Hi everyone, my name is Zandile and welcome to Trigonometry.
Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. Now, if you're currently sitting below 50%, I highly recommend that you start with Solve for X, not because I want to discourage you, but because this section is foundational. And if you understand Solve for X, trust me, everything is going to be easier. And again, in this video, if we come across anything that is related to Solve for X, I'm not going to go deep into it as I'm going to assume the fact that you already know the knowledge. Hope that makes sense why it's very important to basically start with Solve for X. And again, Solve for X is a foundation of every topic because you're going to come across it in every topic that we're going to do from now on, right? Video breakdown. This video is divided into 5 sections. Section 1 is grade 10 and grade 11 foundations. Then section 2 is grade 12 identity and formula. Then section 3 is solving trigonometric equation. Section 4 is trig function. Then section 5 is area, sine, and cosine rule. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I said, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video.
So now what we're going to do, we're going to do trigonometry. And the first thing that we're going to do under trigonometry is defining trigonometric ratio, right? So that's what we're going to do. So the first thing that we need to understand the fact that trigonometry, the only triangles that deals with trigonometry is very important. It's a right angle triangle. Not any other triangle, but strictly what? A right angle triangles. Just remember that. We only can talk about trigonometric ratios if we're dealing with the right angle triangle. So with that said, now let's go ahead with naming the right angle triangle, right? So let me just change my pen right into being blue. So we see the fact that we have a triangle. It's a right angle triangle. So to label it, it's dependent on the what? On the angle where the angle is situated, right? So in here we see the fact that this is theta, right? This is very crucial. The side that is opposite to theta, so if I go from the angle and I go this direction, this is the opposite. The side that's opposite to the angle is called the opposite, right? Then the side that's opposite into this triangle, right, is called the hypotenuse, right? Then when you just do like this, right, when you go down like this is called the adjacent. So that's how we label it, right? So what we're going to do, so it can make sense why I say the fact that we name in reference to what? In reference into the angle. I'm just going to show you another diagram so you can understand what I mean. So what I'm going to do here is that I'm going to split each side into colors. So this one is going to be the yellow one. So let me just highlight it, right? So we're going to name in terms of the angle being theta, right? Which is the one that I highlighted in yellow. So remember the fact that I need to name my sides, right? So as I said, the side that is opposite, so let me just do like this. The side that's opposite to what? To the angle, we're going to call it what? Opposite. So I'm just going to say opposite, just like this, right? So that's opposite. Then what did I say? I say you need the right angle, right? And the side that's opposite to it, we're going to call it hypotenuse. So this is going to be hypotenuse, right? Then what did I say? I said from the angle, if you just go down like this, that's called adjacent, right? So that's that. So I'm just going to highlight the one that is in reference to theta. So this is this one, and this one. So now what I want to deal with this one, right? Which is alpha. This angle is called alpha, right? So what did I say? I said the fact that we name the side with the what? With the reference to what? To the angle. So I'm just going to make my color green, just not to confuse you guys. So now what did I say? I said, let me just do this. I said the side that's opposite to the angle, which is in our case, our angle is theta, is going to be called opposite. So this one, in the reference to alpha, is going to be called what? This is going to be called opposite, right? Then what did I say? I said the side that's opposite to the triangle, to the square, right, which is this right angle, is called the hypotenuse. So the hypotenuse is going to stay the same, but the adjacent is going to be the one that changes. Then from this angle going down like this, going from here and going down, this is now going to be called adjacent, right? So that's how it is. So if I just had to rewrite this triangle, just to show you, and this is going to be A, B, C, right? And this is going to be what? Alpha. Do you see the fact that this is opposite? This is the right angle. This is what? This is hypotenuse. And this is what? This is adjacent, right? Which is exactly what I did in the diagram. So this is how you would name the right angle triangle with reference to what? With reference to the angle that you're given. So now we're going to move to trigonometric ratios, right? So trigonometric ratios, right? It's not meter writing a double S, it's S here, double O. This is S. We just fixed that, right? So with that, right, what we mean when we say trigonometric ratio, we mean the fact that we're going to be talking about sine theta, because that's our angle, right? So the angle comes next to it. Then we're going to say cos theta. Then we're going to have tan theta. That is called trigonometric ratios, right? So we need our right angle triangle to understand what is what, right? So with our sine theta, it's always going to be equals to what? It's going to be equals to what? Opposite over hypotenuse. So your trigonometric ratio for that is going to be opposite, right, over hypotenuse, right? So that's what? That's sine. Then with cos, it's going to be adjacent over hypotenuse. So it's going to be adjacent, right, over hypotenuse. Then for the last one, which is 10, it's going to be what? It's going to be opposite over adjacent. So it's going to be opposite, right, over adjacent. I hope that makes sense. So let me just write it properly here. But this is going to be your trigonometric ratios, right? So just remember just one key thing, especially when you need to remember like the 10 one, right? Opposite is always on top, whether we're dealing with sine or we're dealing with 10, right? So just remember the fact that for sine, it's always opposite over hypotenuse. Then cos is going to be adjacent over hypotenuse. Then 10 is always going to be opposite. So opposite is always on top. And just to remember between these two, just know the fact that they both have hypotenuse in the denominator. I hope that makes sense. So that's the trigonometric ratios. So now we're going to move to calculator skills, right? So these are the following things that we have to do on a calculator. So what I'm going to do is that I'm just going to put on the side a calculator, and then we're going to do everything in a calculator to show you each and every one of them, right? So now what we're going to do, the following, right? So we're going to use calculator skills. So take out your calculators and basically follow what I'm doing, right? So for the first one, it says we need to find cos 48, right? So what's cos 48? On your calculator, there is a cos. Obviously, you need to switch it on. So you're going to say cos. Then you're going to type 48, which is your angle. So you're going to say 48, close your bracket, and you're going to say equals to. And this is going to be your answer. So that's how you're going to find cos 48. Then the next one says we need to, so to clean up, you're going to say here. So the next one says we need to find sine what? Sine 35. So you're going to go to your calculator, press the sine button. So you're going to say sine 35, right? Then you're going to close your bracket. Then you're going to say equals to. So that's going to be your answer, right? Then the next one is going to be what? So clean again is going to be 10 what? It's going to be 1058, right? So you're going to say 10, right? So you're going to say 10, right? Then it's going to be 58, right? So when you close your bracket, that's going to be 1058, right? So that's how you're going to be doing it. So now we're going to deal with number 4, right? So with number 4, this is the following. So number 4 is the following. So we see the fact that we are given what? We are given 10, right? Squared, then it says 81. And we need to find this, right? So whenever you're dealing with something that has whenever you're dealing with trig ratio that's what you call this, that has a power, this is the following that you need to do. So first you need to change this. So how do you change it? We know the fact that 10, 81 all squared is the same as this, right? So you just putting everything inside a bracket and squaring the whole thing is the same thing. So what I mean is the following, because you can get any kind of equation. So if they give you maybe like sine, right, squared, maybe they say 20 degrees, right? So no to the power 3, right? Because I really want to change the value. This does not look like a power, and I do not like that. So if you have it like this, right? So this can be changed as what? As saying sine 20 degrees, right, to the power 3. So whenever you're dealing with a trig ratio that's in the power or has an exponent, just remember the fact that to take in the trig ratio with this angle, then power the whole thing. I hope that makes sense, right? So with this one, punching it into the calculator. So now showing how to show it like punching it in the calculator. The first thing that you're going to do is that you're going to open your bracket. Then you're going to say 10. Then you're going to say 81. So you're going to say 81, right? Close the first bracket because that's for the angle. Then put another bracket because that's for the entire thing. Then you're going to square it. And that's it. So you're going to say equals to, and that's going to be your answer, right? So that's how you would do this question. So now let's do number 5, right? So with number 5, one thing that I want to do is that I actually want to change the power and let it be to the power of 4, right? Let's make it a bigger power, right? So we're going to still take it because we need to like simplify it so we can be able to punch it in the calculator. So number 5, right? Just going to write it here. We see the fact that we have 3 sine, right, to the power 4, right? Then it's going to be 72 degrees. Remember what did I say? If we have anything that it has like when our trig ratio is squared or has an exponent, we need to change it, right? So we're going to just leave the 3 outside because it's not affecting anything. Then you're going to open our bracket. Then we're going to say sine. Then we're going to say 72 degrees. Then we're going to say to the power 4, right? Then this is what we're going to punch in the calculator. So let's do that. So what we're going to do is that we're going to say 3, remember, because there's a 3 in front. Then you're going to open your bracket like that. Then we're going to say sine, right? Then after saying sine, we're going to say what? We're going to say 72, right? Then we're going to close our bracket, then close it again. Then we're going to say to the power 4. So since we only have to the power 2 here, to find the power to the power 4, you click this button. That's going to give you the 4. Then it's going to give you like a square thing. Then you're going to say to the power 4, then you're going to say equals to, right? If you're using the other Casio, right, I don't think they have this button, if I'm not mistaken. To get that 4, what you're going to do is that you're going to just clean this up. Let me just clean it up. I don't want that. So first you're going to say shift. You're going to come here and press there. You see the fact that you're going to have to the power 3, but we need to change it to the power 4. As I said, I think the old Casios don't have this, right? They don't have this one at all. I could be mistaken. But you just go like this. You're going to delete this. Then you're going to say 4. Then you're going to say equals to. So you're still going to get the same value. So this is how you would do it, right? So this is how you would find number 5. So now doing number 6, we don't need to clean up anything. So what to do number 6, you're basically going to go to your calculator. You're going to first press the fraction because that's what you have. Then you're going to say 5, then you're going to go down and you're going to say 6, right? Then what you need to do is that you need to open a bracket because it's multiplying the whole thing, right? And just start loving brackets because this is going to simplify your lives, to be honest. Say 10, then what you're going to have is 34. So you're going to say 34, then you're going to close because you're going to close the angle, then you're going to close the entire bracket. Then you're going to say equals to, and you're just going to get number 6. So now what I want to talk about special angles, right? So with special angles, it's very crucial for you to understand this 2 right angle triangles this is where your special angles comes from, right? So the 3 special angles that you need to know off by heart, the minute they ask you a question and it has this 3 angles, right? Just know the fact that we're dealing with special angles. It's the 30 degrees, it's the 60 degrees, and it's the 45, right? And how would you know the fact that the question is still with special angles? Is that it's going to tell you the fact that without a use of a calculator. If you see 30, 60, and 45 in your question, and the question says without a use of a calculator, your head needs to go, oh, I'm dealing with a special angle. And these triangles, right, are your best friends. Please know these 2 triangles, right? If it means 5 minutes before you write, or on your way to school, you climb how this triangle looks, let it be. And the first thing that you do when you get to the test, right, draw these triangles. When they say start, quickly replicate these triangles on the question paper anywhere so that you don't forget, because this is just basically easy maths, right? So the first thing that the question that we're going to do is we're going to do a question that deals with this triangle. We're going to put it in action, right? So do you see the fact that the question says without a use of a calculator, showing all you're working out, right? They say determine the value of, and they give you this, right? So let me just do this question. Let me just rewrite it here. So we know the fact that we have chord squared 60 degrees, right? And this is multiplied by 1045 degrees. Then this is multiplied by sine 30 degrees, right? And this is divided by what? This is divided by cos 60 degrees, right? So remember the fact that if we're dealing with something that is squared, when the trig ratio is squared, we need to change it. So let's do that. So we're going to first change that. So we know the fact that it's going to be cos 60 degrees, right? And this is going to be all squared, right? And this is going to be what? This is going to be 10. Then this is going to be 45. Leave that. Then this is going to be sine 30 degrees, right? And this is going to be what? Divided by cos 60. So it's going to be divided by cos 60 degrees, right? So remember the following. Remember the fact that we know the following. We know the fact that sine, do we have sine? Yes. We know the fact that sine of an angle, which is, I'm going to call it theta, is equals to what? To opposite over hypotenuse, right? So over hypotenuse. Let me just write this in a different color. So we know the following, and I'm just going to write it here. So I'm just going to do it in green. So we know the following. We know the fact that sine, right, theta, which is the angle, is equals to opposite over hypotenuse, right? I'm just going to call it opposite over hypotenuse, which is OH, right? So then we know the fact that cos theta is equals to what? To adjacent over hypotenuse, right? Then we know the fact that tan theta is equals to opposite over adjacent, right? So now we know the fact that these are the trig ratios. Now I'm going to write the the reciprocal. So we know the fact that cosec, right, which is this one, for sine, the reciprocal of sine is going to be adjacent over opposite. Then we know the fact that sec theta is equals to what? It's basically going to be equals to hypotenuse over what? Over adjacent. Then cot theta is going to be equals to what? It's going to be equals to adjacent over opposite, right? So we know this. We're going to need this trig ratios to basically solve here, right? So let me go back and take my pen. So the first one we have what? We have cot 60, right? Which is the 61? This is going to be the 61. So 60 is our reference angle, right? We know the fact that this, labeling the diagram, we know from 60, this is going to be what? This is going to be opposite, right? And this one is going to be what? This is going to be the hypotenuse, right? So this is going to be the hypotenuse, and meaning this is going to be what? This is going to be adjacent, right? So that's for 60 degrees, right? So this is going to be for 60. So 60 is going to be for the blue one. Then for 30, I'm just going to change the color. I hope that makes sense, right? So for 60, it's going to be this one, right? So we know the fact that we're dealing with cot 60. Cot 60, it says what? It says adjacent over what? Over opposite. So we know the fact that adjacent is 1. So for this one, it's going to be open bracket, it's going to be 1, right? Divided by what? Remember, it's adjacent over our opposite. So opposite is root 3. So it's going to be root 3. Just like this, then we're going to say all squared, right? And this is going to be multiplied by what? We need 1045. So the 45 here, it's either you can use this one or this one. So I'm just going to use this one, right? So with that one, 45, remember the fact that I need to label the diagram. So this is going to be opposite, right? So this is going to be the opposite side. And this is going to be the hypotenuse side, right? And this is going to be adjacent like this. So it's going to be adjacent, right? So remember the fact that 1045 is what? Is opposite over adjacent. So it's going to be the same as what? As 1 divided by what? Divided by 1. So it's going to be 1 divided by 1. Then this is going to be just for this one. So I'm sorted with this one. I'm sorted with this one. So now I'm going to go to sine 30. So remember that sine 30 is in the same diagram as 60. So I'm just going to take a different color so that we can talk about it. So we know the fact that this is the reference angle. Our reference angle is 30. So opposite to 30 is this one, right? So this is going to be opposite, right? Right? Then we know the fact that our hypotenuse is going to be the same. So this is going to be still hypotenuse, right? Which is opposite to the square. Then adjacent is going to be here. So it's going to be adjacent, right? So remember the fact that we're looking for what? Let me just change my pen. We're looking for sine 30, right? Sine 30 is what? Is opposite over hypotenuse. So what's my opposite? My opposite is 1, right? Remember the fact that we're looking at the green one, not the blue one. So opposite is 1. So this is going to be the same as opposite, which is 1. So it's going to be 1 divided by what? By the hypotenuse, which is going to be 2. So this is going to be that. So we're done with the numerator. So now going back to the denominator, going to the denominator. Denominator says cos 60 degrees. Cos 60 degrees, it's from this diagram that shares with 30, but now we're looking for the blue one, right? So we know the fact that cos is adjacent divided by the hypotenuse. So adjacent is 1. So it's going to be open bracket, it's going to be 1. Then hypotenuse is going to be 2. So it's going to be like this, right? So now let's simplify this. Remember, without the use of a calculator, when we distribute the square here, so we know the fact that this is going to be the same as 1 squared divided by root 3, right, all squared. And this is going to be multiplied by 1 divided by 1 is going to be the same as 1. And this is going to be multiplied by 1 over 2, right? And this whole thing is going to be divided by 1 over 2, right? So this one, let's simplify that. So it's going to be the same as 1 divided by 3, right? Multiplied by 1, then multiplied by a half, right? So, and this whole thing is going to be divided by what? Divided by 1 over 2. So since we're dealing with what? Since we're dealing with, which was everything in the numerator is multiplying, and there's a fraction, we know the fact that these 2 are going to cancel out. So we're going to be left with what? We're going to be left with 1 over 3 multiplied by 1, which is going to be the same as 1 over 3. So your final answer here is going to be 1 over 3. So this is us solving without a use of a calculator. So now what we're going to do is we're going to solve we're going to be finding angles, right? So it's the same as like solving trigonometric equations. But in our case here, the unknown value is what? It's actually our angle, right? So with this one, this is the following things that you're going to do. So you're going to do the following. We know the fact that we have, First thing first, you need to label the diagram in reference to the angle. And which in our case, the angle is not given, it's the unknown. So we need to label in reference to the unknown angle. So we know the fact that this is going to be the side that's opposite to the angle, which is this one. It's going to be called opposite, right? The one that's opposite to the square is going to be called the hypotenuse, right? And here it's going to be called the adjacent, right? So what do we see? We see the fact that we are given the following. We are given this and this, which is opposite over adjacent, right? So we see the fact that we're given this 2 and we're looking for this. So let's find our trig ratios. So we know the fact that it's sine theta is equals to what? To opposite over hypotenuse. Cos theta is equals to adjacent over hypotenuse. Then tan theta is equals to what? Is equals to opposite over adjacent. So we see the fact that we're looking for one that has opposite and adjacent, because that's the two things that they gave us. We can use 10, right? So this is going to be the same as having 10 theta is equals to opposite over adjacent, right? So we see the fact that theta is the one that's unknown, right? And opposite is equals to what? Is equals to 50. Then adjacent is equals to what? Adjacent is equals to 100, right? So now let's substitute. So we know the fact that's going to be cos theta is equals to what? It's equals to opposite is going to be 50 divided by what? Divided by 100, right? So now we need to solve for theta. So how do we do that? We're going to say theta is equals to arc10, right? Right? This is called arc10, and this is going to be 50 divided by 100, right? So now I'm going to show you how to do this in the calculator, how to find this value in the calculator. So now what you're going to do, you're going to take your calculator. Then what you're going to do is you're going to switch it on, obviously. Then to find arc10, you need to say shift, right? And for all of them, to find the arc10 of sine, cos, and 10, you're going to do the same thing. You're going to say shift, then you're going to press 10, right? And it's going to give you this. Then you're going to write whatever you're given here, which is in our case is going to be 50, right? Divided by what? Divided by 100. And you're going to go here and close your bracket, and this will be your answer. So this is going to be your angle, right? So that's how you would find it. So for this one, let me just change my pen. Your angle, right, is going to be what? It's going to be 26,5, right? 57, because I'm rounding off to the second decimal place. We just fix that. So it's going to be 57, 57 degrees. And that's how you would find theta for this question. So now what we're going to do is we're going to do trigonometry, right? We're going to start with trigonometry. But the first thing that we're going to start with is Cartesian questions, right? So with Cartesian questions, the first thing that you need to understand is the diagram and everything that has to do with the diagram and how to basically draw your triangles, right? So this is how you would basically do a trig ratio in Cartesian, but I prefer using the normal one, which is sine and theta. We know the fact that that's equals to opposite over hypotenuse. Then cos theta is equals to adjacent over hypotenuse. Then we have what? We have 10 theta, which is going to be equals to what? Which is equals to opposite over adjacent, right? So I'm just going to draw a triangle to show you on how to label the following, because of it's very crucial to know where is opposite, where is hypotenuse, and where is what? Where is adjacent, right? So this only works in right angle triangle. So this needs to be a right angle triangle. And let's say our theta is here, right? Opposite is always the angle that's opposite to the, what you call this? The side that's opposite to the angle. So this is going to be opposite, right? So this is going to be regarded as opposite. Then adjacent, if you take your angle and you just go down like this, right? The side that you meet, that's going to be adjacent, right? And then hypotenuse is going to be always the one that's opposite to your right angle, right? Which is this 90 degrees. This is going to be what? This is going to be, this side is going to be hypotenuse, right? I hope that made sense. So that's how you would know which one is opposite, adjacent, and hypotenuse, right? So with that said, now let's move to the Cartesian plane and know, and talk about how to label it, right? So do you see the fact that we have point P, and with point P, both X and Y are what? Are positive, right? So this X value is always going to be the side. Do you see the side of the triangle? And it makes sense. Do you see the fact that it's on the X-axis? So this is going to be X. Then Y is always going to be the dotted line. So this is going to be Y, right? So this is going to be Y. Then R is going to be the hypotenuse, which is this one, right? So one more thing is that R is always positive. Then X and Y is negative or positive depending on which quadrant we're in, right? So now let's move to the second quadrant. So this is going to be the first, the second, the third, and this is going to be the fourth quadrant, right? So if we move to the second quadrant, which is going to be this one, right? So let's say we have point Q, right? And point Q, because it's in the second, meaning x is negative, then y is positive, right? So you always take that point and connect it to the origin like this. Then you're going to draw your dotted line, creating the right angle triangle. Very important, your dotted line is always going to touch the x-axis, never the y-axis. So this is wrong. It's always going to touch the x-axis, right? Very important, it always touches the x-axis, never the y-axis, right? So this is going to create what? A 90 degrees, which is a right angle triangle, and theta is going to be here, right? So now let's label this diagram. So this is going to be negative what? This is going to be negative x, right? And this is going to be y, then r is going to be here. Do you see the picture? Because if we're in the second quadrant, your x is negative, right? So now let's draw a point in the third quadrant. So here, let's call this point what? Let's call this point W. And here, both x and y are negative, so it's going to be negative x and negative y, right? So connect it with the origin, so it's going to be like this. Then we're going to draw a dotted line going to the x-axis, right? And this is going to be 90 degrees. So now this is going to be what? This is going to be negative y, and x is already labeled in r here, right? So that's how you would label it, and theta is going to be here, right? So theta is always from the origin. Do you see that? Theta is always from here. It's never here. It's always from here, right? So now we're going to go here. So let's name this x, right? So this is going to be what? This is going to be positive x and negative y, right? So connect them. So it's going to be like this. Draw going to the x-axis, right? Then 90 degrees. Then label it. X is going to be here. Then y is going to be negative y here. Then it's going to be r. So theta is going to be here. So this is how you would label your diagram, right? Or label your triangle depending on which quadrant you're in, right? So now we're going to talk more about the cast diagram, because there's going to be some questions that you're going to need to know the cast diagram, right? So this is the cast diagram where this is A at 0 degrees, 90 degrees, 180, 270, and 360, right? Then what's important here is to know where your trig ratios are positive and negative. So in the first one, it says all, meaning sine, cos, and tan are both positive. So all of them. Here only what? Only sine is what? Is positive. Here only tan is positive, and here only cos is negative, right? Meaning here, what it means, the fact that cos is negative, right? And also tan is negative, right? Here it means that sine is negative and cos is negative, right? So here it means what? It means the fact that sine is negative and also tan is negative, right? And here it means the fact that all of them are positive. So sine is positive, cos is positive, and also tan is positive, right? So to remember it, just remember is all students take coffee, right? So this is the cast diagram. Just remember it because we're going to use it in other questions when we're doing the example. So next up is going to be what? It's going to be the first example. So now let's do example 1, right? It says P, which is negative 3 and 4, is a point on the Cartesian with an origin O, right? Theta is the angle between OP and the positive x-axis. Then they say without the use of a calculator, determine the following. So let's do the cast diagram, right? Let's draw the Cartesian, not the cast diagram. So let me just change, just want to use a different color. So it's going to be this. So I'm just going to draw it here. So it's going to be like this, right? So it's going to be like this. Then we see the fact that it's negative. So it's negative x. So it's going to be here, and it's a positive y. So it's going to be in the second quadrant. So it's going to be here. Point P is going to be here, which is negative 3 and 4, right? Then the point needs to connect it with what? With the origin. So you're going to go like this, right? And you're going to draw a dotted line going to the x-axis. And this is going to create a 90 degrees. And theta, because we're dealing with theta, it's going to be here. So let's label the diagram. We know the fact that negative 3 is the x-axis. Then the y is going to be 4, right? Which is going to be always the dotted line. Now we need r, right? So to find r, we're going to use theorem of Pythagoras. So it's going to be r squared is equals to x squared plus y squared, right? So now we're going to say what? R squared is what we're looking for. We're looking for r. then x squared is going to be what? It's going to be negative 3 all squared plus 4 all squared, right? So 3 squared is going to be equals to what? It's going to be equals to 9. So it's going to be r squared is equals to 9 plus 16, right? So it's going to be plus 16 because of that's 4, right? If you say 9 plus 16, you're going to get 25. So r squared is going to be equals to what? To 25. Then r is going to be equals to what? It's going to be equals to the square root of 25, which is going to be 5. Remember that r is always positive, so 5 is going to be here. So since now our diagram is complete, we can go and answer the questions, right? So number 1, it says what? We need to find cos theta, right? What do we know that's cos? Cos is adjacent over hypotenuse, right? So what's adjacent here? Adjacent is negative 3, then hypotenuse is 5. So we are done with that one, right? Number 2 is going to be what? It's 3 tan theta, right? So it's the same as saying 3 open bracket opposite over adjacent for 10. So substitute, it's going to be 3. Then it's going to be what? It's going to be opposite, which is going to be 4. From the diagram, it's going to be 4. Divided by what? By adjacent. Adjacent is negative 3, right? So here, when you simplify it, you're going to get your answer to be what? To be negative 4. So that's going to be your answer there. Then number 3, it's going to be what? It's going to be sine squared theta. We can rewrite this as what? So that we can work with it in a simpler way. It's the same as saying sine theta is equals to, what you call this, inside a bracket all squared, which is going to be what? Sine we know is opposite over hypotenuse. So this is going to be all squared. What's opposite here is 4, right? Divided by what? Hypotenuse, which is 5. And this is going to be all squared. So it's going to be what? 4 squared is going to be what? It's going to give us 16, right? Then 5 squared is going to give us 25. So that's going to be your answer for this one. Then number 4 is going to be what? It's going to be 4 cos cubed theta, which is going to be equals to what? 4. Then this is going to be the same as cos theta to the power 3. So this is the same as what? As 4. Open bracket, what? Our cos is adjacent over hypotenuse. So this is going to be all cubed. So this is the same as what? This is the same as 4. Open bracket, what? Adjacent. Adjacent is negative 3. Divided by what? Divided by hypotenuse, which is 5, right? So what is to the power 3? Forget that. So this is going to be 4. Open bracket, what is? Remember, it's 3 cubed, right? We're going to get that to be negative 27, right? And what is 5 cubed, right? Which is going to be 125, right? So multiply that. So you're going to say 4 multiplied by negative what? Negative 27 divided by 125. So your answer is going to be equals to negative negative 108, 108, yes, divided by what? Divided by 125. So that's how you would do example 1, right? So now let's move on to number 2, right? So number 2, it says sine theta is equals to 0,4. So if they give you a decimal number, just change it to being a fraction, right? It's easier to work with the fraction. And they tell you one extra information. They tell you that theta needs to be an obtuse angle, right? So first, let's deal with the sine. So we know the fact that sine theta is equals to 0,4, right? To change this into being what? Into being a fraction, go to your calculator and say 0.4, then say equals to, it's just going to give you a fraction, right? So you're going to say sine theta is going to be equals to what? To 2 divided by 5, right? So that's how you would find what? That's how you would find your fraction, right? So what do we see? We see the fact that here our sign is positive, right? So let's draw a Cartesian plane. So you're going to draw a Cartesian plane here, right? And we know the fact that this is all students take coffee, right? Where is sign positive? It's positive in the first and in the second quadrant, right? But they tell us the fact that theta needs to be an obtuse. If we pick the first quadrant, do you see the fact that our theta is going to be an acute? So this is not what we want. But if we pick the second quadrant, do you see the fact that our angle here, let me just erase this one, right? Do you see the fact that our angle theta here is going to be what? It's going to be obtuse. Do you see that? So this is going to be obtuse. That's going to be our theta. So our second quadrant is going to be where, right? So this is going to be where our triangle is going to be. So draw a dotted line like this. Then I'm just going to move this theta here so we can work with the triangle properly, right? So let's erase that part. Let me just erase this part, right? I want it inside the triangle so I can work with it properly, right? So now we know the fact that this is 90 degrees. This is what? This is the same as what? As opposite over hypotenuse. So opposite, it's going to be what? It's going to be 2. Hypotenuse is going to be 5 here. Do you see the fact that we're missing x, right? So we're going to find it by using Pythagoras. So it's going to be r squared is equals to x squared plus y squared. Substitute is going to be what? It's going to be 5 all squared. It's equals to what? It's equals to x squared is what we're looking for. Plus what? Plus 2 squared, right? So this is going to give us what? 5 squared is going to give us 25. So it's going to be 25, right? Is equals to x squared. Then it's going to be 2 squared, which is going to give us 4, right? So this is going to be plus 4, right? Take the 4 to the other side. You're going to have 25 minus 4, which is going to give you 21. So you're going to have 21 is equals to x squared, right? Square root both sides is the same as x is equals to plus or minus root 21, right? But do you see the fact that our x is in the negative? So x is going to be equals to negative root 21. So here it's going to be negative root 21, right? So now that's sorted. So now we're going to do the first one. It says we need to find cos theta. Cos theta is the same as what? It's adjacent over hypotenuse. What's our adjacent in the diagram is negative root 21. Then hypotenuse is divided by 5. So that's how you get your answer. Then number 2 is root 21, right? Then that's multiplied by 10 theta. So this is the same as root 21, right? Then open bracket, what is 10? It's going to be opposite over adjacent, which is going to be what? Root 21. Substitute, so it's going to be opposite, which is going to be 2 over adjacent, which is negative root 21, right? The root 21s are going to cancel out, so your answer is going to be equals to negative 2. So that's how you would do number 2. So now we're going to do example 3, right? It says now, given that theta is equals to t divided by 2, then they tell you the fact that theta needs to be between 0 and 90, right? They say determine the following in terms of t, right? So first, let's draw our Cartesian plane, right? So we know the fact that this is all students take coffee, right? Where is 10 positive in the first quadrant and in the second quadrant, right? But very important, they tell us the fact that our angle needs to be between 0 and 90. So this is going to be 0, this is going to be 90, this is going to be 180, this is going to be 270, and this is going to be 360. So do you see the fact that our angle needs to be where? It needs to be in the first quadrant. So this one we're not going to use, we're only going to use this one, right? So we're going to use the first quadrant because of it meets both our condition. 10 is positive and theta is between 0 and 90. So this is where our triangle is going to be. Then this is where it's going to be, right? So we know the fact that we're given that this is 10 theta is equals to what? Is equals to t divided by 2, which is the same as opposite over adjacent. So what is opposite? Opposite is going to be t, which is going to be here. Adjacent is going to be here, and theta is here, right? So now we need r. So to find r, it's going to be r squared is equals to x squared plus y squared, right? Let's substitute. It's going to be r squared is equals to x is going to be 2 all squared plus t squared, right? So this is going to be r squared is equals to 4 plus t squared. Then now we're going to square root both sides. So r is going to be equals to positive 4 plus t squared. Remember that r is always positive. So here's going to be what? It's going to be the square root of 4 plus t squared, right? So our diagram is complete now, right? So we're looking for cos squared theta, which we can rewrite it as cos theta is equals to what equals cos theta all squared, right? So now this is going to be equals to what? What is cos? Cos, we know the fact that it's adjacent over hypotenuse. Then this is going to be all squared. What's our adjacent? Our adjacent is 2 over hypotenuse is going to be the square root of what? Of 4 plus t squared, and this whole thing is squared, right? So distribute the square root, so it's going to be what? It's going to be 2 squared, then divided by what? By the square root of 4 plus t squared, then this is going to be all squared, right? So this is going to give us what? 4 divided by what? By 4 plus t squared. So this will be your final answer for this question. So now we're going to move to example 4, right? We are given the fact that it's 10 cos beta plus 8 is equals to 0. Then they tell us the fact that beta needs to be between 180 and 360. Then we need to determine the following, right? So one important thing here is that we need to make sure the fact that the trig ratio is alone, right? It should never have a coefficient in front of it. It needs to be alone. So let's simplify this, making the trig ratio alone. So, right, we know the fact that we have 10 cos beta plus 8 is equals to 0. Take the 8 to the other side, so you're going to be left with 10 cos beta is equals to negative 8, right? Divide both sides by 10, so it's going to be cos beta is equals to negative 8 divided by 10, right? So now we sorted. We see the fact that our cos is negative, right? So now let's draw the Cartesian plane. So we know the fact that it's going to be like this, right? Then we know the fact that this is all students take coffee. Where is cos negative? It's cos negative in the second and in the what? In the second and in the third quadrant, right? So what do we see? We see the fact that we have a restriction. So this is 0 before 90 degrees. This is 180. This is 270. And this is 360, right? So we see the fact that our angle needs to be between 180 and 360. So this one is out. So our Cartesian plane, our triangle needs to be here, right? Triangle needs to be here because it satisfies both this that causes negative and also beta being what? Being between 180 and 2 and 360, right? So this is going to be 90 degrees, right? So remember, this is the same as what? Is adjacent over hypotenuse. So adjacent, so this is going to be beta here. So adjacent is going to be here, so it's going to be negative 8. Then hypotenuse is going to be here, which is 10. So what's missing is going to be y, right? So we're going to find y using theorem of Pythagoras. So it's going to be r squared is equals to x squared plus y squared, right? So let's substitute. It's going to be what? It's going to be 10 squared is equals to what? 2x is the one, x we have it, so it's going to be negative 8 all squared plus y squared, right? What is 10 squared? 10 squared is 100, so it's going to be 100 is equals to negative 8 squared is going to give you a positive 64, so it's going to be 64 plus y squared, right? So it's going to be 100 minus 64, which is you're going to get what as being 36. So it's going to be 36 is equals to y squared, right? Square root both sides, so it's going to be 36. So it's going to be what? It's going to be y is basically equals to plus or minus 6, right? So where is y? Do you see the fact that y lies in the negative y-axis? So you know that y is going to be equals to negative 6. So this point here, this line here is going to be negative 6. So now our diagram is complete. We can go and answer the following questions, right? So number 1 is what? It's finding cos beta, right? What's cos? It's already given here. So this is going to be negative 8 divided by 10. So you sorted, right? So number 2 is what? It's 3 divided by what? By 10 beta, right? And that's going to be plus 2 sine squared beta, right? So I'm just going to rewrite it so that it's going to be simple for me to basically substitute. So this is the same as saying 3 divided by what? By 10 beta. And this is going to be plus, this one is the same as saying sine beta. This is going to be all squared, right? So let's change the 10 beta and sine beta. This is going to be the same as 3 divided by what? By. This is going to be the same as what? This is opposite over adjacent. And this is going to be plus 2. So this is going to be opposite over hypotenuse, and this is going to be all squared. So now let's substitute. It's going to be 3 divided by what? What's opposite? Opposite is negative 6. Then adjacent, it's negative 8, right? So This is going to be plus. This one is going to be 2. Then what's opposite is negative 6. Then hypotenuse is 10. And this is going to be all squared, right? So let's simplify this one. It's the same as 3, right? Then it's going to be what? Divided by what? Divided by 6 divided by 8, right? So here it's going to be what? It's going to be plus. Then this is going to be what? This is, you're going to square this. So it's going to be negative 6, right? Divided by what? By 10. Then that's going to be all squared, right? So when you do that, you're going to have the fact that here you're going to have 9, right? Divided by 25, right? So this is going to be what? So when you punish that, if you say 3 divided by what? By 6 divided by 8, you're going to get that this is 4. Then if you say 2 multiplied by what? By 9 divided by 25, you're going to get your answer as being what? So this is going to be plus 18 divided by 25. Add them together. So you're going to say 4 plus 18 divided by 25. You're going to get your answer as being what? As being 118, right? Divided by 25. And that's how you would do this question. So now let's do example 5, right? It says if sine theta is equals to negative 15 divided by 17, and they tell you the fact that cos theta is less than 0, meaning it's negative, right? Then it says find the following without a use of a calculator. So first let's draw the Cartesian, right? So we know the fact that the Cartesian is going to look like this, right? First, we see the fact that our sign is negative, so it's going to be all students take coffee, where sign negative is negative here and here. But one more condition, it says they want cos to be also negative, so this one is going to be the one that we're going to use. Then this one is where cos is positive, so it's not going to meet this restriction. So we're going to use the third quadrant, so it's going to be here. So a triangle is going to be here like this, right? So this is going to be 90 degrees, right? Then theta is going to be here. So we see the fact that sine, right, theta is equals to negative 15 divided by 17, right? This is the same as opposite over hypotenuse. So what's opposite? Opposite is negative 15, so negative 15 is here. Hypotenuse is 17, which is going to be here. So we are missing what the x-axis. So let's do it, finding what? Using the trig ratio, right? So using theorem of Pythagoras, that's what I meant. So it's going to be r squared is equals to x squared plus y squared, right? Let's substitute. It's going to be 17 all squared is equals to what? X is the one that we're looking for, plus y, which is negative 15 all squared, right? So it's going to be 17 squared, which is going to give us 200 and what? And 89, right? Is equals to what? To x squared. Then it's going to be negative 15 all squared. It's going to give us plus what? Plus 225, right? If you say 289 minus 225, you're going to get that this is equals to 64 is equals to x squared. Square root both sides. So it's going to be the root of 64, which is going to be 8. So x is going to be equals to plus or minus 8, right? So where is our triangle? Do you see the fact that it lies on the negative x-axis? So your answer here is going to be x is equals to negative 8. So here is going to be negative 8. Then you are done with filling in your triangle, right? So now we can go and answer the question. So number 1, it says find cos theta. What's cos is what? It's adjacent over hypotenuse, right? So what's our adjacent? Adjacent is negative 8. Hypotenuse is 17. So you sorted with that one, right? Number 2 is going to be 10. Theta is equals to what? It's equals to opposite over adjacent. What's opposite? It's negative 15. Adjacent is negative 8. So your answer is going to be positive 15 divided by 8, right? So that's how you would do that one, right? So now you're going to do number 3, right? Number 3 is what? It says cos squared theta plus sine squared theta. So this is the same as what? This is the same as cos theta all squared plus sine theta all squared, right? So we know the fact that cos is what? It's adjacent over hypotenuse all squared plus what? Plus opposite over hypotenuse all squared. Let's substitute. What's adjacent? Adjacent is 8, so it's going to be negative 8 divided by what? Divided by 17 all squared plus what? Plus negative 15, which is opposite, divided by 17. Then this is going to be all squared, right? So what? Negative 8, right? Divided by 17, right? Squaring the whole thing. So let's square the whole thing, right? It's going to give you what? It's going to give you the fact that this is 64, right? Divided by 289, right? So this is going to be plus, if you say negative 15, right? Divided by 17, you're going to get 200 and what? 225 divided by what? By 289. Since the denominators are the same, this is the same as adding the numerator. So you're going to say 64 plus 225, which is going to give you 289 divided by 289, and that gives you 1. So this will be your final answer. So now we're going to do example 6, right? It says, if 17 cos theta is equals to negative 8 and 10 theta is greater than 0, meaning it needs to be positive. They want 10 to be positive. Determine the following with an aid of a diagram, right? Not in a calculator. So now let's first make sure the fact that the trig ratios are known. So it's going to be 17 cos theta is equals to negative 8. Divide both sides by cos. So it's going to be what? It's going to be cos theta is equals to negative 8 divided by 17, right? So this is our cos, and we see that our cos is negative, right? So draw the Cartesian plane. And we know the fact that this is all students. Take what? Take coffee. So where is cos negative? It's cos negative in the second and in the fourth. But very important, they want our 10 to be positive. So this is where it's going to be. So this one is not going to be there, because here our 10 is going to be negative. So we're going to use the third quadrant, right, to draw our triangle. So this is it, right? So we know the fact that this is the same what? It's the same as adjacent over hypotenuse, right? So theta is going to be here. Where is adjacent? Adjacent is going to be here. So it's going to be negative x. Then this is going to be 17. So here we'll be looking for what? For y. So using theorem of Pythagoras, it's going to be r squared is equals to x squared plus y squared, right? Substitute what's r squared? R squared is 17. All squared is equals to x squared. It's going to be negative 8. All squared plus y squared, right? So it's going to be 17 squared, right? Which is going to be 289. Then 8 squared, right? It's going to be what? It's going to be 64. So it's going to be 64 plus y squared, right? So it's going to be 289 minus 64, which is going to give us 225 is equals to y squared. Square root both sides. So it's going to be 225. Then this is going to give us y being equals to plus or minus 15. Where is our y? It lies on the negative y-axis, so y is going to be therefore equals to negative 15. So here's going to be negative 15. So now our diagram is complete. We can go and answer the questions, right? So number 1, we're looking for cos theta divided by sine theta. I'm going to rewrite it as this one. I'm going to rewrite it as cos theta divided by sine theta, right? So when I do that, it's going to be what? This one is going to be what? It's going to be cos is what? It's adjacent over hypotenuse. Then this is going to be divided by what? By opposite over hypotenuse. So let's substitute. So substituting is going to be what? Adjacent is negative 8. So it's going to be negative 8 divided by what? By 17. Then this is going to be divided by what? By opposite, which is going to be negative 15 divided by 17, right? So now I'm going to change this division into a multiplication. So this is negative 8 divided by 17. Multiply your next term. Your numerator becomes your denominator, right? And your denominator becomes your numerator. So this is going to be the same as what? It's 17 divided by negative 15. So the 17s are going to cancel out. So you're going to be left with negative 8 divided by negative 15, which is going to give you 8 divided by 15. So that's going to be your answer for this question, right? Then for number 2, we're looking for what? For 17 sine theta, right, minus 16 10 theta. So this is the same as 17. Then sine is what? It's opposite over hypotenuse, right? Minus 16. Then this is what? This is opposite over adjacent. So let's substitute. This is going to be 17. What's opposite? Opposite is negative 15. Hypotenuse is 17, right? So this is going to be minus 16. Then it's going to be opposite is negative 15. Then hypotenuse is going to be what? It's going to be negative 8, right? So now let's simplify this one. The 17s are going to cancel out. So you're going to be left with negative 15, right? So here, if you multiply this whole thing into your calculator, if you say negative 16, open bracket, and you say negative 15 divided by negative 8, right? You're going to get the fact that you're going to get negative 30, right? Add them together, you're going to get negative 15 minus 30, which is you're going to give us what? Which is going to give us negative 45, right? So the trick here, they say without the use of a calculator, don't punch the whole thing inside your calculator. Just show small steps, right? Show small steps so that you can look like you did not use a calculator, but you all know that you did use a calculator. Just show small steps. Don't get here and basically punch this whole thing in the calculator. It's going to show the fact that you didn't show you're working out. So that's how you would do example 6. So now we're going to move to identities, right? With identities, we're going to start with grade 11 identities, which are these two, which is the quotient's identity and also the square root, which was the square identity, right? So I'm going to have my identities on this side. So pro tip is that when you're doing anything that has to do with trigonometry, please write all your identities on the side. As we proceed, you'll see the fact that I'll be adding more identities, right? Make sure you have your identities on the side. And the reason is that so that you can know which best one to use for the scenario that you're doing, right? So now we're going to do example 1 that deals with only grade 11 identities, right? They say simplify this, right? So how are we going to simplify it? We see the fact that we have this question. We have 10 squared theta multiplied by cos squared theta. What do we see? We see the fact that we can change this 10 into this one, right? So one thing about the 10 is that it really doesn't matter if we have a squared or cubed in anything. We can still rewrite this whole identity in terms of what you call this. Since this is 10 squared, we can rewrite it as sine squared theta and cos squared theta, right? So let's do that. So we know the fact that 10, let me just rewrite it. Let me just do this, eraser, right? And I want to change my pen. So we see the fact that we have 10 squared theta, right, multiplied by cos squared theta, right? So as I said, the fact that the best one to use is this one, right? That is the best one in this scenario is going to be this one. So it's going to be what? We're going to replace that. So it's going to be what? It's going to be sine, right, theta divided by cos theta. And remember the fact that this is all squared. And this is going to be multiplied by cos squared theta. So this is going to be the same as what? This is the same as sine squared theta divided by cos squared theta. And this is going to be multiplied by cos squared theta, right? Do you see the fact that your cos are going to cancel out? So you're going to be left with sine squared theta. And this will be your final answer, right? Do you see the fact that if you have your identities on the side, it's very easy to know which one is going to be the best one to pick in the scenario, right? So that's that, right? So now we're going to move on to what? To example 2, right? So one more thing is that we can actually rewrite the square one into 2 identities. So we can basically make sine squared theta the subject. So you can say sine squared theta, right, is basically equals to 1 minus cos squared theta. Then you can write cos as being the subject. So it can be cos squared theta is going to be equals to 1 minus sine squared theta, right? Because sometimes in the question we might be able to use this ones, right? So just make sure the fact that after writing this one, you write the extended version of it, making sine squared theta as the subject and cos squared theta as the subject, right? So we have this equation, we need to simplify it, right? We have, let me rewrite it, 1 divided by cos squared theta, right, minus 10 squared theta divided, yeah, that's it, right? So here, the first identity that I see that I can use is again the 10 one, right? So this is going to be the same as, remember the fact that this 10 squared theta is the same as saying what? As saying 10 theta all squared, right? So it's going to be the same as 1 divided by, I'm just going to leave this one, so it's going to be equals to cos squared theta. Then this is going to be minus, this is, the identity is sine theta divided by cos theta, right? But remember that it's all squared, right? Distribute the square, so it's going to be what? It's going to be 1 divided by cos squared theta, right? And this is going to be minus sine squared theta divided by cos squared theta, right? Do you see the fact that the denominator is the same? So I can add the numerator. So this is going to be the same as 1 minus sine squared theta. And this is going to be divided by what? By cos squared theta, right? So do you see the fact that now I can basically use this identity here? Do you see the fact that this is the same as this one? Do you see that? So I can replace the 1 sine squared theta by cos, right? So let's do that. So it's going to be now, it's going to be cos squared theta divided by what? Divided by cos squared theta. Since the numerator and denominator are the same, so this is the same as equals to 1. So this is how you would do this equation. So now this equation is proving, right? So what proof? We need to prove that the left-hand side, right, is equals to, the left-hand side is equals to the right-hand side, right? So first what you need to do is basically you need to take the more complex side and try to simplify it to match it up with the other side, right? In our case, both the left and right-hand side are basically the same, right? So what we're going to do here, we're going to take the left-hand side, try to simplify it, and also take the right-hand side, try to simplify it so they can be equal to each other, right? So I'm going to take the left-hand side, which is going to be what? Which is going to be 1 minus sine alpha divided by what? By cos alpha. So looking at this, there's nothing much we can do, but what we could do is that we need to rationalize, right? So rationalize, I'm going to take the denominator, right? And basically multiply it by the conjugate, right? What's the conjugate of 1 minus sine theta? So conjugate is that if you have 1 minus sine theta, is in our case, the conjugate of it, right, is going to be what? It's going to be 1 plus sine theta. It's just changing the sign, right? So this is going to be the conjugate. So we're going to multiply by the conjugate. So it's going to be minus, multiply by what? By 1 plus sine alpha, right? Divided by 1 plus sine alpha, right? So that's the conjugate. And the nice thing about conjugate is that this is going to create a difference of 2 squared. So we can square the first term and the second term to basically get when we multiply, right? So this is going to be equals to multiplying numerator and denominator to denominator. So it's going to be 1 minus sine alpha, right? Multiplied by 1 plus sine alpha, right? And this whole thing is going to be divided by denominator to denominator. It's going to be cos alpha, right? And this is going to be 1 plus sine alpha, right? So that's what we're going to have. So this is going to be equals to what? This is going to be 1 squared. So it's going to be 1 squared, which is going to be 1. Then it's going to be sine squared. So it's going to be negative sine squared alpha, right? And this is going to be divided by what? By cos alpha divided by what? Divided by 1, right? So this is going to be 1 plus sine alpha, right? So now, every time when you're proving left-hand side and right, and like what you call this, left-hand side and right-hand side, you need to go back to the one that you're trying to prove, right? What do we see? We see the fact that, okay, cool, we have 1 sine squared alpha, right? Do you remember the fact that I could change this and basically write sine as the subject? So sine squared theta is going to be equals to 1 minus cos squared theta, right? And also I can say cos squared theta is equals to 1 minus sine squared theta, right? And here we want cos. We want the denominator to be cos. Do you see the fact that I can replace the 1 minus sine squared theta by this one, by cos alpha, cos squared alpha, right? So let's do that. And it's going to make me close to what I want. So this is going to be cos squared alpha. And this is going to be divided by what? This is going to be cos alpha. Then this is going to be 1 plus sine alpha. One more thing. Do you see the fact that in the denominator we have partially what we want? Do you see that? We have partially what we want, right? And now since it's cos squared theta and cos here, one of them is going to cancel out the denominator because it has the lowest power. So this one's going to cancel out and this one is no longer going to be squared but only one cos. So you're going to be left with cos alpha is divided by 1 plus sine alpha. Do you see the fact that this matches up with the right hand side? So this is going to be equals to the right hand side. And this is how you would prove this question. So now we're going to move to grade 12 identities, right? First, we're going to do the double angle. I'm not going to yet touch on the other one, the compound angles, because of the compound angles has a reduction to do with it. We need to do reduction first, then we can do the compound angle, right? So now we're going to only touch on the double angle, right? To touch on the double angle, this is the double angle. We have that sine 2 theta is equals to 2 sine theta cos theta. Then it's going to be cos 2 theta is going to be this one. The cos 2 theta has 3 identities in total, right? So it's going to be 3 identities. So with the 3 identities, with each question, remember the fact that you need to use the best one to basically solve whatever situation that you're in, right? So now let's do a question that deals with the identities, right? So this is the identities that I'm not going to do right now. I'm going to do it when we are done with reduction, because as I said, the fact that a lot of questions involve reduction with this one, right? So do you see the fact that I wrote already my grade 11 identities? So here, let's add up what? Let's add up this one making sine and cos the subject. So we know the fact that sine squared theta is basically equals to 1 minus cos squared theta, because we might use it, right? So here is going to be what? It's going to be cos squared theta is equals to 1 minus sine squared theta, right? So, and this is the new identities that we just add, right? So here it says if alpha is an acute angle and sine alpha is equals to what? To 0,6, determine sine 2x without the use of a calculator. Here, if you see the fact that we're going to use Cartesian, right? We see the fact that we are given that sine alpha is equals to 0,6, right? As I said when we were doing Cartesian, if you have a decimal, change it into a number. So you're going to say 0.6 in your calculator and say equals to. So sine alpha here is the same as saying 3 divided by 5, right? And we know the fact that this is the same as opposite over hypotenuse, right? So let's draw it in the Cartesian plane. So it's going to be like this, right? They tell you one extra information, the fact that alpha is an acute angle. So it definitely needs to be in the first quadrant. So it's going to be here, right? So it's going to be here. And we already know the fact that in the first quadrant, sine is positive. So it's going to be here, right? So alpha is going to be this one. So we know the fact that this is opposite. So 3 is going to be here. Hypotenuse is going to be here. So we are missing x. So let's find x. So it's going to be r squared is equals to what? Is equals to x squared plus y squared, right? So let's substitute. It's going to be 5 squared is equals to x squared is what we're looking for, plus y, so it's going to be 3 squared, right? So it's going to be 5 squared is going to be equals to 25, right? Is equals to x squared plus what? Plus 3 squared, which is going to give us 9, right? So this is going to be 9. So if you say 25 minus 9 is going to give you 16. So it's going to be 16 is equals to x squared, right? Square root both sides, so it's going to be 16 squared, which is going to be x is going to be equals to plus or minus 4, right? So, but we see the fact that x is in the positive, our triangle is in the positive x-axis. So here x is going to be equals to just 4. So here is going to be 4. So we see that our diagram is complete in this question, right? So to answer the question, we need to determine sine 2 alpha, right? So here we see the fact that sine 2 alpha is what? It's actually this identity. Do you see that? So we're going to substitute sine 2 alpha with that. So it's going to be 2 sine alpha cos alpha, right? So we know the vector is going to be 2. What sine alpha is going to be what? It's going to be opposite over hypotenuse. Then here is going to be what? Adjacent. Cos is going to be adjacent over hypotenuse. So let's substitute. So it's going to be 2, open bracket, opposite over hypotenuse is going to be 3, right? Divided by what? 3 divided by 5. Then cos is going to be 4 divided by 5, right? So that's going to be the same as what? That's going to be the same as if we take numerator, if we multiply numerator, so it's going to be 2 multiplied by 3 multiplied by 4, which is going to give us 24, right? And if we say 5 multiplied by 5, that's going to give us 25. So our answer here is going to be 24 divided by 25. So now example 2, we need to prove that we need to prove the following, meaning we need to prove that left-hand side is equals to right-hand side. As I said that with proving, we always take the more complex side. Here, which one is the most complex side is actually our left-hand side, right? But before that, let's rewrite this one. So it's going to be the same as sine squared theta is equals to 1 minus cos squared theta. Then cos squared theta is equals to 1 minus sine squared theta, right? So I have all my identities, right? So now, remember the fact that this one's we're not going to use. We're not going to use that one. We're going to use the grade 11 and also this ones, right? So now we know the fact that left-hand side is equals to what? Is equals to sine x plus sine 2x, and that whole thing is divided by what? Is divided by 1 plus cos x plus cos 2x, right? So here our goal is to get 10x. That's our goal, right? So we need to simplify this so that we can get 10x, right? So it's going to be equals to what? Sine x, leave it alone. We're going to change what? We're going to change our sine 2x. So it's going to be sine x plus sine 2x. We have this identity. Do you see that? It's going to be what? It's going to be 2 sine x, right? Cos x, right? So this is going to be divided by what? This is going to be divided by 1 plus cos, we leave it, right? Then here it's going to be what? It's going to be plus what? This is going to be plus, now we need to replace the cos 2x, right? So here, one more important thing, we know that the identity of 10x is basically equals to what? It's equals to sine x, right? Divided by cos x. And the reason why I'm bringing that up is that for us to arrive here, we need the following, right? We need our numerator to be just sine, then our denominator to be just cos. So here, when replacing, right? When replacing the cos 2x, because there's 3 identities, right? We need to pick the one that has what? That has cos, because we need our denominator to be cos. I hope that makes sense, right? So I cannot pick the cos squared theta, cos squared theta minus sine squared theta. Even if you pick it, you can arrive to the final answer, but it's going to take more time, right? I cannot even pick the one with the sine because of, again, is that I want my denominator to be what? To be cos, right? So which one is the best option? That is why I'm saying the fact that you write all your identities so you can pick the one with the best option. It's going to be this one, right? This one is our best option. So let's substitute with that. So it's going to be what? It's going to be 2 cos squared x, right? Then this is going to be minus 1, right? And you're going to have that, right? So let's simplify the numerator and denominator. So it's going to be sine x, right? What do we see? We see the fact that sine x is what? It's actually common, right? So I can take out sine x as a common factor. So this is going to be left as 1, right? Then it's going to be plus 2, right? 2 cos x, right? Do you see the fact that so far I'm having my x alone, my sine x alone? So I'm getting closer and closer to the answer, right? So now we're going to have this one. Let's simplify the denominator. It's the same as 1 plus cos x, right? And this is going to be plus 2 cos squared x, right, and minus 1. What do we see? Do you see the fact that the 1 and the negative 1 are going to cancel out? So you're going to be left with sine x, right? Then this is going to be 1 plus 2 cos x. And this is going to be divided by what? This is going to be divided by, now we're going to be left with cos plus 2x. Do you see the fact that I can take out cos x as a common? So this is going to be cos x, and open bracket, I'm going to be left with what? With 1 here. So this is going to be 1 plus 2 cos x, right? So do you see the fact that now the 1 plus 2 cos x is going to cancel out? So you're left with sine x divided by cos x. That's exactly this identity, and this identity is basically equals to what? To 10x. Do you see the fact that knowing which one to pick and having your identities on the side, it makes it easy to prove and simplify? So this is how you would prove that this is equals to the right-hand side. So this is how you would do it, right? So your identities being on the side is very important. It makes these questions, no matter how complex it is, as long as you know which one is best to substitute, then these questions are going to be like just a breeze, right? Just remember the fact that always look when proving, always look at the side that you're not proving what you need, so that when you substitute, you know which one is best to substitute, right? So I hope that made sense. So now let's do example 3, right? We are given the fact that we need to prove that 1 over sine 2x minus 1 over 10 2x, right, is equals to what? Is equals to 10x, right? Which one is the most complex one? It's actually the left-hand side. So we know the fact that this is the left-hand side and this is the right-hand side, right? And with every proof question, it looks difficult. But as long as you apply what I'm telling you, you'll see the fact that these questions are really a breeze, right? As I told you, is that we're going to extend this one. So this is going to be the same as sine 2 theta is equals to, because we might need it, we don't know, 1 minus what? 1 minus cos squared theta. Then this one is going to be cos squared theta is equals to 1 minus sine squared theta. So now let's approach this question. We know the fact that we're taking the most complex side, which is the left-hand side, right? It's going to be equals to 1 divided by sine 2x. So this is going to be sine, right, 2x, right? And this is going to be minus what? Minus 1. Then this is going to be what? 10 2x, right? So now what I'm going to do is I'm going to substitute my identities, right? So I know the fact that sine 2x only has one identity, so there isn't a multiple identities that I can substitute. It's only this one. So let's substitute that one. So it's going to be 1 divided by what? Divided by 2 sine x multiplied by cos x, right? So that's what we're going to have. Then this one, right? We know the fact that we have the fact that this identity of 10 theta is equals to sine theta divided by cos theta. So 10 2x, I can change it as what? As actually sine 2x divided by cos 2x, right? So I can change that one. So this is going to be minus, this one divided by, change this one. So it's the same as sine 2x divided by what? By cos 2x, right? So now what I'm going to do is I'm going to try to simplify it. So it's going to be 1 divided by what? By 2 sine, right, x. And this is going to be cos x, right? And this is going to be minus. This is the same as writing it as 1 divided by what? By sine 2x divided by what? By cos 2x, right? So now continue simplifying it. It's going to be 1 divided by what? Divided by 2 sine x, right? And this is going to be cos x. And this is going to be 1 minus 1. Then this one, when we change to multiplication, your denominator becomes your numerator, and numerator becomes your denominator. So this is going to be cos 2x divided by what? By sine, right? Sine 2x, right? So this is going to be sine 2x, right? So this whole thing, right, is the same as negative 1 multiplied by the numerator, which is cos 2x. So this is the same as 1 divided by what? By cos sine x, right? And this is going to be cos x, right? Is minus what? It's going to be minus, then here we're going to have what? We're going to have cos 2x divided by what? By sine 2x, right? Before I continue, do you see the fact that this and this is the same thing? So I'm just going to go back to before, like substituting it. So this is going to be the same as what? This is the same as 1 divided by sine 2x, right? I'm just going to go back to before we substituted it because I'm seeing something. So this is going to be minus, then this is going to be cos 2x, and this is going to be divided by sine 2x. What do we see? We see the fact that the numerators are the same. So I can add the denominators are the same, sorry. So I can add the numerator. So this is going to be the same as 1 minus what? 1 minus, then this is going to be cos, right? Cos 2x, and this is going to be divided by what? By sine 2x, right? So now this is what we have, right? So with this one, remember the fact that we're looking for what? We're looking for 10x. So we're basically looking for the numerator to be sine x alone and the denominator to be cos x alone. So we need to change this to be in this form, right? So what do we know? We know the fact that first let's deal with the denominator because it only has what? It only has one identity. We see the fact that we have 1 minus cos 2x. And the reason why I'm dealing with the denominator that has only one identity is that cos 2x has multiple ones, right? So my denominator is going to determine which one to pick in the numerator, right? So this is going to be divided by what? This is going to be divided by, remember the fact that this is 2 sine x and cos x, right? So remember the fact that in my denominator, I want cos, right? I want this one. So this one should be remaining. So I want to get rid of 2 sine x. That's what I want to get rid of, right? So now, with that said, me wanting to get rid of what you call this, 2 sine x, right? Now I look at my denominator. This identity, I have 3 options, right? So remember the fact that again, in my numerator, I want sine, right? And I want something that's going to cancel with 2 sine x, right? So here, which one is the best one to pick is that if I pick cos 2x minus sine 2x, right? What's going to happen is that, let's check, is that I'm going to have a bit of what? I'm going to have a bit of sine, which is what I want, and also I'm going to have a bit of cos, right? So let's check, is it the best one? Looking at it, no, I don't think so. If I pick the second one, I think the second one is going to be the best one, right? Because I'm going to be able to get rid of sine, right? And also one more thing is that, I'm going to be able to get rid of sine because of it as sine, and in the numerator, I want sine, right? And if I pick the third one, I'm going to have cos in the numerator, which is going to be not what I want because I want sine in the numerator. I hope that makes sense. So 1 minus 2 sine squared theta is the best one, right? So I'm going to substitute by 1 minus, open bracket is going to be 1 minus 2 sine squared x, right? So this is going to be sine squared x. So it's going to be sine squared x, right? So this is going to be divided by what? This is going to be divided by 2 sine x cos x, right? So this is going to be the same as 1 minus 1, then negative 1, and this one is going to give you positive 2 sine squared x. And this is going to be divided by what? By 2 sine x cos x, right? So this ones are going to give you 0, so it's going to give us, we're going to be left with 2 sine squared x divided by what? By 2 sine x cos x, right? So here, continuing the equation, we're going to be left with what? Do you see the fact that the 2's are going to cancel out? And here, because it has the highest, the 2's going to cancel out, and the sine is going to cancel out. So you're going to be left with sine x divided by what? By cos x. Do you see the fact that that's exactly what? That's exactly 10x. And this is equals to the right-hand side. Do you see the fact that the thing of writing identity, again, you knowing which one is best to use for the scenario is how you always arrive to the answer, right? So this is going to be how you would solve this question. So now we're going to do example 4, right? It's also proving, right? So with proving, remember the fact that this is going to be your left-hand side and this is going to be your right-hand side, right? So we're going to take the most complex one. For me, I feel like the most complex one, and that has identities in it, is going to be the left-hand side, right? So I'm going to take the left-hand side and simplify it to look like the right-hand side. So I'm going to say left-hand side, right, is going to be equals to 10, 2x, right? And this is going to be plus 1 divided by cos 2x. Let's change this 10 to x, which is going to be the same as sine, right, 2x divided by what? Divided by cos 2x, right? And this is going to be plus 1 divided by cos 2x, right? So the denominators are the same, so I can add the numerators. So this is the same as sine 2x plus 1, and this is going to be divided by what? Divided by cos 2x, right? So now we're going to go back to the equation and see what we need, right? In the equation, the right-hand side, we need a sine x plus a cos x, and in the denominator, I need a cos x, then I need a minus sine x. So that's what I need, right? So whatever I do here, whatever I pick, is that this needs to be, this is what I should arrive to, right? So here I'm going to start with the one that has only one identity, which is what? Which is the sine 2x, because that one is going to make me know which one to pick for the cos 2x, because remember that cos 2x has what? Has 3 options. So let's start and substitute. We know the fact that sine 2x is going to be the same as 2 sine x cos x, and this is going to be plus 1, right? And that's going to be divided by what? That's going to be divided by the following. It's going to be just cos 2x, right? So now we know the fact that we have this, right? So that's that. We can simplify the numerator is that, right? But remember the fact that the goal is to get what? The goal is to get this, right? So we see the fact that we have sine, right? Sine added to some number, right? So from this, I think here the best one, now we need to look at cos 2x. So we know the fact that we need 2 things, right? We need sine and we need cos, right? So looking at our identities, which one will be best, right? Which one contains sine and cos is going to be the first one. Do you see that? It's cos squared theta minus sine squared theta, right? So I'm going to substitute with that one. So it's going to be 2 sine x, right? And this is going to be cos x plus 1. And this whole thing is going to be divided by what? It's going to be divided by, if I say cos squared x, right? And this is going to be minus sine squared x, right? So that's what I have, right? So what do I know? I know the fact that this is actually a difference of 2 squared. So I can factorize this, right? Because do you see the fact that we have 2 terms and both the terms are what? Are both, one is positive and one is negative, and they both can find the perfect square. So that can be replaced as 2 sine. The numerator is going to remain the same. And this is going to be plus what? So here we're going to have what? We're going to have open bracket. I can say what? I can say cos x, right? Minus sine x. And here I can say what? I can say sine x, right? So it's going to be sine x. So it's going to be cos x, sorry. Then this is going to be plus sine x. So now we see the fact that we are one step closer to the answer. Do you see that? We have what we want here. So now we see the fact that, okay, cool. The left-hand side, we have a portion which is I just highlighted, right? But looking at it is that there isn't anything that I can do. This is where I can end in terms of the left-hand side, right? So what I'm going to do is now I'm going to take the right-hand side and try to simplify it, maybe so I can match it up with the left-hand side, right? So I see the fact that the right-hand side, I have the following. So the right-hand side is equals to what? To sine, right, x plus cos x, right? And that's divided by what? And that's divided by cos x, right? Minus sine x, right? So just a pro tip is that if you are doing one side and you see the fact that, okay, I can't do anything, you can actually take the other side and try to simplify it and get them to match with each other, right? So what do I see? I see the fact that I have cos x minus sine x, then it's multiplied by cos x plus sine x, and this is what the conjugate of the denominator. So I'm going to do that so they can match up with this denominator. So I'm going to say this is going to be multiplied by what? By cos x, right, plus sine x, and that's going to be divided by the same thing, which is going to be not changing the equation because of dividing the numerator and the denominator and numerator being the same thing is equals to 1, right? So this is going to be cos x plus sine x, right? So now we're going to multiply numerator to numerator and denominator to denominator. So this is the same as sine, right? Sine x plus cos x, right? And it's multiplied by cos x plus sine x, right? And this is going to be divided by what? This is going to be divided by the following. It's going to be what? It's going to be cos x minus sine x, right? Then this is going to be what? This is going to be cos x plus sine x, right? So I'm just going to leave the denominator the way it is because it matches up exactly with the denominator when simplified of the what? Of the left-hand side. So I'm going to leave it the way it is. So I'm going to now deal with the numerator because the numerator is our problem, right? So now I'm going to what? I'm going to expand this. This is going to be what? This is going to be sine x multiplied by cos x, which is going to be sine x multiplied by cos x like this. Then it's going to be sine x multiplied by sine x, which is going to be the same as sine squared x. Then it's going to be cos x multiplied by cos x, which is going to be the same as, let me just change, did a mistake there. It's going to be cos squared x. So it's going to be what? It's going to be cos squared x. Then we're going to have what? We're going to have cos x multiplied by sine x, which is going to be what? Which is going to be cos x multiplied by sine x, right? So this two, we have, okay, before we do that, this is going to be divided by this denominator, right? So this is going to be what? This is going to be cos x minus sine x, right? And this is going to be cos x plus sine x, right? So now we see the fact that we have like terms. This two, do you see the fact that this one, let me just do it in another color. Do you see the fact that this and this is exactly the same thing because of its multiplication? Whether it's in front or it's the second one, it really doesn't matter. So this is going to be the same thing. So let's put them together. So this is going to be the same as 2 sine x cos x. Do you see the fact that we're coming close to the answer? We have this portion. So let me see, highlighted. Do you see the fact that, no pen. I want my highlighter. Do you see the fact that this now it's this one? Do you see that? We have this portion, right? So then that is going to be added by what? It's going to be added by sine squared x plus cos squared x, right? And that whole thing is going to be divided by what? It's going to be divided by cos x minus sine x, right? And that's going to be cos x plus sine x, right? So what do we see? We see the fact that we have another identity here, right? Do you see the fact that this is an identity, this one? It's from grade 11. It's exactly this. This is equals to 1. Do you see that? So I'm going to replace that 1 by 1. So it's going to be equals to what? 2 sine x cos x plus 1, which is exactly the numerator, is divided by what? Is divided by cos x minus sine x, right? And that's going to be what? Cos x plus sine x, right? Do you see the fact that that matches up exactly with the left-hand side? So this is going to be equals to the left-hand side, which proves this question. So now what we're going to do, we're going to do reduction, right? So we're going to basically, this is like a summary of everything but I'm going to draw the diagram that we're going to be constantly using here, right? Which is going to be like this, right? So it's going to be 180. It's going to be a summary of everything. And I'm going to like just say a couple of things from the diagram, or a couple of things that we're going to need to know, right? So is that we see the fact that here it's what? It's 0 degrees, right? And this is 90. This is 180. And this is 270. And this is 360, right? So the angles that are very important here is the following. It's this 360, it's this 90, and this 270, right? This 370 in terms of co-functions is not important. We only use 90 for co-functions, right? So with that said, is that now we need to know in which quadrant, right? How we gonna reduce each and one of them, right? Do you see the fact that if you go this direction when we're dealing with 90, right? Is that the following happens. This side, it's like subtracting, it's less than 90. That is why here it's going to be 90 minus theta. Here, do you see the fact that it's everything that's greater than 90? So that is why it's 90 plus theta, right? Then here, do you see the fact that it's less than 180? That is why this side again, it's also going to be what? It's going to be 180 minus theta. With this side, it's going to be 180 plus theta, right? So I'm just showing you guys the simpler way to remember this, right? Then here, right, do you see the fact that 360, this side, right, it's actually everything greater than 360. So this side is also known as 360 plus theta, right? With this side, right, we're going backwards, so meaning it's going to be less than 360. So this side is going to be 360 minus theta, right? So, right, when we're doing questions, you'll see how to use each and every one of them, right? So, this is called the 90 part. Let me just take my highlighter. This 90 section is called the cofunction, right? It's when we change from, do you see here? That's when we change from where? That's why we change from a sine to a cos, or cos to a sine, right? So the cofunction is when changing from sine to cos and cos to sine, right? Then one more important thing to know here is that in each quadrant, we need to know which one is positive and which one is negative. You already know that the fact that this is all student, right? Take what? Take coffee, right? So we know the fact that in the first quadrant, all of them, they're positive. And the second one is that only sine is positive. In the third one is that only 10 is positive. And in the fourth one, we know the fact that only what? Only cos is positive, right? So one more important thing that I want to discuss, especially when it comes to cofunction, right, is the following. Is that, do you see the fact that when we get to the fourth quadrant, when we're changing from, if we have sine, do you see here? If we have sine and it's 90 plus theta, right? You know the fact that it's going to change from sine to cos, right? But remember in the second quadrant, very important is that what? We know the fact that sine is the one that's positive, right? That is why when we change, it's going to be positive what? It's going to be positive cos theta, right? And the reason why it's positive cos theta is that in terms of determining the sign, whether it's going to be positive or negative, we look at the original question. You do not conclude by the final. I get the fact that your final answer is cos, right? But your initial question was sine, and sine is positive. And that is why cos 90, right, plus theta, it's going to give us negative sine, right, theta. Regardless the fact that we're in the second quadrant, the initial one was cos. And we know the fact that cos is what? It's negative on the second quadrant. That is why your answer is going to be negative sine. Just keep that in mind, right? Because if that's going to be a little bit confusing. So that's one thing that I want to talk about. Then another thing that I want to talk about is when we are given the following, when we have sine of a negative angle, what do we get? When we have cos of a negative angle, what do we get? And also when we have a tan of a negative angle, what do we get, right? So with sine of a negative angle is that it's going to be negative sine theta. Then with cos, it's going to be positive theta. So cos is the only one that's going to be positive, you'll see. Then tan is going to be negative tan theta. And to actually explain that is that in the fourth quadrant, right? Here, let me just change my color because I just want to emphasize this, right? In the fourth quadrant, this, when we do like, when we do general solution, you'll see, right? Is that in the first quadrant, you know the fact that this is theta, and in the fourth quadrant is actually represented as negative theta, right? You can write it as 360 minus theta, or you can say negative theta. And we know in the fourth quadrant, only cos is positive. That is why it's justifiable when we're looking for cos of a negative angle, it's actually negative. I hope that makes sense, right? So that's just a couple of things that I just wanted to talk about before we get into doing the questions, right? So next up, we'll be doing the first example. So now we're going to do the first example, right? So the reason why I started with identities before I went to reduction is because of questions in reduction, right? They can ask you about identities. That's why I have the identities on the side, because as we're doing more questions, you'll see the fact that you're gonna need your identity, right? So now let's do the following. It says write down the following as a single trig ratio. So our final answer needs to be a single trig ratio, right? So the tip here is that we always look at, we always check whether are we dealing with like special angles or not. If we're not dealing with the special angle, then the next step is to check whether our smallest angle is it, you check for your smallest angle. That's what I wanted to say, right? So here we see the fact that we have 163, right? Here we have 193, then we have 10 of 17. So we see the fact that 10 of 17 is our smallest angle, right? So now when we reduce this to, right, the 163 and the 193 is that we need to reduce it to 17, because of that's when we can get rid of things, right? So just keep in mind the fact that you always check whether you're dealing with special angles. And if you're not dealing with special angles, because special angles is going to give you actual numbers, right? And then you check your smallest angle, right? In our case, it's 17, right? So our goal is to get 17. Then the next step is that we see the fact that we have 163. Which one is closer to 163? And very important, right? We never use cofunction where we're not needed, right? So here we see the fact that cofunction is not necessarily something that we need, right? So we always use our first thing that we use. We always use 360 and 180. We don't just use the cofunction. We use it when it's needed, right? And you'll see when it's needed, right? So now, knowing the fact that you use 360 and 180, right? You look at your angle, which is, in our case, it's 163. 163 is closer to what? Is it closer to 360 or is it closer to 180? And we see the fact that it's closer to 180. So you take your 180, so you're going to say 180, right? Minus what? Minus 163, right? And you're going to get your answer to being what? To being positive 17, right? So that's perfect. You see the fact that it's positive 17. So now I need to rewrite this in terms of that. So you know the fact that if I say 180, right? And the tip here is that if you get a positive answer, you subtract it. And it makes sense. If you say 180 minus 17, you agree the fact that I'm going to get 163, right? So you know the fact that you're going to get 163 there, right? So now you know you can replace this 163 by this, right? So now let's do the cos part, right? The cos part is going to be what? It's going to be 180, right? And you're going to say minus 197. And you're going to get the fact that your answer is going to be negative 7, right? Negative 17. So if you add it, because of its negative, so it's good. If you say 180 plus 17, you agree the fact that you're going to get 197, right? So now you know the fact that you're going to replace the 163 by 180 minus 17. Then 193, you're going to replace it by this one, right? So this, your answer is going to be the following. So I wish the fact, okay, cool. So let me just take my pen. Just wish that I used a different color to show this. So now it's going to be what? It's going to be sine, right? replace it. So it's going to be 180, right? Minus what? Minus 17. So this is equals to, because it's equals to that. Sine 180 minus 17, right? And this is going to be divided by what? Divided by cos, right? Then it's going to be 180 plus 17, right? And this is going to be plus 10, 17. Then this is going to be plus cos, right? Then this is going to be 180 minus beta. Then this is going to be multiplied by 10. Then it's going to be 180 plus beta, right? So now let's simplify this. So 180 minus 70, where's 180 minus? It's in the second quadrant. Sign is positive there. So you're going to say the fact that your answer here is going to be the same as sine 17, right? Because in the second quadrant is positive. Then, 180 plus is here. Do you see that? And 180 plus theta is in the third quadrant, and 10 is the one that's only positive, meaning cos here is negative. So it's going to be minus what? Minus cos 17, right? So we have this one. So this is going to be plus 10 17, right? And this is going to be plus. Then now we're going to deal with 180 minus theta. 180 minus theta is in the second quadrant. Only sign is positive, so cos is going to be negative. So it's going to be negative cos theta here, right? And this is going to be multiplied by what? By 10, 180. 180 plus. It's in the third quadrant. 10 is positive. So we see the fact that this is going to be the same as 10 theta, right? So here, let's simplify this. This one is the same as what? We see the fact that we have, sine 17 divided by cos 17. Do you see the fact that this is this identity? So I can change it to negative 10 17. And this is going to be plus 10 17, right? And this is going to be what? Minus cos theta multiplied by 10 theta. So the cos 17, the negative cos 17 and 17, they're going to cancel out because they're going to give us 0. So our answer here is the same as negative cos theta multiplied by what? By 10 theta, right? So here for cos, using the same identity, I'm going to change it to sine theta divided by cos theta. So this is going to be the same as negative cos theta, right? Multiplied by what? Multiplied by sine theta divided by cos theta, right? Since the negative cos theta is in the numerator and the other one is in the denominator, they're going to cancel out. And because of this multiplication, right? So your answer here is going to be negative sine theta, which is a single trig ratio. So that's how you would solve this question. So now we're going to move to example 2, right? It says determine the value of the following expression without the use of a calculator, right? Very important here, right? They say determine the value, right? So meaning, as you're doing the question, you know the fact that, and they say determine the value, and very important, they say without the use of a calculator, without using a calculator. So if they say the fact they determine a value and they want you not to use a calculator, then in your head, what needs to check is that you need to use special angles, right? So special angles, the following special angles are this ones, right? It's 0, I think. I don't know whether 0, but 0, I'm going to assume. Then it's going to be 30, right? It's going to be 45. It's going to be 60. It's going to be 180, right? Then it's going to be 360. So these are the special angles, right? So I think even 90 and 270, right? Yeah, 90 and 270, right? But these are your special angles. But normally when you're doing questions, the following ones are going to be the one that are going to be more prominent, which was they're going to be the one that's going to be more visible, that you're going to mostly use. Is this one, and it's this one, right? The 180, the 360, not really, right? But the ones that you need to know at the back of your mind, right, is that 30 and 45 and 60, right? Then the other one, you just know the fact that they're from the Cartesian. So with that said, right, is that we see the fact that our equation is 10, 150 sine 30, right? Minus what? Minus our cos 210, right? So again, is that we could use the method, as I said, the fact that taking reference to the one with the smallest angle, right? Which is in our case is what is the cos 30, right? So it could be the cos 30. So just here is that when dealing with special angles, is that it's not necessarily your goal to get cos 30. If you get cos 45 or cos 60, then you're perfectly fine. Cos 30, if you like looking for a value and you're going to deal with special angles, your 30 is not necessarily the goal, right? Your goal is to either get cos 30, 45, or 60, because there are special angles and you can find them without using, you can find the values without using what? Without using your calculator, right? So now with that said, let's, let's change 150 to some special angle, right? So where 150 is closer to what? 150 is actually closer to, 150, it's closer to a 180, right? So I'm going to say 180 minus 150, which is I'm going to get my answer to being what? To be 30, right? Which is a special angle, so that's happy, right? We're happy about that. So that we're going to change as being what? So it's going to be 180 plus 30, because remember that the sign here, it's negative, is the sign here is positive, so it's going to be what? It's going to be minus. So here's going to be minus 30, and this is going to be equals to what? This is going to be equals to 150. So we're going to replace 150 by this one. Then the 210, right? Again, it's closer to what? It's more closer to 180 than 360. So it's going to be the same as 180 minus 210, right? It's going to be equals to what? It's actually going to be equals to negative 30 degrees, right? Which is going to be what? Which is going to be 180 plus 30, which is going to equals to 210, right? So with that said, now we can replace our 150 and 210, right? We're going to leave the 30 alone because that's a special angle. So when we replace it, we're going to have the following. We know the fact that it's going to be equals to 10, right? Then 10 is going to be what? It's going to be 180 minus 30, right? And that's going to be multiplied by what? Multiplied by sine 30. Then this is going to be minus cos, right? And it's 180 plus 30, right? So now let's use reduction. 180 minus theta or minus 30, where does it lie? It lies here. Do you see that? So since it lies there, sine is the only one that's positive. So this one is going to be negative 10, 30 degrees, right? Then this is going to be multiplied by sine 30 degrees, right? Then cos plus is here, and there only 10 is positive. So this is going to be the same as minus open bracket minus cos 30 degrees, right? So with that said, now we can basically, substitute our special angles, right? So here the trick is, if you are going to use your calculator, guys, be smart about it, right? They specifically said without a usable calculator, so don't paste the whole thing inside your calculator. Don't do that. Now you're showing that you actually use your calculator, right? So the trick is to do individual so that it looks like you didn't use your calculator, right? So we're going to go to the calculator and look for 1030, right? So for 1030, before that, let's simplify this. So this is going to be negative 10, 30 degrees, right? Multiplied by sine 30 degrees. Then this is going to be plus, because a negative and negative going to give you a positive. So it's going to be plus cos 30. So now individual, right? You're going to look for 1030, sine 30, and cos 30 individually, right? Don't paste the whole thing, then you're not going to get your marks, right? We are tricking the system. So remember the fact that this is negative so that we don't make a mistake, right? So this is negative, right? So if you say negative, right, 1030, you're going to get the fact that in your calculator, you're going to get the square root of 3 divided by 3, right? Then you're going to say, this is going to be multiplied. You're going to look for sine 30, which is going to give you a half, right? Then you're going to say plus, if you say cos 30, you're going to get what? You're going to get the square root of 3 divided by 2, right? Then again, you do not do everything. You don't punch everything into your calculator. You solve it, right? So here you're going to say what? You're going to say numerator multiplied by numerator and denominator multiplied by denominator, right? So this is going to be the same as negative square root 3 multiplied by 1, which is going to be negative root 3, right? Divided by 3 multiplied by 2, which is going to give you 6, right? And this is going to be plus the square root of 3 divided by 2. Then from here, you can just punch it in your calculator, right? So this is going to be equals to the root of 3 divided by 3. Just remember, when they say without the use of a calculator, you become smart and do it bits by bits, how you would solve it manually, right? Because of manually, you wouldn't punch the whole thing and know what it is. You need to break it down so that it looks like you manually solved it, right? So that's how you would do this question. So now we're going to do example 3. So example 3, it says if f is equals to 1063, right? Express the following in terms of f. So here we know by just looking at the question and what they want from us that everything that we do is that we need to reduce it to 67, right? So if f is equals to 1067, not 63, right? So we need to reduce it to that. So keep in mind the fact that whatever angle that we get, we need to reduce this to 67 because of that's 10. Remember that f is equals to 1067, right? And it's that we need to write the following in terms of 10, right? And again, is that we should not have sine and cos. We need to strictly have what? We need to strictly have 10 in our question. I hope that makes sense, right? So with that said, now let's reduce our angles, right? So the first one is that it's 293. 293, is it closer to 360 or 180? It's actually closer to 360, right? So if you say 360, right, minus 293, you're going to get that your answer is going to be what? 67, right? So that's going to give you what? That's going to give you is the same as 360, right, minus 67, which is going to give you 293. Then our cos, our 427 is closer to 360, which makes sense. So it's going to be 360 minus what? Minus 427, right? Which is going to be equals to what? Which is going to be equals to negative 67. Clearly I like 63. Then this is going to give you what? This is going to give you 360, right? 360 plus 67 is equals to 427. So now the problem is this one for us, if you look at it, right? It's this one, right? So now to reduce that one, we're going to use the same method that we've been using, right? But we keep on substituting back, right? So I'm going to do it on the side. So is that... Okay, let's do this, right? Is that let's basically go and substitute this one and this one, right? And substitute the first one that we're going to get. 1,447, right? It's by default closer to 360, right? So you're going to say 360, right? Minus 1,147, right? So if you say 360 minus 1,047, you're going to get the fact that it's going to be what? It's going to be negative, right? 787, which is the same as if we rewrite it. We're going to rewrite it as what? As 300 and what? It's going to be the same as if I rewrite it as 360 plus 787, right? So that's how you're going to do it. So first thing first is that we're going to basically substitute everything, right? So when we substitute, here we know the fact that sine equals to, sine is going to be equals to what? To 360, right? Minus 67. And that's going to be divided by what? That's going to be divided by, if you, then cos is going to be what? It's going to be cos, then it's going to be 360 plus 67. And that's going to be what? Plus 10. Then this is going to be negative 67, right? And this is going to be plus what? That's going to be plus 10. Then this is going to be 360, right? 360 plus 787, right? So now using your reduction, so we know the fact that 360 minus is in the fourth quadrant, and there what's going to happen is that our cos is the one that's positive, So sine is going to be negative here. So this is going to be negative sine 67, right? Then 360 plus what you call this plus 67 is in the first quadrant. Everything is positive. So this is going to be positive cos 67, right? Then this one, I'm going to change it. Negative 67 of 10 is the same as negative 10 67, right? So this one, 360 plus is in the first quadrant. So this is the same as saying plus 10. Then you're going to have what? 787, right? So we're going to reduce it again, right? Because it's not what we want. So again, when you reduce it, let me just change my pen. When you reduce it, it's going to be 360, right? Minus 787, right? Which is going to give you 360 minus 787, which is going to give you 424. So we know the fact that you're going to get negative 427, right? So that's going to be the same as what? That's going to be the same as 360 plus what? Plus 427, right? And we see that 427 is something that we had. So now rewriting the equation, substituting that. So it's going to be, where's my pen? Okay. So this is going to be equals to, we know the fact that this is negative sine 67 divided by cos 67, right? Minus 10. Then this is going to be 67, right? Then this is going to be plus 10. Going to replace it with 360 plus 427, right? So this is going to be what? This is going to be negative sine 67 divided by what? Divided by cos. Then this is going to be 67. Then this is going to be minus 10. Then this is going to be 67, right? And this one, when we say 360 plus, is going to be the same plus 10, what? 427, right? So we already know that 427 is equals to this one, and I'm not going to do it. It's that we already know that 427 is basically replaced by this one, right? So we're going to replace it by that one because we already calculated it. So this is the same as negative sine 67 divided by cos 67, right? Minus 10, 67, plus, then we can say 10. Then we're going to say 10, right? Then you're going to replace it by 360, the one that I just highlighted, right? Plus 67, right? So now I'm just going to continue here. This is going to be equals to what? We already know the fact that this is sine 67, right? Divided by what? By cos 67, right? Minus 10, 67. Then this one is going to be plus, then 360 plus is in the first quadrant, so everything is positive there. So it's going to be the same as 10, 67, right? So this is an identity. Do you see that? This is an identity. So this is the same as having negative 10, 67, right? And this is going to be minus 10, 67. And this is going to be plus 10, 67. So this ones are going to give us what? So this one and this one is going to give us 0, right? So we're going to have our answer is going to be negative 10, 67, right? So therefore our answer is going to be negative f. So our final answer is going to be negative f because we needed to write our following expression in terms of f. So that's how you would solve this question. So now we're going to do example 4, right? They say evaluate without a use of a calculator. Without a use of a calculator, in your head, special angles, ding, 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 ding. That's what needs to come into your head, right? Remember the fact that the special angles, as I said, the fact that it's going to be 30. So it's going to be 30, 60, and 45, right? That's the ones that matters, right? So let me just rewrite it properly. So we know the fact that it's going to be 30 degrees, 45, and 60. So when reducing, right, here, remember the fact that with special angles, our goal, to be honest, is not to reduce to the smallest one in the equation, but to reduce to one of the special angles, right? So here we see the fact that we have 10 squared, right? It's going to be 10 squared, 210 degrees, right? Minus 1 plus cos 120, then sine squared 400 and what? 405, right? So now let's reduce everything. We see the factor for the first one, which is 210, is closer to what? It's closer to 180. So it's going to be the same as saying 180 minus what? Minus 210, which is you're going to get negative 30, which is good because of that's our special angles. So we know the fact that when we rewrite it, it's going to be 180, right? Plus 30 degrees, that's going to give us 210. So that's what we're going to replace it with. Then the other one is going to be 180. Again, 120 is closer to 180. So this is going to be minus what? Minus 120, which is going to give us what? Which is going to give us 60 degrees, right? So that's going to be the same as 180, right? 180 minus, right? So this is going to be 180 minus 60, which is going to give us 120, right? Then this one is going to be the same as saying 180, not 180. 405 is closer to 360. So let me erase that. So that one is closer to 360. So it's going to be what? It's going to be 360 minus what? Minus 405, which is going to give us what? Which is going to give us 45, right? Negative 45. So it's the same as saying 360 plus 45, right? So that's going to give us 405, right? So now everything is perfect. Do you see the fact that everything is in terms of either 30, 60, or 45? So now let's substitute, right? So this is going to be equals to, let me substitute. So this is going to be equals to 10, right, squared. Open bracket is going to be 180 plus 30, right? Then the other one is going to be minus open bracket 1 plus, then it's going to be cos. Then it's going to be what? It's going to be 180 minus 60, right? Then this is going to be sine squared. Then this is going to be 360 plus 45, right? So now let's reduce it. So when we reduce it, we're going to have the following. We know the fact that 180 plus is in the third quadrant, right? So here 10 is positive. So this is going to be the same as 10 squared 30 degrees. So that's sorted, right? Then now we're going to say minus open bracket 1 plus. Then if you say cos 180 minus 60, 180 minus is in the second and only sign is positive there. So this is going to be the same as negative cos 60 degrees, right? So that one is sorted too, right? Then we're going to move to 360 plus 45. 360 plus is in the first quadrant, so this is going to be the same as sine squared. Then this is going to be what? This is going to give us 45, right? So now, this is the same as what? This is the same as 10 squared 30 degrees. Distribute the negative here. So before we distribute, let me just clean up. Here is going to be minus open bracket 1 minus, because it's negative. So this is going to be 1 minus what? 1 minus cos 60 degrees. And this is going to be multiplied by sine squared 45, right? So now I'm going to rewrite the ones in square like this. So this is the same as having 10, right? 30 degrees all squared. Then this is going to be minus. Then it's going to be minus 1 minus. Then this is going to be cos 60 degrees. Then this one is going to be the same as sine 45 all squared, right? So now let's find the special angles. Remember the fact that do not punch everything in your calculator. So first find 30, sine, what you call this 10 of 30. So this is going to be the same as the square root of 3 divided by 3 all squared, right? Minus what? Then if you say 1 minus cos of 60, right, it's going to give you 1 over 2. So it's going to be a half. Then sine of 45 is the same as the square root of 2 divided by what? Divided by 2, right? And this is going to be all squared. So this one, when you distribute the square inside, so it's going to give us 3 divided by 9, right? Then this is going to be minus. If you say 1 minus a half, it's going to give you what? It's going to give you a half. So this is going to be positive a half. Then distribute the square root. So it's going to be the same as 2 divided by 4, right? So here it's going to be 3 divided by 9. here, take the multiplying numerator to numerator and denominator to denominator. So you're going to get the following. It's going to be 1 multiplied by 2, right? So it's going to be the same as 2. Then if you say 2 multiplied by 4, it's going to give you 8. Then you can punch this one into your calculator. So when you punch that one into the calculator, your answer is going to be 1 over what? 1 over 12. And that's going to be your final answer for this question. So now we're going to do example 5. The nice thing about example 5, there is no reducing of any angle. It's just dealing with theta. So we just gonna need this, right? So it says simplify the following. So let's simplify it. We have the first one is cos squared, open bracket, 360 plus theta. 360 is in the first quadrant, which means the fact that everything is positive. So this one is going to be cos squared, then it's going to be theta, right? Then the second one is 180, so it's going to be plus. The second one is 180 plus theta. 180 plus theta is in where? It's in the third quadrant. 10 is the only one that's positive, meaning cos is negative. So it's going to be minus cos theta, right? So this is going to be minus cos theta. Then now we're going to move to what? We're going to move to 10. It's 360 minus theta. So it's going to be in the fourth quadrant and only cos is positive, and we're dealing with 10, so this is going to be negative 10 theta. Then the other one is 360 plus. It's in the first quadrant, everything is positive, so sine is going to be positive. So it's going to be positive sine theta, right? So let's simplify this. This is going to be cos squared theta. So this one is going to multiplying them together. You're going to get what? You're actually going to get a positive, so this is going to be plus. So it's going to be the same as cos theta multiplied by 10, theta multiplied by sine theta, right? So now let's change this one into this identity. So let's do that. So it's going to be cos squared theta, right? Plus cos theta. Then this is going to be multiplied by sine theta divided by cos theta multiplied by sine theta. Do you see the fact that we have a cos and a cos, one in the numerator and one in the denominator, and they're multiplying? So these two are going to cancel each other. So you're going to be left with cos squared theta. Then a sine and sine is the same as plus sine squared theta. Do you see the fact that that's actually an identity? So that's going to be equals to what? To 1, right? So that's how you would solve this question. So now we're going to do example 6, right? It says express the following in terms of t if t is equals to sine theta, right? So they give us the question, right? Or the thing that we need to basically simplify or express, right? So here, what do we see? We see a couple of things, right? So let me take my highlighter. Do you see here we have our theta being in front and the angle being next to it? We could never, right? Never do that. We need to always have the angle in front, like the 90, the 360, the what you call is the 180 always needs to be in front. Then the angle needs to be the one that follows, right? So first, let's rewrite this in the proper way. So when we rewrite it in the proper way, it's going to be like this. So it's going to be equals to what? This is going to be equals to cos. Then this is going to be negative 90 because I'm taking it front. Then this is going to be plus theta, right? And the second one is going to be cos. Leave that alone. So it's going to be 720 plus theta, right? And here's going to be what? It's going to be 10. It's negative 360, right? Plus theta. Then this whole thing is going to be divided. So let's draw my division. So it's going to be what? It's going to be sine squared. Then this is going to be 360 plus theta, right? Then the other one is going to be cos. Then it's going to be what? It's going to be 90 plus theta, right? Then we arrive on our next issue. This is our next issue. Is that, do you see the fact that our 90 and 360 are negative? Again, we could never deal with a negative, right? We need to make it positive. So meaning we need to pull out the negative to make it positive. And how we're going to do that is we're going to say cos, right? And I'm going to do a square bracket. Then take out the negative, right? Then open. then it's going to be what? It's going to be negative. Everything that was negative becomes positive, and everything that was positive becomes negative. Since it was negative, 90 is going to be positive, right? Then this is going to be minus theta, right? Then it's going to be close square bracket. Then this is going to be cos. Then this is going to be 720 plus theta, right? Then do the same thing here. It's going to be 10. Square bracket is going to be minus. Then it's going to be 360 minus theta, right? Then close it. Then it's going to be divided by what? This whole thing is going to be divided by the following. So it's going to be divided by sine squared. Then this is going to be 360 plus theta. Then this is going to be cos. Then it's going to be 90 plus theta, right? Then now we're going to simplify this. Remember the fact that this negative, we know the fact that cos of a negative still becomes a positive. Remember when I showed you guys this, right? We're dealing with that. We know the fact that this is the same as what? This is the same as a positive, right? So we're going to do that. So we know the fact that cos of a negative is still what? Is still a positive. So this is going to be cos 90 minus theta, right? Then it's going to be multiplied by cos. Then this is going to be 720 plus theta. Then this is going to be, remember the fact that 10 of a negative is a negative. So this is going to be minus 10. And this is going to be 360 minus theta, right? Then close your bracket. Then this is going to be divided by what? And this is going to be divided by sine squared. Then this is going to be 360 plus theta. Then this is going to be cos. It's going to be 90 plus theta, right? So now we arrive at our next problem, which is this one, right? This one, right? So let's change that one. So that one actually, if you say the following, if you, no, I don't want a highlighter. Go back to my original. So pen. So if you say 720 divided by 2, you're going to actually get 360, right? So meaning I can rewrite this as what? As 2 multiplied by 360. So let's do that. So now let's rewrite that one. So a highlighter. I pen, change my color. So this is going to be the same as cos. Then this is going to be 90 minus theta, right? And this is going to be cos. This is going to be 360, right? Plus theta. Then this is going to be negative 10. 360 minus theta, right? And this whole thing is divided by what? Whole thing is divided by my division. It looks horrible. So my division is going to be sine squared, right? And this is going to be 360 plus theta. And this is going to be cos 90 plus theta. So now we can start just what you call is reducing it, right? So let me just erase this here because I'm going to need space. So when I start reducing it, this is going to be equals to, let's start with what? This one, 90 minus theta. 90 minus is in the first quadrant, right? Meaning everything is positive. So I'm going to have that this is going to be sine. Remember that 90 is a cofunction. It changes cos to sine and sine to cos, right? So here we're going to have sine 90 degrees, right? So that's nice. Then now the 2 multiplied by 360, we're just going to take it as 360 something, right? The 2 in front of it doesn't do anything to us, right? So this is the same as 360 plus theta, which is in the first quadrant, meaning it's positive. So that's going to be the same as multiplied by cos theta, right? So that one is sorted. Then now we're going to move to what you call this 10, 360 minus what? Minus theta. 360 minus is here in the what? In the fourth quadrant, and only cos is positive, meaning this 10 is going to be negative. So this is going to be what? This is going to be the same as, remember it's minus, so it's going to be minus what? Minus 10 theta, right? Because it's minus, so it's going to be minus, right? And now that's the numerator sorted, right? So now we're going to go to the denominator. So this is going to be divided by, right? So it's going to be what? The sine squared is 360 plus. 360 is in the first quadrant, so that's going to be positive. So it's going to be sine squared. Then there's going to be theta, right? Then the other one is what is a 90 plus. 90 plus is in the second quadrant. And remember, do you see the fact that this is cos and only sine is positive? So this is the same as negative sine theta, right? So that we have reduced everything. Everything is sorted here, right? So now let's simplify it further. So this is the same as sine theta multiplied by cos theta, right? And this is the same as positive. So it's going to be 10 theta, right? And this is going to be divided by what? This is going to be divided by sine squared theta. Then this is going to be what? Minus. So it's going to be minus sine squared theta multiplied by another sine theta, right? So remember the fact that when we go back to the equation, we need everything to be in terms of sine, because sine is 10, right? So we see the fact that this sine and this one is going to cancel out because of everything in the numerator is multiplying and everything in the denominator is multiplying, and we have a sine in the numerator and denominator. That's why it's cancelling, right? So we're going to be left with what? With cos theta multiplied by 10 theta, and this whole thing is going to be divided by what? By negative sine squared theta, right? So now again is that I need to get rid of cos and 10, right? So we know the fact that 10 is an identity, so I can replace that by that. So it's going to be here, it's going to be cos theta multiplied by what? By sine theta divided by cos theta, right? And this whole thing is going to be divided by negative sine squared theta. The coses are going to cancel out. So you're going to be left with what? With sine theta divided by what? Divided by negative sine squared theta, right? So since we have in the numerator, we have one sine, and the denominator, we have two sines. So this one is going to cancel out. So you're going to be left with what? We're going to be left with negative 1 divided by sine theta. I just took the negative on top, right? Remember the fact that 10, t is equals to sine. So this is going to be the same as negative 1 divided by t. And this is going to be how you solve this question. So now we're going to move to example 7, right? It says to simplify the following. So it says 2 sine, open bracket, 90 minus theta plus 90 minus x, right? Plus sine, then it's going to be 90 plus x, then divided by sine 90 minus x. Then the other one is going to be what? Minus cos 180 minus x, right? First thing is that everything looks okay, so we just need to reduce. So let's do that, right? So the first thing that you're going to do is that we're going to change this. So 90 minus is in the first quadrant, meaning it's going to be what? It's going to be, since it's 90, meaning it's a cofunction, so this is the same as 2 cos what? Cos x, right? And then here it's going to be what? It's 90 plus second quadrant, meaning what? Meaning sine is positive, so when we change it, it's the same as plus cos x, right? So that's going to be divided by what? Then in the denominator, we have 90 minus. 90 minus is the first quadrant. So this is going to be the same as what? As cos cofunction 90 cos x, right? Then the other one, it's minus. Then here's going to be 180 plus. 180 plus is in the third quadrant. Only 10 is positive. So this is going to be the same as what? It's negative cos x, right? So now let's simplify this. This is the same as 2, right? 2, let's just add them together. So this is in the numerator, is the same as 3 cos x divided by what? So this is going to be divided by cos x plus cos x, right? So this is going to be the same as 3 cos x, and this is going to be divided by 2 cos x. We have a cos x and a cos x, so they're going to cancel out. So your answer here is going to be 3 divided by 2. So your answer here is going to be 3 divided by 2. So now we're going to do double angles. As you know, the fact that double angles, it needs what? It needs reduction, right? So there's going to be a couple of questions that we're going to use reduction in the situation, right? So these are the double angles, right? So these are double angles. The first one is cos of A minus B is equals to cos A cos B plus, do you see the fact that here the sign is different? You said minus, but you actually need to say plus, right? And same applies with cos A plus B. Instead of saying plus, right, when you expand it, it's actually negative. And then sine A minus sine B, do you see the fact that you say sine A cos B minus, so it maintains its sign, right? Then you're going to say cos A multiplied by cos B. And then with sine A plus B, you see the fact that it still maintains its sign. So just remember the fact that with cos, it changes its sign, and with sine, it maintains its sign, right? So that's basically the 4 identities under double angle, right? So we're going to do the first question. The first question says, prove that sine 75 is equals to, then they give you the other side, right? So with proving, so let me just do this. Okay, go. So just want to change my pen. This is the left-hand side, right? And this is the right-hand side, right? So looking at the right-hand side, we see the fact that we're getting numbers, meaning our left-hand side, we need to use what? We actually need to use what you call this special angles, not identities, right? So remember our special angles is 30, it's 45, then it's 60. So we need to break down the left-hand side, right, in such a way, the fact that we use special angles, then we basically need to arrive into what? Into being the right-hand side. Because if you punch this into your calculator, trust me, you're not going to get this number. So we need to break down this side, right? So what do we see? We see the fact that 75, we can break it down, right, into what? Into being 30 and 45. So if you say 30 plus 45, right, that's actually equals to 75. So I can change the 75 into being what? Into being 30 and 45. And what do we not know about 30 and 45? They are special angles. So let's change that, right? So remember with what you call this, with proving, you take one side and simplify it so it can look like the other side. So we're going to say left-hand side is going to be equals to sine 75, right? Which is going to be equals to sine, open bracket, it's going to be 30 plus 45, right? Do you see the fact that this is what? This is a double angle. And what do we know? Double angle, this is the one that we're going to use, is sine A plus B, which is our A is 30 and our B is what? Is 45. And we're adding, right? So this is what it's going to be when we extend it. So it's going to be sine, right? 30. Then you're going to say cos 45, right? Then you're going to say plus. Then you're going to say what? You're going to say cos 30. Then you're going to say sine 45, right? So with that said, now we're going to basically find sine of 30, cos of 45, cos of 30, and sine of 45. So let's do that, right? So what sine 30 is equals to the following is the square root of 2 divided by what? Divided by 2. Then what's cos of 45 is root 3, right? Divided by 2. Then you're going to say plus what's cos 30? It's going to be root 2, right? Divided by 2. Then what's sine 45? It's actually 1 over 2, right? So now we're going to multiply numerator to numerator and denominator to denominator. So we're going to have root 2 multiplied by root 3 here. Then this is going to be divided by 4, right? Then here we're going to have what? It's going to be plus root 2, right? Divided by 4. Do we see the fact that we have the same LCD? So we can add the numerator. So it's going to be root 2 multiplied by root 3, right? Then you're going to say plus root 2. That whole thing is going to be divided by 4, right? So do you see the fact that from the question we have everything? We have the denominators being 4, and we have root 2, we have root 3, then we have what? We don't have 1. How do we get 1? It's by taking out root 2 as the common factor. Do you see the fact that it's common? So we're going to do that. So we're going to say root 2, open bracket, it's going to be what? It's going to be root 3 plus 1. Then this whole thing is going to be divided by 4. Do you see the fact that this and this is exactly the same thing? So this is equals to the right-hand side, which completes our proof. So now we're going to do example 2, right? It says determine the following expression without a use of a calculator, right? So what we see the fact that we have cos 65, then cos 35. Then the other side, we have what? We have cos 25 and we have cos 55. What do we see? We see the fact that we have cos, right? So we have cos, meaning we need sin, right? So we can convert this. You know the fact that you can change cos into being sine and sine into cos. So we're going to use cofunction, right? So look at when we do the following. If we say 90 minus what? Minus 25, right? What we're going to get, we actually going to get what? We're going to get the following. We're going to get the fact that this is actually equals to what? Is equals to 65, right? So meaning when we rewrite this 25, it's going to be the same as what? As saying 90, right? 90 minus 65, which is going to replace this one, right? So that's going to replace that one. So with 55, if we say 90 minus 55, what do we get? We see the fact that we're going to get 35, which is perfect. So meaning when we rewrite it, it's going to be 90 minus 35. And the reason why that's good is, do you see the fact that we have 65 here and we have 65? We have 35 here and we have 35. So this is going to change as being what? As being sine, right? Of what? Sine of 65. And this one is going to change as being what you call the sine of 35. So let's rewrite this. So this is going to be equals to what? To cos 65. That's going to remain the same. And it's going to be cos 35, right? And this is going to be plus, replace the 25. So it's going to be cos, right? Then open bracket, you're going to have what? You're going to have 90 minus 65, right? Then multiply by cos. Then it's going to be 90 minus 35, right? So 35. Made a mistake. This is 35, right? So this is going to be 35, right? So let me just rewrite our diagram here. So our diagram, remember, is what? Here it's going to be 90 minus theta. And here it's going to be 90 plus theta. Remember, we just need 90, so I'm just going to leave it like that. And this is all students take coffee, right? So we see the fact that this is going to be equals to cos 65. Then this is going to be cos 35, right? And it's going to be plus 90 minus is in the first quadrant. So this is the same as, since everything in the first quadrant is positive, so this is going to be the same as sine 65. And 90 minus still in the first quadrant. So this is multiplied by sine. What? Sine. So it's going to be sine 35. So since the angles are the same, do you see the fact that we're going to use which one? We're going to use, since we're adding, so we're going to use this one, right? So it's going to be equals to what? Subtracting the two angles. So this is the same as cos, open bracket, you're going to say 65 minus 35, right? So when you simplify that, it's going to be cos is equals to what? To 30 degrees. Punch that into the calculator, you're going to get the fact that it's equals to root 3 divided by 2. So this will be your final answer for this question. So now we're going to do example 3. Example 3 is actually what? If you look at it, it's actually Cartesian, right? So we're using the identity plus the Cartesian. So here we have what? We have 13 sine alpha plus 5 is equals to 0. Then they tell us that alpha needs to be between 0 and 270. So let's start with that. So first we need to simplify this so they can have a single trig ratio. So this is the same as 13. Then you're going to have sine, right, alpha. Then this is going to be plus 5 is equals to 0. Take the 5 to the other side. So this is the same as 13 sine alpha is equals to negative 5. Divide both sides by 13. So sine alpha is basically equals to what? To negative 5 divided by 13, right? So this is the same as what? As opposite over hypotenuse, right? So let's sketch it. So we know the fact that we're going to have something like this, right? So they tell us the fact that, so we know the fact that this is all student take coffee. So where is sine negative? It's negative in the third and fourth quadrant. But very important, they tell us the fact that alpha is between what? It's between 0 and 270. So we know the fact that this is 0, this is 90, this is 180, and this is 270, right? So meaning it cannot be in the fourth quadrant because of 0 till 270. It's either it's in the first, second, or third. So we need to pick the third quadrant because that's where sign is negative, right? So that's where our triangle is going to be. And this is going to be alpha, right? So let's substitute things so that we can complete the diagram. We know the fact that it's opposite, so it's going to be -5 here over hypotenuse, which is going to be 13, right? So now we need to solve for this part. So it's going to be what? It's going to be x squared is equals to x squared plus y squared. Let's substitute. This is the same as 13 all squared is equals to what? Is equals to, x is the one that we're looking for. Then it's going to be plus, then it's going to be -5 all squared, right? So with that said, we know the fact that we're going to have what? We're going to have 169 is equals to x squared. That's going to be plus 25. Take 25 to the other side. So it's going to be 144, right, is equals to x squared. So therefore, x is equals to squaring both sides. X is equals to plus or minus 12, right? So we look at it, x is on the negative side of, it's on the negative side of x. So x here needs to be equals to -12. So here's going to be -12, right? So now our diagram for the first part is complete. So now let's do our second diagram, right? So first we need to simplify it. So it's going to be what? It's going to be 13 again, right? But now it's cos beta, right? -12 is equals to 0. Simplify that, it's going to be the same as 13, right? Cos beta is equals to +12. Divide both sides by 13, so it's going to be cos beta is equals to what? Is equals to 12 divided by 13, right? But they tell us the fact that cos needs to be between 90 and 360. So let's draw our diagram, right? So in our diagram, we know the fact that this is all student take coffee. Where is cos positive in the first and also in the what? In the fourth diagram, right? So we know the fact that these needs to be between 90. So this is 0, this is 90, this is 180. So this is 180, right? This is 270, and this is 360, right? So do you see the fact that they say it's beta needs to be between 90 and 270? So it cannot be in the first quadrant. So by default, our triangle is here, right? So this is going to be 90 degrees, and beta is going to be here, right? This is equals to what? This is adjacent over hypotenuse. So adjacent needs to be here. So this is going to be 12. Hypotenuse is going to be 13 here, right? So now we need to find y. So finding y, it's going to be r squared is equals to x squared plus y squared, right? So this is going to be what? This is the same as 13 all squared is equals to, then it's going to be 12 squared plus y squared, right? So this is going to be 169 is equals to what? To 144, right? Plus y squared. So subtract, so you're going to get what? You're going to get 25 is equals to y squared. So therefore y is basically equals to plus or minus 5. Then do you see the fact that y is where it's in the negative? So y here is equals to -5. So this is going to be -5, right? So now we sorted, we have both our diagrams, right? So now we can start answering the question. So number 1, A, it says what? We need to find 10 alpha minus 10 beta, right? So from the diagram of alpha, we know the fact that 10 is what? It's adjacent, right? Over, it's opposite, it's opposite over adjacent. So what's opposite is going to be -5. Then adjacent is going to be -12, right? So that's from the first diagram. Then from the second diagram, remember the fact that it's going to be minus. Then it's going to be what? 10 is what? It's opposite over adjacent. So it's going to be opposite is -5 again this side. Then adjacent here, right, is going to be 12, right? So then you're going to just do what? Then this is going to be what? This is going to be the same as 5 divided by 12, right? Then this is going to be plus 5 divided by 12, right? So since the denominator are the same, this is going to be the same as having what? As having 10 divided by 12, which is going to give us what? Which is going to give us 5 divided by 6. So that's A, right? So now we're going to do B, right? So with B, we're going to have sine, right? Open bracket is B minus alpha, right? So that's going to be what? This is going to be this identity. Do you see that? So that's basically equals to what? To sine beta, right? Then this is going to be sine alpha. Then you're going to say minus cos beta. Then you're going to say sine alpha, right? So we know the fact that the nice thing is that we have what you call this sine beta. We need to find it from here. So we know the fact that what sine beta is opposite of our hypotenuse. So this is going to be what? This is going to be negative 5 divided by 13. So that's sine beta because it's in here. Then sine alpha. So this is not sine alpha, it's cos alpha. Did a mistake there. Let me just fix that. So this is going to be cos alpha, right? So where's cos alpha? Cos alpha is here in the first diagram. It's adjacent of our hypotenuse. So this is going to be negative 12 divided by what? By 13, right? And this is going to be minus what? Cos beta is actually this one. So it's going to be the same as what? As 12 divided by 13. Then sine alpha is actually this one. So it's going to be negative 15 divided by what? Divided by 13, right? So we're going to multiply those two together. So it's going to be negative 5 divided by what? Divided by 13 multiplied by what? By negative 12 divided by 13. You're going to get a positive, which is you're going to get 60 divided by 169, right? And this is going to be minus, then open bracket, if you say 12 divided by what? By 13, multiplied by what? By negative 15 divided by 13, you're going to get your answer as negative, right? 180 divided by what? Divided by 169, right? So now this is going to be the same as having 60 plus, so it's going to be 60 divided by 169 plus 180 divided by 169. 169 is a common factor, a common denominator. So this is the same as adding the numerator. So it's the same as saying 60 plus 180, which is you're going to get 240 divided by 169. Then that's basically going to be 240 divided by 169, which is going to be the final answer, right? So now moving to C, whether I can squeeze it. I hope I can squeeze it here, right? So moving to C, we see the fact that C, we have what? They want cos, then open bracket is going to be what? It's going to be alpha plus beta. So this is the same as using this identity. So it's going to be the same as finding cos alpha cos beta, right? Minus sine alpha sine beta. Ooh, doesn't look like we have space. And that's going to be what? What's cos alpha? Cos alpha is from where? It's from this diagram, which is going to be what? Adjacent. So this is going to be negative 12, right? Divided by 13, because it's adjacent over hypotenuse. Then cos beta is this one, which is going to be 12 divided by 13, right? Then we're going to have minus, and I'm just going to do sine. Sine alpha is going to be this one, which is going to be what? Which is going to be negative 15 divided by what? Divided by 13. Then this is going to be multiplied by what? By sine beta, which is from here, which is going to be negative 5, which is opposite over hypotenuse, divided by 13, right? So that's going to be equals to, let's simplify this one. If you say negative 12 divided by 13 multiplied by 12 divided by 13, you're going to get negative 144 divided by 169, right? Then if you say negative 15, right, multiplied by what? Divided by 13, multiplied by another negative 15, right? So it's another negative 15, negative 5, sorry, divided by 13. You're going to get the fact that your answer is negative what? Negative 75, right? So no. Your answer needs to be positive because it's negative and a negative. So your answer is going to be positive 75. But remember the fact that we have a negative. So this is going to be negative 75 divided by 169, right? So denominators are the same. So it's the same as adding the numerator. So it's going to be 144 minus 75, which is you're going to get negative 219 divided by 169. So our final answer is going to be this one, right? So that's how you would do all three questions. So what we're going to do now, we're going to do general solution. General solution is the same as solving for x, but in a trig way, right? So now we're going to do example 1. It says determine the general solution for sine theta is equals to 0.3, correct to 1 decimal place, right? So with general solution, what do you need? You need the following. You need the reference angle. Then after needing the reference angle, you need to determine where your trig ratio is positive or if it's negative. Then from there, picking from there, then you can write your answer, right? So first thing first is your reference angle, right? So your reference angle here, right? So your reference angle is basically going to be equals to arc sine. So it's going to be arc sine, right? Then it's going to be 0.3, right? Then get that. If you punch that into the calculator, you're going to get 17, 5, right? So you're going to get 17 over 5. Then you're going to go back to the question and check where sine is positive. Sine is positive in where? In the second and in the first quadrant, right? So looking at the first quadrant, right? So now you're going to go and say first quadrant. So we're going to look at the first quadrant, right? So this is going to be the first quadrant. This reference angle that you found is going to be this theta, right? So we see the fact that in the first quadrant, it's just theta. So your theta here, right, is basically going to be equals to just the reference angle, which is going to be 17,5, right? Then you're going to say plus, because this is sine, right? You're going to say plus k. Then you're going to say what? You're going to say 360, right? Then, or, right, we're going to look at where sine is positive, which is in the second quadrant. So you're going to say second quadrant, right? We see there, it's what? 180 minus theta. This theta is the same as the reference angle, right? So it's the reference angle. So here it's going to be theta is equals to, because of this theta, is equals to what? Then you're going to say 180, right? Minus 17,5, right? Then this is going to be plus k. Then you're going to say 360 degrees, right? Then we need to simplify this one. So when we simplify it, we're going to get the fact that theta is equals to what? It's equals to 162, right? 5. Then you're going to say plus k. Then you're going to say 360, right? And then since you said k there, then you're going to say k is an element of real numbers. And this is how you would solve for this question. Now you're going to move to question 2, right? With question 2, it says determine the general solution. Then they say give your answer in the correct 1 decimal place, right? Remember the fact that one more thing is that, and as we do questions or as we do example, you're going to see how the question changes, right? Do you see the fact that here we have cos 2 theta, right? So the first thing that you need to do, just change this cos theta and make it into maybe like x, right? So just say let x equals to 2 theta, right? And you'll see why this is important, right? So your question is the same as having cos x is equals to what? Is equals to negative. There's going to be 0.6427, right? So it looks like you just have a trig ratio on the other side and you just have a number on the other side, right? So as I said, the fact that you find the reference angle, right? So here is going to be your reference angle, which is going to be equals to cos, right? And then never, very important, never substitute a negative number when you're looking for the reference angle. The negative number tells you which quadrant to look at, right? Never substitute the negative number. So here you're going to just say 0.6427, right? Then punch that into the calculator. You're going to get your answer as being what? As being 50 degrees, right? Then now you're going to determine where cos is what is negative. Cos is negative in the second and is negative in the third quadrant, right? So in the second quadrant, what do you see? It's 180 minus, remember the fact that this is the reference angle, right? So this is the reference angle, and also here is the reference angle, right? So it's going to be what? 180, right? Minus, so you're going to say x, sorry. So, okay. So you're going to say what? You're going to say x because it's cos x, right? So you're going to say x is equals to, then you're going to say 180 minus what? Minus 50, right? And you're going to say plus, cos is what? Cos is plus k 360, right? This is the period, right? Then now what you're going to do, you're going to simplify this. So it's going to be x is equals to what? So when you say 180 minus 50, you're going to get 130. So this is going to be 130 plus k, then it's going to be 360, right? So now we're going to substitute this x by this 2 theta. So it's going to be 2 theta because we're determining theta, right? So 2 theta is going to be equals to 130 plus k, then you're going to say 360. We want theta alone, so we're going to divide throughout by 2. So this is going to be the same as theta is equals to 130 divided by 2 plus k. This is 360. Then it's going to be 360 divided by 2, right? So your answer here is going to be theta is equals to what? 265 plus k, then it's going to be 180, right? So you're done with the second quadrant. Or, right, it's going to be what? It's going to be in the third quadrant. So it's going to be third quadrant, which is what? Which is 180 plus theta. So this is going to be the same as x is equals to 180 plus our theta is 50. So it's going to be 50. Then you're going to say plus k 360, right? Then now it's going to be x. So when you say 180, right, plus 50, you're going to get 230. Right, plus k, then you're going to have 360. Substitute your x price by 230 by 2 theta. So it's going to be 2 theta is equals to what? It's going to be 230, right? Plus you're going to say k, then it's going to be 360 divide throughout by 2. So it's going to be theta is equals to what? Is equals to 230, right? Divided by what? Divided by 2. Plus you're going to say k, 360 divided by 2, right? Punch that into the calculator. You're going to have theta is going to be equals to 115 plus what? Plus k, 180, right? Then you're going to say when k is an element of integers. Then you are done with number 2. So now we're going to do example 3, right? So with example 3, it says determine the general solution for 10, then open bracket, 2 alpha minus 10 degrees, it's equals to 2,5. Then they give us a restriction and they tell us the fact that it's between what? Your alpha needs to be between the following. It needs to be between negative 180 and 180, right? So as per usual, we start by finding the reference angle, then checking where 10 is what? Is positive because we have a positive number here. But before we do that, we see the fact that inside is alpha, it's 2 alpha minus 10. So let's change that into being x, right? So that like everything becomes a little bit easier. So we're going to say let x equals to what? To 2 alpha minus 10 degrees, right? So now it's the same as 10. X is equals to what? To 2,5. So now let's find the reference angle, which is going to be equals to 10. Right, negative 1, then it's going to be what? It's going to be 2,5, right? Punch that into the calculator. You're going to get that your 10 is what? Your reference angle, it's going to be equals to what? It's going to be equals to 68,2, right? So that we have that. So we have our reference angle as being that. Then we take away, because of this is positive, do you see the fact that it's positive 10, right? And we see it from here. We see it from here. We see that it's positive 10, right? So we check where is it positive. It's positive in the first quadrant and also in the third quadrant, right? So in the first quadrant, we see the fact that it's just theta, which is theta is a reference angle, right? So it's going to be our reference angle. So it's going to be what? It's going to be x is equals to what? X is going to be equals to just 68, 2. Then you're going to say plus k. Then with 10 is going to be k 180 degrees, right? For 10, it's 180. For cos and sine, it's 360, right? So now we're going to substitute what? Our x, which is going to be 2 alpha, is equals to, it's going to be 2 alpha minus, erase that. So it's going to be minus 10 is equals to 68, 2 plus k, then it's going to be 180 degrees, right? Then now we're going to take 10 and add it here. So it's going to be the same as 2 alpha is equals to 68, 2 plus 10. Then you're going to say plus k. Then it's going to be 180 degrees. So it's the same as 2 alpha is equals to what? 278, 2 plus k. That is going to be multiplied by 180 degrees. Divide by 2. So it's going to be alpha is 78 divided by 2, 78, 2 divided by 2, plus k, then it's going to be 180 divided by 2. So alpha here is basically the same as being equals to what? 239, 1, right? Then it's going to be plus k, then it's going to be 90 degrees, right? So, or, remember the fact that the other quadrant is the third quadrant, so it's going to be the third quadrant. So it's going to be what? It's going to be the third quadrant. So it's going to be what? It's x is equals to what? To 180, right? 180 plus what? Plus 68, 2. Then it's going to be plus k. Then it's going to be 180, right? So x here is going to be equals to what? Then you're going to say 180 plus 60, 8,2 is the same as 248, 2. Then you're going to say plus k, then it's going to be 180, right? So x, now we're going to substitute x, which is we know is 2 alpha minus 10 is equals to 248, right? 2 plus k, then it's going to be 180, right? Minus the 10. So it's going to be 2 alpha. It's going to be 248, right? 2 plus 10. Then you're going to say plus k. Then it's going to be 180, right? So that's going to give you 2 alpha is equals to 258, 2 plus k. Then it's going to be 180, right? Then divide by 2. So it's going to be alpha. It's going to be 258, 2 divided by 2, then it's going to be plus k, then it's going to be 180 divided by 2. So therefore, alpha is going to be equals to what? It's going to be equals to 129, right? 1, then it's going to be plus k, then 90 degrees. Then now, remember that we have a restriction, right? Our restriction, it says the fact that it needs to be between what? It needs to be between negative 180 and 80, right? And remember the fact that we always say that k is an element of integers, right? So now we need to find the numbers, the angles that are between this negative 180 and and positive 180, right? So I'm just going to change my color here, right? So we're going to start by looking for, we're going to start at k is equals to negative 3, right? So let's find that for both of them, for both these two solutions, right? So when we substitute there, when we substitute negative 3 and k, it's going to be equals to what? You're going to say 39, right? 1 plus, then it's going to be k, which is going to be what? Which is going to be negative 3, right? Then we're going to say multiply by 90, because that's 90, right? And what do you get? You're going to get your answer as being the following. If you say 39, 1, right? Plus, then you're going to say negative 3. Then you're going to say multiply by 90. You're going to get the fact that your answer is equals to negative 230,9. Do you see the fact that this is not part of this region? So we cannot use this one, right? So now we only check for this one. Let's check for this one. So that one is going to be alpha is equals to what? It's going to be equals to 129,1 plus k is -3, right? Then we're going to have 90. So it's going to be what? It's going to be the same thing, but it's going to be 100. So here it's going to be 129,1, right? So you're going to get your answer as being what? So it's going to be 129, right, multiplied by 3. So you're going to get your answer as being negative 40,9. So do you see the fact that this one is part of our solution? So this one, and I'm going to just highlight the ones that are part of our solution. So this one is going to be the one that's part of our solution, right? So you're going to leave it there. So now we're going to move when it's k is equals to what? K is equals to -2, right? So finding alpha is going to be equals to 39,1. Then you're going to say plus, then it's going to be -2. Then it's going to be 90, right? So let's do that. So it's going to be 39,1, right? Plus, then it's going to be -2 now. Then it's going to be 90, right? So you're going to get your answer as being what? As being -140,9. But we already have a -140, right? So that we can't duplicate it. Or we can have when alpha, now we're dealing with this one, which is 129, right? 1, then it's going to be plus, then it's going to be -2, then it's going to be 90. Let's check what do we get there. So now we're going to say 129, right? 1, right? Which is we're going to get our answer as being -50,9. So we see the fact that even that one is part of our solution because of it's definitely in between negative 180 and 180, right? So that one is part of our solution. So now we're going to move when k, right? So we're going to move when k is equals to -1, right? So this is going to be what? When alpha is equals to 39,1 plus, then this is going to be -1, then this is going to be 90. What are we going to get? So if we say 39,1, right? Plus, then it's going to be -1, then multiply by 90, right? We get our answer to being what? To being -50. Do you see the fact that -50,9, we already have it, so we can't duplicate it. So now if we say alpha and say 129,1 plus -1, then it's going to be 90. What are we going to get there? So if we say 129 now, 129,1, we're going to get our answer as being 39, right? So this is going to be 39,1. So do you see the fact that this is going to be our solution because of it's definitely part of this region, right? So now moving on, if I say k is equals to 0, right? Because 0 is an integer. So we know the fact that it's going to be alpha is equals to 39,1 plus, now it's going to be 0 multiplied by 90, which is you're going to get 39. We're not going to use that one because of we already have it. Now if we say alpha is equals to what? Is equals to 129,1, right? Plus, then here's going to be 0, then 90. Our answer is going to be 129,1. Do you see the fact that this one now is part of our solution because it's definitely in between here, right? So now we're going to do what? We're going to do when k is equals to 1. So when k is equals to 1, we're going to have alpha is equals to what? To 39,1 plus, then it's going to be 1 here, then it's going to be 90, then it's going to be equals to what? It's going to be equals to, so now we're going to have the following. So if we say 39, right, 39,1, then we're going to get our answer as being 129, which we already have that, so we can't duplicate it, right? And then if we now have when alpha is equals to what? It's equals to 129,1 plus, then open bracket, it's going to be 1, then here's going to be 90, it's going to be equals to. So now if I have 129, I get my answer, the fact that it's 219. 219 is definitely greater than 180. So that one is not part of our solution. So my solution is going to be the one that I highlighted, right? So therefore, my final answer, right, is going to be what? When alpha, so your final answer, you're just going to write that. So it's going to be negative 140, right, comma 9. Then it's going to be negative 50, right, comma 9. Then it's going to be what? It's going to be 39, comma 1, right? Then it's going to be the last one, which is 129, comma 1. So these angles, right, are part of this region, right? So these angles are part of this region, and that's how you would do this question. So now we're going to do example 4. It says determine the general solution of sine, open bracket, theta minus 20 degrees is equals to what? Is equals to cos 2 theta, right? Here, our goal is that we're going to use co-function, right? What do we know? We know the fact that we can rewrite this, right? And the goal is to make this side, this two sides, trig ratios the same. So we need to convert this into being sine, right? So we know the fact that we can rewrite this as being what? As being sine, right? Open bracket 90 minus 2 theta. If you find this, you're going to go back to cos 2 theta, right? So this is the first step. So now we know the fact that sine, right? Sine theta minus 20 degrees is basically equals to sine. Then this is going to be what? 90 minus 2 theta, right? So with that said, now since our trig ratios are the same, we can drop them. So this is the same as saying what? Theta minus 20 degrees is equals to 90, right, degrees minus 2 theta. Then you're going to say what? Because of cos and sine are what? Are k 360. So you're going to say plus k 360 degrees, right? So with that said, now we're going to solve for what? We're going to solve for theta. So I'm going to take theta to the other side. So this is going to be the same as theta plus 2 theta is equals to 90 degrees. Then take the 20 degrees. So it's going to be plus 20 degrees. Then this is going to be plus k 360 degrees, right? So this is the same as 3 theta is equals to what? 90 plus 20 is going to be 110 degrees plus k 360 degrees. Divide by 3. So it's going to be theta is equals to 110 divided by 3 plus k. Then this is going to be 360 divided by 3, right? So theta here is going to be equals to 36, right? 36, comma 7, right? Plus what? Plus k, then it's going to be 120, right? Now we're not done, right? We have this, right? Now we need to check where both cos and sine are positive and when both cos and sine are negative. So where is it where both sine and cos are positive? It's in the first quadrant. The first quadrant is when both cos and sine are positive, right? And where are they both negative? Do you see the fact that it's in the third quadrant, right? So now we're going to calculate this using the quadrant, right? So here, what do we know? We know the fact that this is what? This is for the first quadrant because of this theta, your answer is going to just remain like this, right? Because we already solved it. So for the first quadrant, so for the first quadrant, it's going to be what? It's going to be just theta is equals to, then you're going to say 360, not 360. It's going to be, so it's going to be 36,7 plus k, then this is going to be 120 degrees. And I'm just going to write here where both sine, right, sine theta and cos theta are positive so that you can remember, right? Both sine theta and cos theta are positive, right? Because that's what we're looking for. We're looking for a quadrant where they're both positive and a quadrant where they're both negative, right? So the first quadrant is where they're both positive, right? So now for the third quadrant, right? So this is going to be O for the third quadrant, right? So for the third quadrant, it's when both of them are negative. So that's both sine theta and cos theta are negative, right? So we know the fact that it's going to be what? Do you see the fact that it's 180 plus? So I'm going to go back to this stage. Do you see this stage? This is the one that I'm going to use. So you're going to say 330 because of our reference angle here, it's 110. So it's going to be 3 theta. Then you're going to say what? You're going to say 180. And plus, we add the reference, which is our reference is going to be 110. Just to emphasize it more, I'm going to highlight it. This is actually our reference angle. So I'm just going to write a note there. No, I don't want to change highlighter. So I'm going to say 110 is, so I'm going to say reference angle is equals to 110 degrees, right? So this is the reference angle, right? So this is going to be plus, then it's going to be K 360 degrees, right? So this is going to be theta is equals to 110, right? 110 plus 180 is going to give you what? 290. So this is going to be 290 plus K 360, then divide by 3. So alpha here, theta is going to be equals to what? It's going to be equals to, when you say 290 divided by 3, which is going to give you what? Which is going to give you 96, right? 0.67 plus K, then this is going to be 120. So this will be your answers. Then remember that K is an element of integers. So this will be your final answer for this question. Going to do example 5, which we're going to start dealing with the quadratic, right? So it says find the general solution of 4 sine squared theta, right, is equals to 3. So we see the fact that we have what? 4 sine squared theta is equals to 3. So what we're going to do is we're going to divide both sides by 4. So we're going to say sine squared theta is equals to 3 divided by 4, right? Let me just fix that. Right? So now what we're going to do is we're going to square root both sides. So when we square root both sides, we're going to have the following. It's going to be sine theta is equals to plus or minus, then this is going to be the square root of what? Of 3 divided by 4, which is going to be sine theta is going to be equals to plus or minus, then it's going to be the root of 3 divided by 2, right? When we simplify it, right? So this is the same as having sine theta is equals to negative root 3, right, divided by 2, or sine theta is equals to positive root 3 divided by 2, right? So now we're going to use the general solution to solve for both of them, right? So now just looking at what? We're just going to look for this one, right? So concentrating on this one, we're going to solve for this one. So 4 sine theta equals to negative root 3 divided by 2, right? So first we need to find the reference angle. So the reference angle here, it's going to be equals to the following. It's going to be equals to arcsine, right? Then you're going to say root 3. Remember the fact that we never take the negative, divided by 2, which we're going to get our reference angle as equals to 60 degrees, right? Then we're going to check where sine is negative. It's negative in the third and in the fourth quadrant. So now in the third quadrant, quad, right? We see the fact that we have the following. We're going to have the fact that this is going to be what? This is going to be theta is equals to 180 plus 60, right? And this is going to be plus K 360 degrees, right? So this is the same as theta is equals to what? It's equals to 240. So this is going to be 240, right? Plus K, then you're going to say 360. Or, right, it's going to be in the what? In the fourth quadrant. So it's going to be the fourth quadrant, right? So in the fourth quadrant, it's going to be what? It's going to be theta is equals to 360 minus. So it's going to be 360 minus 60 degrees. Then you're going to say plus K 360, right? So this is the same as theta is equals to 300 plus K 360, right? So we sorted with the one with the negative. Now looking at the one with the positive, meaning I'm just going to say 4 sine theta is equals to root 3 divided by 2, right? So since the reference angle is going to be the same, now we're going to look where sine is positive, and it's positive in the first and in the what? In the second quadrant, right? So this is going to be the same as theta is equals to what? It's just going to be 60 degrees, right? Then you're going to say plus k, then it's going to be 360, right? Or in the second quadrant, so this is going to be the second quadrant. Forgot to write first quadrant there, it's fine. So in the second quadrant, it's going to be what? It's going to be theta is equals to 180, right? Minus 60, right? That's going to be plus k 360. So therefore, theta is going to be equals to what? It's going to be equals to 120 degrees plus k 360 degrees. So when k is an element of integers, and that's how you would solve this question. So now we're going to look at another quadratic example. It says find theta if, then they give you, right? And they give you a restriction with this one. So first we need to solve for theta. So if it's like this, where you have, do you see the fact that you have cos theta squared and another cos? What you do is you're going to say let x equals to what? To cos theta, right? So let's substitute. This is the same as having 2x squared, right? Minus x, that's going to be minus 1, is going to be equals to 0. Factorize that is the same as having 2x, right? Plus 1, right? Then the other bracket is going to be x minus 1, and this is going to be equals to 0. So this is the same as having when x is equals to negative 1 over 2, or the other one is x is equals to positive 1, right? Substitute your x, so this is the same as having cos theta is equals to negative 1 over 2, or the other one is cos theta is equals to positive 1. So first we're going to deal with the one for cos theta is equals to negative 2. So I'm going to say for cos theta is equals to negative 1 over 2. So first you need to find the reference angle. So the reference angle is going to be equals to what? It's going to be equals to cos. It's going to be equals to cos, right? Then it's going to be positive 1 over 2. So when you get there, you get that your reference angle is going to be equals to 60 degrees, right? So now we're going to check where cos is negative. It's negative in the second and in the third quadrant. So for the second quadrant, right? So for the second quadrant, it's the same as having what? It's the same as having theta is equals to what? Is equals to 180 degrees, right? Then you're going to say minus 60, right? So that's going to be plus k, that's going to be 360, right? So simplify that, it's going to be theta is equals to what? Theta is going to be equals to 180 minus 60, which is going to give you 120 plus k, then you're going to say 360, right? So now, or remember the fact that we have to deal with the third quadrant. So it's going to be the third quadrant. We're going to have the following. It's going to be what? It's theta is equals to 180 plus here. So it's going to be 180 plus 60, right? Plus k, then it's going to be 360. So when you say 180 plus, it's going to be theta is going to be equals to 240, right? Plus k 360, right? So we are sorted with when cos theta is equals to negative a half. So now for cos theta is equals to 1, we need to find the reference angle. So the reference angle is going to be a cos, right, of 1, which we found the fact that our answer for that is going to be what? It's going to be 0 degrees, right? So it's going to be 0 degrees. Then you ask yourself, where is cos positive? It's positive in the first and in the fourth quadrant, right? So meaning for the first quadrant here, right? So for the first quadrant here, it's going to be what? It's going to be just the angle. So it's going to be theta is equals to 0 degrees plus k. Then you're going to say 360 degrees, which is the same as theta is equals to k 360 degrees, right? Or remember the fact that for the fourth quadrant, so it's going to be for the fourth quadrant, right? So it's going to be what? It's going to be theta is equals to what? To 360 minus 0 degrees, right? Which is going to be plus k 360. So this is going to be the same as theta is equals to 360 degrees, right? Plus k 360. Then now, for k is an element of integers. And that's how you would solve this question. So now we're going to do example 7, right? It says, find alpha if 2 sine squared alpha minus sine alpha, then cos alpha is equals to 0. Then they give us a restriction. Do you see that? So let's do that. So first, we're going to have to take out sine x as a common factor. Do you see the fact that it's common? So we're basically factorizing it. So we're going to say 2 sine squared alpha minus sine alpha, right, cos alpha, and this is equals to 0. So this is going to be the same as saying sine alpha, open bracket, you're going to have 2 sine alpha, right? Then this is going to be minus what? Minus cos alpha is equals to 0. So this is the same as having sine alpha is equals to 0, or having 2 sine alpha minus cos alpha is equals to 0. So this one is okay. So let's solve this one. So it's going to be 2 sine alpha is equals to cos alpha, right? So divide both sides by cos. And the reason why we're doing that, because we know this identity. Remember this identity? We know this identity. So that is why we're dividing both sides by cos. So this is going to be the same as 2 sine alpha divided by cos alpha, right, is equals to cos alpha divided by cos alpha, right? So this is going to give us 210 alpha is equals to what? Is equals to 1, right? So therefore 10 alpha is basically equals to 1 over 2. So we have sine alpha is equals to 0 and 10 alpha is equals to 1 over 2. So now for looking for just sine alpha is equals to 2, let's find the reference angle. So the reference angle is going to be equals to arc sine, right? Then it's going to be 0, which is going to give us what? Which is going to give us 0. So where is sine positive? Sine is positive in the first and second quadrant. So we're going to say what? We're going to say for the first quadrant, right? So for the first quadrant, it's basically going to be what? It's going to be alpha, not theta. It's going to be alpha is equals to what? Just 0. So it's going to be 0 plus k 360 degrees, which is the same as alpha is equals to what? 2 k 360 degrees, right? So we sorted with that one. So now looking at the what? Looking at the second quadrant. So looking at the second quadrant, it's what? It's 180 minus theta. So it's going to be the same as alpha is equals to 180, right? Minus 0 degrees, right? Then it's going to be plus k, then it's going to be 360. So this is the same as alpha is equals to 180 degrees, right? Then it's going to be plus k 360. So we sorted with that one, right? So now looking at 10. So let me just erase this. So now just looking at what? Looking at 10. So looking at 10, alpha is equals to 1 over 2. Find the reference angle, which is going to be equals to what? Which is going to be equals to arc 10, right, of 1 over 2. So what is the reference angle there? So when I say arc 10, 1 over 2 is equals to 26,6, right, degrees. So now we're going to check where cos is positive. It's positive in the first and in the third quadrant. So in the first quadrant, right, we're going to have what? We're going to have that alpha is equals to what? Is equals to, what you call this? So in the first quadrant, it's just going to be the reference angle. So it's going to be 26, right, comma 6. Then you're going to say plus k then this is going to be 180 degrees, right? Then now moving on to the, to the third quadrant. So it's going to be O in the third quadrant, right? So it's going to be what? It's going to be alpha is equals to what? It's equals to 180. So it's going to be 180. Then we're going to say plus what? Plus 26,6, right? Plus k, then this is going to be 180, right? So now simplifying that, it's going to be alpha is equals to 206, right? Comma 6. Then we're going to say plus k 180, right? But remember the fact that we have a restriction. We have this restriction, right? So with this restriction, I'm just going to change my color. Is that now we need to look for values that are within 0, that are between 0, right? Including 0 till 360, right? So since in our case, looking at it, we don't have any negative numbers, I'm going to start at k is equals to 0, d is equals to 0, right? And the reason why I'm doing that is that I know the fact that, okay, we can start actually let's start at k is equals to -1, right? Just to check whether from -1, do I have any values, right? So when I say k is equals to -1, now when we say k is equals to -1, so we're going to start with this side. We know the fact that it's going to be what? When k is -1, so it's going to be -1, then it's going to be 360. So this is going to be equals to -360. So this one can't be the answer, right? And then the other one is, let me just do it here. When alpha is equals to, I'm going to look at this 180. So I'm going to say 180 plus, then it's going to be -1. Then we're going to have 360 here. What are we going to have? So if we say 180, right, minus 360, I'm going to get a negative value, which is -180, right? So also this one is not part of our solution. Now let's look at this too. So if I say alpha is equals to 26, right, comma 6, then I'm going to say plus -1, right? Then it's going to be 180. Let's check what we're going to get. So 26,6. Then if you say minus 180, you're going to get a negative value. So this is going to be equals to what? To -153, which is this one also is not part of our solution. And then when we say alpha is equals to 206, right? 206,6, then you're going to say -1, then it's going to be 180, right? What are you going to get? So if you say 206,6, right? Then you're going to say plus, then it's going to be -1, then you're going to say 180, right? So it's going to say multiply by 180. It's going to give you the following. This is going to give you 26. Do you see the fact that this is going to give you 26,6? So this one is going to be part of the solution. See that this one is part of the solution. Let's highlight it. So this one is going to be part of the solution. So now if I say k is equals to 0, let's check. So if I say k is equals to 0, if I say alpha is equals to 0, then say 360 here. This is going to give me 0. So this is part of the solution, right? So let's highlight it because of it's including 0, square bracket, it's including 0. Then if I say here, so now if I say alpha is equals to 180, right? Then it's going to be plus, then it's going to be 0, then it's going to be 360. 180 is part of the solution, right? So this 180 is part of the solution. So let me highlight that, not erase it, highlight that, right? So now moving on, if we say alpha is equals to 26,6, then it's going to be plus 0, then it's going to be 180, right? That's going to be also part of the solution because you're going to get 26,6. So that's part of the solution. So that is part of the solution, right? So now if I move to the last one here, which is going to be alpha is equals to 206,6, then it's going to be plus, then this 0, then 180, 26, 0, 206,6 is also part of the solution, right? Because it's between this. So that is also part of the solution. So now I'm going to move when k is equals to 1. So k is equals to +1. So now it's going to be alpha. Then we're going to have what? We're going to have -1, +1, sorry. Then it's going to be 360, which our answer here is going to give us positive 360. This is including 360, so that is part of our solution because of a square bracket, meaning including, right? So now let's move here, which is going to be alpha is equals to what? To 180, right? Then it's going to be plus, then it's going to be 1, then it's going to be 360. You're going to get 180 plus 360, which you're going to get 500 and what? 504, right? 540. So that is not part of our solution. So if we say alpha is equals to 26,6 now, plus, then it's going to be 1, then it's going to be 180, right? So it's going to be 26,6, then it's going to be plus 180. You're going to get the following. You're going to get 206,6. We already have that, so I'm not going to duplicate it. Then we're going to have alpha is equals to what? It's equals to 206, right? 6 plus, then it's going to be 1, then it's going to be 180. You're going to get 206,6, then plus 180. You're going to get your answer as being what? 386,6. That is not going to be part of our solution. It's greater than 360. So now let's check when we have k is equals to 2, right? So it's going to be the same as alpha is equals to what? 2k, which is going to be 2, then it's going to be 360, right? So that's going to be equals to what? 2 multiplied by 360. That's 720. That's not part of our solution. Then alpha equals to 200. It's going to be 180, right? Plus, then it's going to be 2, right? Then it's going to be 360. You're going to get 180, right? Plus 2, open bracket, 360. And I get your answer is 900. That's definitely not part of our solution. Then now if I say alpha is equals to 26,6 plus 2, then it's going to be 180. I'm going to get 26,6 plus, if I say 2, then it's going to be what? 180. I'm going to get 386,6, right? Definitely not part of the solution. Then the other one is 206,6 plus, if you say 2 multiplied by 180, right? You're going to get the fact that 206,6 plus 2, then it's going to be 180. And you're going to get your answer as being 500 and what? 566,6, right? Definitely not part of the solution. So your solution is the ones that you've highlighted. So this is going to be your solution. So it's going to be what? It's going to be, where's my color pen? Yes. So your solution, it's going to be 0, right? It's going to be 26, so it's going to be 26,6. Then it's going to be what? So it's going to be 0, 26,6. I don't know why I duplicated that one. So it's going to be 180. Then you're going to have 206,6. Then you're going to have 360. So these are going to be your following solutions for this question. So now we're going to do example 8. It says solve for x, right, without the use of a calculator. And they give us this, right? Do you see the fact that first we need to simplify let me just take out my pen. We need to first simplify the left-hand side, right? So we need to simplify the left-hand side. Then after simplifying it, then we can equate it and basically solve for x. So let's do that, right? So simplifying it, we see the fact that we have 1 minus sine x minus cos 2x, right? And that is going to be divided by what? That's going to be divided by sine 2x minus cos x, right? So I'm simplifying it in a way the fact that I get a single trig ratio because that's the only time that I can solve for what? I can solve for x. So let's do that. Remember the fact that you need to simplify it so you get a single trig ratio, right? So here we see the fact that there is 2 identities that I can apply. It's for this cos 2x and also this sine 2x. But because of the cos 2x has how many? It has 3. Do you see that? It has 3 identities. So we see the fact that cos 2x has 3 identities, 1, 2, 3. First, what you need to do is you need to substitute for cos 2x. Then from there, you would know which one to substitute for cos 2x so that you can cancel things and you can end up having a single trig ratio. So we know the fact that this is going to be equal to what? It's going to be 1 minus sine x, right, minus cos 2x. Remember the fact that we're not substituting now, right? And that's going to be divided by what? What you call the sine 2x is equals to this one, right? So it's going to be 2 sine x multiplied by cos x, and that's minus what? That's minus cos x. Remember, as you're solving, we're looking for a single trig ratio, right? So what do we see? We see the fact that in the denominator, I can take out cos as a common factor, right? So it's the same as 1 minus sine x, right, minus cos 2x, and that's going to be divided by what? That's going to be divided by cos x, open bracket, it's going to be what? It's going to be 2 sine x, then it's going to be what? It's going to be 2 sine x minus 1, right? So that's what we have, right? So now we see the fact that the best, identity that we can substitute for cos 2x, right? Remember the fact that we want to get rid of 2 sine x, right? It's going to be what? It's going to be the one that I'm highlighting right now. It's going to be the one with only sine, right? It's because of with that, it's either we can factorize something. But if I take the one that it has cos, it's going to complicate my what? My numerator, right? So with that said, we know the fact that, okay, I changed the color of my highlighter, not my pen. So I just want my blue pen. So this is going to be equals to what? This is going to be 1 minus sine x, right, minus open bracket. The one with just sine is going to be 1 minus 2 sine squared x, right? So that's going to be divided by what? That's going to be divided by cos x, open bracket, is going to be 2 sine x minus 1, right? So now we're going to distribute the negative in the numerator. So it's going to be 1 minus what? 1 minus sine x minus 1. Then this is going to be plus 2 sine squared x, right? And that's going to be divided by what? That's going to be divided by cos x, open bracket, is going to be 2 sine x. Then that's going to be minus 1, right? So that one is sorted. So what do we see? We see the fact that the positive 1 and the negative 1 is going to give us 0. So they're going to basically cancel out, right? And now this one is going to be what? It's going to be equals to negative sine x, right? And that's going to be plus what? Plus 2 sine squared x, right? And that's going to be divided by what? That's going to be divided by cos x, open bracket, is going to be 2 sine x minus 1, right? So here in the numerator, what do you see? We see the fact that we have a common factor of sine, right? So I can take out sine as a common factor. So it's going to be sine x, open bracket, is going to be negative 1 plus 2 sine x, right? And that's going to be divided by what? That's going to be divided by cos x, open bracket. It's going to be what? It's going to be 2 sine x minus 1. What do we see now? Do you see the fact that the numerator, this and this, is the same thing if we rearrange the one in the numerator, right? So let's rearrange that. So it's going to be the same as sine x, right? Multiplied by 2 sine x minus 1, right? And that's going to be divided by what? Divided by cos x, right? And here's going to be what? It's going to be 2 sine x minus 1. Do you see the fact that these two are going to cancel each other? So that's going to cancel each other. Then we know the fact that sine x divided by cos x is an identity, right? So this is going to be the same as 10x from this identity, right? So now we have everything in a single trig ratio, right? So now solving for x here, this is the same. So therefore, this is the same as looking for 10x is equals to -1, right? So from here, we can find what? The reference angle. So we know that the reference angle here is going to be equals to 10, right? Remember the fact that we never put the negative, so it's going to be 1. So therefore, it's going to be equals to what? To 45 degrees. Then we're going to ask ourselves, where is 10 negative? Because that's what the negative is for. It's negative in the second and what? In the second and fourth quadrant, right? So in the second quadrant, right, it's going to be what? So in the second quadrant, it's going to be the following. It's going to be that x is equals to, open bracket, 180 minus, what you call this, 180 minus theta. Remember the fact that this is the reference angle. So this is the same as 180 minus 45, right? And this is going to be plus k. Remember the fact that this is 10. So this is going to be 180 degrees, right? So simplify this, is going to be the same as x is equals to 135 plus k, 180 degrees. So we sorted with that one, right? Now moving to the fourth quadrant. So fourth quadrant, right? Remember the fact that this is O. So this is going to be what? This is going to be x is equals to, then it's going to be 360. Remember the theta is the reference angle, so it's going to be minus 45. Then it's going to be plus k, then you're going to say 180, right? So this is the same as what? It's x is equals to 315 plus k, then it's going to be 180, right? Where k is an element of integers. So that's how you would solve this question. So now what we're going to do, we're going to do example 9, right? With example 9, we see the fact that they say prove that 8 cos to the power 4x minus 8 cos squared x, right, plus 1 is equals to cos 4x. Then after proving that this 2 is actually true, then they tell us the fact that what? That 8 cos to the power 4x minus 8 cos squared x plus 1 is equals to 0,8, right? So what needs to happen is that we need to prove first, and from the proof we can conclude the fact that this is actually equals to this, right? And which this, if you look at it, it's basically equals to what? It's equals to cos 4x, right? So it's basically cos 4x is equals to 0,8, right? But we're going to start doing the proof. Then from the proof, we're going to do the second part, which is basically calculating x, right? So I know that normally I say the fact that take the most complex side, which is in our case, the most complex side would be the left-hand side, right? But in this case, the one that's going to be simple for us to basically reduce and make it look like the other side in terms of like we have an identity, is actually the right-hand side, right? So the right-hand side is equals to cos 4x, right? So look at this. We see the fact that we have cos 4x, so we can rewrite this. So this is exactly the same as this one. Do you see that? This, this identity. So I'm going to take that identity and I'm going to show you on how to reduce this identity so it can look like this, right? So this is going to be the same as cos, right, to theta, which we have as what? We just have as 2 cos. I'm just going to take the last one. 2 cos squared theta minus 1, right? So what do we see? We see the fact that here is 2, 2 theta, right? And here, what angle did we write here? It was what? It was actually 2 divided by what? 2 divided by 2, which give you 1, which is the same as theta, right? So now, how will you write this? Is going to be, now, if you have cos 4x, right, is going to be the same as taking this identity. So it's going to be 2 cos squared, but now your angle changes, right? Remember here we said what? It was 2 divided by 2 to get this theta. So here's going to be 4 divided by 2 to get what? To get 2. So this is going to be 2x minus 1. And just to add more, it would be the same if we are given cos 6x, right? So this, it can be written as 2 cos cos squared, right? Then here it's going to be what? It's going to be 6 divided by 2, which is going to give you 3. So this will be 3x. And the pattern continues. Just wanted to show you the fact that it's not only the 4x that's going to work, but with 6, with also 8, you get me with 12. So it will always work, right? So knowing this is that now I know that I can replace this as what? As the following. So I can say 2, right? Cos squared. Then here we're going to have 2x, right? Minus 1. But now I'm going to rewrite this, right? In a form of what? Of taking the power outside, right? So it's going to be 2, open bracket. I'm going to say cos, then 2x. Then this is going to be all squared minus 1. Do you see the fact that this is exactly this identity, right? So I'm going to use that one. And just to go back, the reason why out of the 3 identities, I'm using the one with specifically only a cos is that, do you see the fact that our left-hand side strictly deals with cos, right? That is why I picked that one, right? That one will be the best one, because if I pick the one with sine, it's not going to match up with the left-hand side. If I pick the one that has sine and cos, it's not going to match up with the left-hand side, right? So that is why I specifically picked the one that has cos only, right? So we know the fact that this can be replaced with this identity again, right? So this is going to be the same as 2, open bracket. It's going to be 2 cos squared. Now it's going to be x, right? Then this is going to be minus 1. Then this is going to be all squared minus 1, right? So now we're going to expand this. So this is going to be the same as 2, open bracket. This is going to be 2 cos squared x minus 1. Then it's going to be 2 cos squared x. Then this is going to be minus 1, right? And this is going to be minus 1. We're going to expand this. So when we expand it, it's going to be 2. Then it's going to be 2 multiplied by 2, which is going to give you 4. So this is going to be 4 cos to the power 4, because do you see the fact that they both squared? So it's going to be to the power 4 x, right? Then when you say negative 2 cos squared x multiplied by negative 1 is going to be negative 2 cos squared x, right? Then when you say negative 1 again multiplied by negative by 2 cos squared x is going to give you the same as 2 cos squared x. Then when you say negative 1 multiplied by negative 1, you're going to get plus 1. Then you're going to close your bracket. Then this is going to be minus 1. So now what we're going to do is we're going to clean up what the brackets. So this is going to be the same as 2, open bracket. You're going to have 4 cos to the power 4 x, right? Then this is going to be the same as minus 4 cos squared x, right? And this is going to be plus 1. Then this is going to be minus 1, right? Distribute the 2, so it's going to be the same as having what? As having 8 cos to the power 4 x minus 8 cos to the power 2, what you call this x, then it's going to be plus 2 minus 1. Simplify this, it's going to be the same as having 8 cos to the power 4 x minus 8 cos squared x. Then this is going to give us what? Plus 1. Do you see the fact that this is exactly as the left-hand side? So this is going to be the left-hand side. So you have answered the first part of the question, right? So you are sorted with that. So I'm just going to erase this because I need space to answer the second part. So now they say, hence, solve 8 cos to the power 4 minus 8 cos squared x plus what? Plus 1. So hence means what? You need to use the information that you were given before, right? What is the information? As proving the fact that these two are equal. So the hence part is that I can replace this whole thing by cos 4x. So now for the second part of the question, we know the fact that this can be replaced as what? As cos 4x is equals to 0,8, right? Because the hence part says basically use your previous information that you have, right? So since this one it's in a perfect way, our trig ratio doesn't have a coefficient in front of it, we're gonna let k equals what? yeah, let's call it K. I don't want to confuse. Let's not call it K because we have the K in the formula. Let's call it W is equals to 4x, right? So this is the same as cos W is equals to 0,8, right? So from here, you're going to find the reference angle, which is going to be the same as arc cos, then it's going to be 0,8, right? So when you paste that into the calculator, you're going to get that the reference angle is equals to what? Is equals to 36,9, right? I'm just going to do this just to show the fact that, so there's no messed up, right? So we have our reference angle, right? We see the fact that cos is positive, right? So where is cos positive? It's in the first and it's in the fourth quadrant. So now in the first quad, right, we see the fact that it's theta, meaning it's just a reference angle. So here's going to be what? It's just going to be W is equals to 36,9, right, plus K, because it's cos, this is going to be 360. But we know that W is equals to what? To 4x. So this is going to be 4x is equals to 36,9 plus K, then this is going to be 360. Divide throughout by 4, so this is going to be x is equals to 36,9 divided by 4. You're going to get the fact that your answer there is going to be what? It's going to be 36, right? 9 divided by 4. You're going to get your answer as being 9, what? 225, right? Plus K, then you're going to say 360, right? So you're going to say 360 divided by 4, which is going to give you 90, right? Or it's on the fourth quadrant, so it's going to be the fourth quad, right? If I can feel it here. So it's going to be W is equals to what here? It's going to be 36. It's going to be 360 actually, right? And then you're going to say what? Minus the reference angle, which is 36, right? 9. Then this is going to be plus K, 360, right? So with that said, I'm just going to take it up here. So we know the fact that now W is going to be equals to what? If you say 360 minus 36,9 is the same as having what? As having 323,1 plus K, 360. We know that W is equals to 4x, right? So this is going to be 323,1 plus K, 360, right? So divide throughout by what? By 4. So x is going to be equals to what? It's going to be equals to 323,1 divided by 4. It's going to give you 80,1, right? Plus 360 divided by 4 is going to give you 90. Then this is going to be when K is an element of integers. So that's how you would solve this question. So now moving to example 10, right? It says find the general solution for sine theta multiplied by cos squared theta is equals to sine, sine to the power 3 theta, right? First instant that you might think is that, okay, cool, I could basically divide both sides by sine, then you're going to get rid of some of the signs. But that will be completely wrong. And the reason why is that we never want to cancel out any trig ratio, right? We either want to change it into a 10, like you can divide and create like a cos or a 10, but we never want to cancel it out. Just remember that here, we never want to cancel out unless we're simplifying, like number 8. Number 8, we're simplifying it to a single trig ratio. That is why there were things that were cancelling out. But if you're given a question like this, we never want to cancel out any trig ratio. So we don't want any trig ratio to be cancelled because it's going to lose out some information. So if it's like this, what you're going to do is you're going to take the sine to the power 3 to the other side. So it's going to be sine theta multiplied by cos squared theta. Then this is going to be the same as minus sine to the power 3 theta is equals to 0. And the reason why I'm doing this is that, do you see the fact that I can take out sine as a common factor? So this is going to be the same as having sine theta, right? Open bracket, you're going to have cos squared theta. Then this is going to be minus sine squared theta is going to be equals to what? It's going to be equals to 0. So meaning here, sine theta is going to be equals to 0, or you're going to have that cos squared theta minus what? Minus sine squared theta is equals to what? It's equals to 1, right? So this is a difference of 2 squared. So this is the same as having what? Cos theta, right? Minus sine theta. Then this is going to be what? This is going to be cos theta plus sine theta, and this is going to be equals to 0. So this is going to be the same as having cos theta minus sine theta is equals to 0, or it's going to be what? It's going to be cos theta, right, plus sine theta is going to be equals to what? It's going to be equals to 0. So let's start with this one, take it to the other side. This is going to be the same as having cos theta is equals to what? To sine theta. Divide both sides by cos, and the reason why is because of an identity, right? We know the fact that tan theta is equals to sine theta divided by cos theta. That's why I'm dividing both sides by cos. So this is going to be the same as cos theta is divided by this side is going to be cos theta, right? So you're going to have the fact that this is going to be 1 is equals to what? It's going to be equals to 10 theta. So this is going to be 10 theta is equals to 1. Do you see what I said? Is that here we did not cancel anything, but we changed it into an identity, right? Or here it's going to be what? We're going to take the cos to the other side. So it's going to be the same as sine theta is equals to negative cos theta. Divide both sides by cos again. So we're going to have cos theta divided by cos theta again. So here we're going to have 10 theta, and this side is going to be equals to negative 1 because of this negative, right? So we have 1, 2, and 3, right? So we need to find the general solution for all 3 of them, right? So now for what? For sine theta equals to 0, we need to find the reference angle. So we know that the reference angle is equals to arc sine of 0, right? So when you find arc sine of 0, we get the fact that you're going to get what? You're going to get 0, right? So where is sine positive? It's in the first and it's in the second quadrant. So the first one is going to be that theta is equals to what? For the first quadrant, it's going to be theta is equals to, then you're going to have 0 degrees, right? Plus k, it's sine, so it's going to be 360 degrees, which is the same as having what? Theta as being equals to k 360 degrees. So we sorted with the first quadrant. And then with the second quadrant, so this is going to be, the second quadrant is going to be what? Just wanted to write first quadrant, right? So with the second quadrant, it's going to be what? So the second quad, so this is going to be or. The second quadrant here is going to be the following. It's going to be that theta is equals to what? It's equals to 180, right? Minus 0 degrees. Then this is going to be plus k 360. So this is going to be the same as theta is equals to 180 plus k 360. So we sorted with that one, right? So we sorted with this one. Now we're going to move to this one. So with this one, I'm just going to do it here. We need to find the reference angle, which is equals to arc, right? Then it's going to be arc 10. Then this is going to be 1, which is going to give us 45, right? Where is 10 positive? It's positive in the first and also in the third quadrant, right? So knowing that, we know the fact that in the first quadrant here, for this one, so I'm going to do it here, right? So in the first quadrant, it's going to be what? It's going to be, so let me just say O here. it's going to be the same as having, so in the first quadrant, it's going to be the same as having theta is equals to 45, right, degrees. Then you're going to say plus K 180, right? Or, so we can do it all here. So here we can do it for, let's do it for the third quadrant, right? So for the third quadrant, we know that theta is equals to what? It's equals to 180, right? Then this is going to be plus 45. Then this is going to be plus K. Then this is going to be 180, right? So when we simplify that, we're going to get the fact that that's going to give us what? When you say 180 plus 45, it's going to be 225, right? Plus K 180 degrees, right? So now we know the fact that the reference angle for this two, so for this one and for this one is going to be the same. Only the sign is going to be different. So with this one, where is 10 negative, right? It's negative here, right? And it's also negative where it's negative here. So now for this one, it's going to be in the second quadrant, right? So in the second quadrant, I know the fact that it's everywhere, but it's going to be what? It's going to be theta is equals to 180 minus what? Minus 45 plus K, then this is going to be 180, right? So simplify that, theta is going to be equals to what? It's going to be equals to 135, right? Minus 45, 135, just that. I don't know why did I say minus, right? And this is going to be plus K 180, right? So that's that one, right? Then for the what? Or, let me put or, remember the fact that it's negative in the fourth quadrant. So in the fourth quadrant, right, it's going to be what? It's going to be theta is equals to what? It's equals to 360 minus 45 plus K 180, right? So this is going to be the same as theta is equals to what? It's equals to 315 plus K 180 degrees. And that's how you would solve this question. So now what we're going to do is we're going to do trig functions, right? So I'm going to combine your sine and cos together. And the reason is the properties are exactly the same, only the shape of how the graph looks differs, right? Obviously, when I talk about the graph, I'm going to show you how the cos one look and how the sine one look, right? So the first thing that we're going to discuss, as you know, always in functions, we need to discuss the properties of each part, like your A. In our case, it's going to be A, it's going to be K, it's going to be P and Q. But remember how I said the fact that we were doing functions that A acts the same way, it has the same properties. Here in trig, it's going to have the same properties, but obviously the shape of how the graph looks is going to differ, right? And also P is going to have the same property, right? And then Q is going to have the same property. So now let's discuss the effect of A, right? So here, the effect of A is that we know the fact that A gives us what? It gives us the shape. Right? So we know that A gives us the shape. So now when A is what? Is greater than 0, our graph for sine is going to look like the following. It's going to look like this, right? It's going to look like this, right? So that's when A is what? Is greater than 0, meaning A is positive. But now if A is less than 0, meaning it's negative, right? So then our graph is going to be it's going to just change, right? Do you see the fact that we started from here, right? Then if it's negative, it's going to start from here like this. It's going to go like this. It's going to go like this, right? So it's going to go like this. So that's when A is what? It's negative. So now let's just talk about the shape of cos, right? So we know the fact that still gives us the shape. So I'm just going to talk about when A is positive here and how the shape looks, right? So we know the fact that positive means the fact that it's positive. So the shape of the graph looks like this, right? It's going to start here going like this, right? So it's going to be, this is going to be how the graph looks. I'm not going to complete the entire graph, right? So this is when A is what? This is when A is positive. But when A is less than 0, meaning it's negative, then our graph is going to look like how? When A is what? It's negative. Instead of starting from here, it's going to start here, right? So it's going to be like this, right? So it's going to be basically like this. So that's how the shape of A and that's how A affects the graph, both with sine and both with cos, right? So as I said, the fact that it's going to be the same thing, the difference is how the graph looks, right? So now we're going to talk about what? We're going to talk about K and what K does, right? So I'm just going to change the color for that. What is K? And K is going to be the same for both of them. So I don't even need to rewrite it, right? For K, K gives us the period, right? So K gives us the period. So how do we find the period? It's going to be the period here, right? It's going to be equals to what? It's going to be equals to 360. Because of for sine and cos, right? It's 360. It's going to be 360 divided by the absolute of K. What is this two lines? It means absolute. What do they do here? It means the fact that regardless of whether our K is positive or negative, you always take the positive number, right? So for example, and I'm just going to erase this, if they give you cos and maybe they give you negative 2x, right? To find the period here, it would be what? It would be 360, but we always take the positive 2, so it's not going to be negative 2, but it's going to be 2, right? We're going to always take the positive number. So the absolute means is always the positive, right? Now, I have a couple of examples on how to find the period, right? So just e.g., it's going to be, if we given that maybe f of x is equals to what? It's equals to sine, and this is going to be what? This is 3x, and this is going to be plus 30 degrees, right? Then they say find the period. Remember that the period is equals to what? To 360. Then k is the coefficient of x. So it's going to be what? Divided by 3. So meaning here the period will be 120, right? Then another example is that if you're given g of x and it's equals to what? It's equals to cos, right? Then this is negative 1 over 2. Then x, right? And this is going to be plus 60 degrees. Then they say to you find the period, right? So the period here is going to be equals to what? It's going to be 360, right? Divided by, remember we always take the positive, so it's going to be a positive a half. It's going to be equals to, then this is going to be 720 degrees. So that's how you would find the period if you're given both situations, right? So that's how you would do it. So now we're going to move to what? We're going to move to P, right? So P, as I said, the fact that how it affects the graph here and this side is going to be the same thing, right? So I'm going to do P here. Then I'll do Q this side because I need space, right? With P, remember the fact that P moves the graph, what? It moves the graph left or, what you call this, left or right, right? So it moves the graph left or right, right? And remember, one more thing about P is that it always acts opposite its side, right? So here, if P, right, if P is greater than 0, meaning it's positive, then the graph would not move to the right, but it will move to the left. So the graph, right, the graph moves to the left, right? And here, where if P is less than 0, meaning negative, the graph will move to the right. Remember the left is where the negative x-axis are, and the right is where the positive x-axis are, right? So that is why I'm saying it moves opposite its side. If it's positive, you would expect it, right, to move to the right where there's the positive x-axis, but it actually moves the opposite side, which is where the negative x-axis are, right? So is that the graph moves to the what? To the right. When P is what? when P is negative, right? So that's what P does. So now let's move on to Q, right? And as I said, the fact that what P does here and what P does here, it's exactly the same thing, right? So I don't need to duplicate them. The only why I duplicated the A is because of it acts differently in terms of like the shape of the graph, but they both give shape, right? So with this one, right, it's Q. Q moves the graph up or down, right? So with that said, we know the fact that when Q is greater than 0, Q maintain its sign, right? So greater than 0, the graph will move up, right? So the graph moves up, which makes sense because up is where the positive y-axis are, right? Then when Q is less than 0, meaning it's negative, and this one is positive, the graph moves down, which is down is where it's where the negative y-axis are. So the graph moves down. So that's the equation, right? The properties of A, K, P, and Q. So now we're going to talk about the domain and range, right? So with both of them, it's going to be the same thing, right? Whatever formula that I'm going to give you for the domain and range is going to be the same thing for both the cos and the sine, right? So with domain, so let me just change my pen. So with domain, right, it's going to be dependent on what they give you here, right? So normally we know the fact that our graph goes from where? From if they don't give you, right? If they don't give you a restriction, your domain will be X is an element between negative 360 till 360, right? So that will be your domain, right? Or it could be that X is an element between where? Between 0 and 360. So this is when if they don't give you the domain, right? They don't give you like a restriction. Then your range is the one that needs a couple of components, right? So always your range is going to be what? It's going to be Y is an element. Then you're going to need what? You're going to start from the negative. So it's going to be negative A, right? Plus Q. Then it's going to be A plus Q, right? So the first one is basically negative A. And the reason for that, remember the fact that our range goes like this, right? It goes like this. So your graph is, your range is going to be here and here, right? So, and that is affected by what? It's affected by your A, because of A gives what? Gives us our maximum and minimum, right? And also it's going to be determined, it's going to be affected by Q because Q moves the graph up or down. So that is why it's going to be negative A plus Q, what you call the semicolon, is going to be A plus Q. So just remember this formula, you will never get the range and domain wrong, right? So with that said, let's put both our domain and range equations or situations in action, right? So the first one says what? Let's just change up the color. So the first one says what? It says f of x is equals to 3 sine, open bracket, x plus 30 degrees plus 4. Then they tell us the fact that x is an element of real numbers, right? X is an element between 0 and 360. So we need to find domain and range. So domain here is going to be your restriction, right? So it's going to be what? It's going to be x is an element. It's between 0 and 360 degrees, right? So that is going to be your domain. Then your range, right, is going to be what? Remember the fact that it's going to be what? Y is an element, open bracket, it's going to be negative A plus, right, plus Q. Then it's going to be what? It's going to be A plus Q, right? So with that said, we need our A. So our A here from the equation is going to be 3. Then our Q is going to be what? It's going to be 4, right? So that's going to be equals to what? So this is basically equals to what? It's going to be y is an element, right? So this is going to be what? This is going to be negative a. So it's going to be negative 3 plus 4, right? Then it's going to be what? It's going to be 3 plus 4. So your range here is going to be y is an element between where? Between positive 1, right? Then this is going to be till 7. So this will be your what? This will be your range for this graph, right? This formula, as I said, it always works, right? So now let's do g of x, right? So the domain here will be the restriction, which is going to be x is between where? Is between 180 degrees, right? And negative 180. That's your what? That's your domain, right? Then your range, remember the fact that you need your a and you need your q. So what's your a? Your a is negative 5. Then your q is negative 6, right? So we know the fact that the formula here is y is an element between where? Between negative a plus q, right? Then it's going to be a plus q. So let's sort that out. So that's going to be the same as what? As y, right, is an element. Then this is going to be what? What's negative? Then what is a? It's negative 5, right? Plus q, which is negative 6, right? Then this is going to be, a is going to be negative 6 plus q, my negative 5, because of that a. Made a mistake here. It's going to be negative 5 plus q, which is negative 6, right? Close with the square bracket, right? So when you simplify this, this is going to be the same as y is an element from negative 1, right? And negative 11, right? So here, what do we see after finding the... So let me just change back along. So here, what do we see about after finding our negative 1 and negative 11, right? When a is negative, do you see the fact that it does not make sense? Because if we always, in like finding inequality, right, is that our smallest number comes first, then our less small number, like the smallest number comes first, then the other one comes second, right? So we can't say the fact that our number line, because this is like more or less if you represent it on a number line, we can't say we start at negative 1, then we go to negative 11. It's always from negative 11, because that's further from the left than it's negative 1. So you need to swap this two, right? So this is going to be the same as y is an element, right, between negative 11 and negative 1, right? And it makes sense because of if you had to write this in this form, right, you can't write it like negative 1 till negative 11. That's incorrect because of this and this is basically the same thing. But you know the fact that this is incorrect. The smallest number comes first, so that is why it's negative 11. Y then is negative 1. So that's why you need to rearrange them. Make sure that your smallest one is on the other side, right? Which is in our case, negative 11 is the smallest. Then the bigger one is on the other side, right? Which is negative 1. So that's how you arrange when you're dealing with a negative number. Or after finding this form, you see the fact that the order is not okay. Remember, always the smallest one first, then the bigger one next, right? Just swap them so that you can get the correct answer and they do not mark you wrong. So now what we're going to do is we're going to discuss our maximum and minimum, right? So with your maximum and minimum, you need your range, right? So we know for this one that the range, right, is going to be what? It's going to be y is an element. It's between where? It's between 1 and 7, right? So this one always gives us the minimum value, right? And this one always gives us the maximum. So this is going to be always the case, right? So with this one, and let me just show you visually on how this would look. So we know the fact that if we had to sketch roughly this graph, right, not taking into account the other components, but only the maximum and minimum, we know the fact that it's at 1, right, is the minimum, and at 7 is the maximum, right? So since A is positive, our graph goes like this, right? This is how our graph is going to go, right? So let's say the fact that it cuts here, right? let's say the fact that it goes to like this. So it's going to be like what? It's going to be, so this is going to be, your graph is going to look like this. Yes, just the proper sign. So this is going to look like this. Do you see that? So this is how your graph would look. Do you see the fact that 7 is always the maximum? Do you see that? Then what you call this? 1 is always the minimum. Do you see that? This is the minimum, minimum, maximum, maximum, right? So that is why it will always be like this. And even here, right, we need just our range, right? Which is here was what? Was y is an element, and it was between -11 and -1, right? So as I said, the fact that this will always be what? This will always be the minimum, and this one will be always the maximum. So just sketching showing the minimum and maximum with this graph, it's going to look like this. We know the fact that it's -1 here, and this is going to be -11 here. So this is -1 and this is -11, right? So maybe it cuts through here, meaning we like shifting them, it will cut through here, right? So we know that our graph, since since this is -a is less than 0, meaning our graph is gonna, instead of starting here, it's gonna start here, right? It's gonna start and go like this. So it's gonna start here at -11 and it's gonna go like this. This is how the graph will look, right? So it's gonna go like this. Do you see something? Do you see the fact that -1 will always be what? The maximum, and -11 will always be what? Will be the minimum. So remember the fact that if you need your maximum and minimum, the only thing that you need is going to be your range, right? Because that is going to determine your maximum and minimum. And regardless whether A is positive or negative, always the first term in your range is going to be the minimum, and the second term will always be the maximum. So now what we're going to do, we're going to talk about amplitude, right? So with amplitude, I'm just going to look at when y is equals to sine x, right? So with sine x, we know the fact that this is the graph. Just going to do the positive side. So this is going to be what? This is going to go like this. Right? So this is going to go like this. So do you see the fact that this is going to be what? This is going to be your max, which is 1. And your minimum is going to be here, which is -1, right? So your amplitude is going to be just this, the distance from the x till the max, right? Or the distance from the x to the what? To the x-axis. So this will be regarded as your amplitude, right? So that's just your amplitude, right? Then if we had cos, so if I say y is equals to cos x, right? So it's going to be where? It's going to be your graph, just taking only considering the positive x-axis, right? Remember the fact that it's like this, right? So it's going to be the distance from your max till the x-axis, and here it's going to be the distance, this distance. So that will be also considered as your amplitude. So that's just amplitude, and this is how it looks, right? So now we're going to move to sketching your sine, right? So with sketching your sine, what I love doing is basically first sketching the mother graph, then from the mother graph, moving the graph from like, what you call this, reducing the graph if I need to reduce it from the period, then moving it up or down if I need to, right? So with sketching, first we're going to need our Cartesian plane. So Cartesian plane, do you see the fact that here we have a restriction is between 0 and 360? So our Cartesian plane needs to be within this restriction. So it's going to be like this. So it's going to be like this, right? So it's going to be like this. First, what I will do is find the range of this, and that helps because you know the fact that whether do you need more space in your y-axis, right, or do you need more space in your positive, like first it's going to that So you can determine, do you need more space in your positive y-axis or do you need space on your negative y-axis, right? So with our range here, right, we already determined it, right? We know the fact that the range here is what? It's going to be what? It's going to be 1 and 7, because it's the same question that we've been doing, right? So meaning we're going to need more space in our positive what? Positive y-axis. So meaning we need to go till up to maybe 8, right? So this is going to be what? This is going to be 1, 2, 3, 4, 5, 6, 7, 8, right? So meaning our line is going to go, maybe let's say here. So we know the fact that the x-axis will be somewhere here, like this, right? And this is going to be y, and this is going to be x. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, right? And this is going to be what? -1 and -2, right? Then here we need to basically write our, our y-axis, right? So with our x-axis, so here it's going to be what? So I always, leave a space of 2, right? Or 3 depending. So this is going to be what? This will be 0. This will be 90, right? This is going to be 180. Actually, let's do it in a space of 3. Yeah, I feel like the best one is a space of 3, right? So this is going to be what? This is 1, 2. This one is too long. So this is going to be 1, 2. Then 3 here is going to be our 90. Then this is going to be 1, 2. Then 3 here is going to be our 180. And this is going to be 1, 2. Then 3 here. Remember, it's going to be our 270. Then it's going to be 1, 2. 3 here is going to be our 360. Right? So it's going to be always 0, 90, 180, 270, and 360, right? So how does our mother graph go? It goes like this, right? And this one, the one that I'm doing in blue, right? This one I'm doing with this light blue, it's going to be the one that you erase, right? So always draw with your pencil, don't draw with your pen, right? So we know the fact that how the mother graph looks is like this, right? It comes through here, right? It comes through here. Then we know the fact that here at 90, it gives us what? It gives us our maximum width sign, right? Then it cuts through 180. Then our second maximum is going to be here, right? And remember the fact that it matches upward 1 and -1. It's going to be at 270. Then it cuts at 360. So our graph here would look like this. And this is the mother graph. Remember, use your pencil, don't use your pen, right? Because you're going to be erasing things to basically have your final. So this is your mother graph, right? So with your mother graph, what do we see? We see the fact that another part, so this, the blue one, right? This one is when it's y is equals to sine x. That's just the mother graph, right? We see the fact that here we have 3. 3 affects the what? The maximum or minimum, right? So our new maximum here, and I'm going to do it in green, right? It's going to be what? It needs to be 3. So it's going to be here, and let me just extend this. So I'm going to extend this because we need a -3. So this is -3 and -4, right? So we see the fact that our new maximum and minimum, it's going to be here. So this one is going to move to, it's going to move here. And this one is going to move here, right? And that's it. So we know the fact that it's still going to cut here, it's still going to cut here, and still going to cut here. So we're going to move it like this, right? So it's going to move like this. And now this is when taking into account this one, right? So this one is basically y is equals to 3 sine x, right? So that one we sorted, right? So we have sorted this one, right? So now what we're going to do is, before we move it, before we move it up or down, we're going to deal with this 30 degrees, right? So what is 30? We know the fact that since it's positive, it's going to move it to the left by 30 degrees, right? So here, what we're going to do is that we're going to say 0, right? So we need to move each point. We need to move this one, this one, this one, this one, 270 and 360, right? We need to subtract it by 30 because of it moves it to the left. So you're going to say 0 minus 30, right? So I'm just going to extend here, even though we're going to erase it because of the region, right? So this is, I'm going to extend this one. I need to change my pen, right? So I know the fact that this is what? This is 1, 2, then this is negative 90, right? Yeah. So moving by 30 is going to be, your 30 is going to be here. So this is negative 90. So your 30 is going to be here because of, if you say 90, right, divided by 3, it's going to be what? This is basically 30. So this is 30 and this is 60, right? And if I fill in this one, it's going to be what? So if I just fill in, so this is going to be 0, 30, 60, 90. And if I say 90 plus 30, I'm going to have 120 here. Let's just fill it up, right? So this is going to be 120 plus 30, which is going to be, this one is going to be 150, right? So now it's intervals of 30, right? And this is going to be plus 30, this is going to be 180. And this one will give us what? This one will give us 210, right? So this one's going to be 210. Then this is going to be 240. And this one will be 270 as we have. Then add another 30. This one will give us 300. And this one is going to be 330. Right? That is why I divided it by 3 parts, right? So I think just a tip, always divide it by 3 parts so that if you need to move things, it's very easy, right? So as I said, the fact that, so this one will be negative 30 first, and this one will be negative 60, right? As I said, the fact that we're going to move this 0 where it cuts, 30 units to the left. So it's the same as taking that 0, right? So it's the same as taking 0 and minusing it by 30 degrees. So meaning this is going to give us negative 30. So meaning this point here is going to move here. So our graph is no longer going to cut there. So let's change the color because we're going to change. So our graph is no longer going to touch here, but it's going to cut here, right? So that's where it's going to start cutting, right? Then we're going to move the 90, right? Remember the fact that the 90 gives us the maximum. If you say 90 now, minus 30, it's going to give us what? So if you say 90 minus 30, you're going to have 60. So this is going to be 60, right? So now we're going to have our maximum here. So this is going to be the point we're going to have maximum at 3, right? Because remember the fact that we are taking account when 3 is already situated. So it's going to be, maximum is going to be here at 60, right? Then now we're done with the 90 part. We're going to do what? 180, right? Because that's where the graph cuts. So it's going to be 180 minus 30, which is going to be 150. So now the graph is going to cut at 150, right? So we sorted with that one. Then now we're going to go at 270, and 270 is the what? Is the minimum, right? So if you say 270, so this one is going to be the same as 180 minus 30, which is going to be what? 150, right? So it's going to be 270 minus what? Minus 30, right? So it's going to be 270 minus 30, which is going to give us what? Which is going to give us 240. So this is going to be 240. So now our graph is going to have a minimum at 240. So it's going to be here, right? Then it's going to be what? It's going to be the last term, which is 360 minus 30, which is going to be what? Which is going to give us the following. So it's going to be 360 minus 30, which is going to give us 330. So this is going to be 330. So it's going to now cut here, right? So now let's connect the purple graph. So this is going to be how the graph looks, right? So this is going to be how it looks now, right? So this one is when you shift it to the what? This is when you shift it to the left by how many units? By 30 units. So it's going to go up kind of like this, ending somewhere here, right? Because that's where our restriction is. It's at 360, right? So now we sorted with that one. So let me just erase this. We sorted with the purple one, and I'm going to name it so that you know which one is that one. So that one is going to be what? It's going to be when y is equals to what? Is equals to sine. Then this is going to be what? X plus 30 degrees, right? So we sorted. So do you see the fact that what's left? We left with moving the graph up, right? So now we're going to take each point and move it how many units? 4 units up, right? So we're going to start with the ones that are on the x-axis, right? So when you move the ones on the x-axis 4 units up, it's going to be what? It's going to be 1, 2, 3, 4. So now the cutting point here at 0 is going to be here, right? So now we're going to move this maximum 4 units up. So this is going to be 1, 2, 3, 4, right? So now our maximum point is going to be here, right? So now we're done with that one. We know the fact that this point here is going to be here because it matches up with this one, because it cuts the x-axis. And this one, right, is going to be what? The minimum, we move it 4 units up. So it's going to be 1, 2, 3, 4, right? So it's going to be here. Do you see that? Then this one, right, is going to be the same as the one that's here, right? And that's your graph. So our graph, which is change color, right? So our graph is going to be this one. So it's going to be going like this, then going down like this, then like this, then like this, right? Then remember the fact that it has a restriction at 360 somewhere here. So it's going to be the same as doing this, right? So now our actual graph that we're sketching, which is f of x, is going to be the red one. So f of x is going to be the red one. Then when you're done basically finding f of x, you can erase everything, right? So you can erase everything. So this is erasing. That is why I'm saying use your pencil. But just write your Cartesian plane, right? Write your Cartesian plane in pen, right? So that when you erase the rest of the graph, you basically don't erase your Cartesian plane. So let me just fix my Cartesian. We know the fact that this is going to be this one. Then you can just emphasize it with the pen if you want to, right? But remember the fact that our restriction does not have this negative side. So this side needs to go too. So, you know the fact that this is going to be what? It's going to be here, right? So it's going to be here, right? So this is going to be like this. Let me just do this. Yes. So it's going to cut like this, right? So this part, it's not part of your graph. This one. This one. So this is how your graph would look, ending like this. So this is exactly how your graph will look, right? So that's how you would do it. Remember the fact that you need to take it bits by bits to basically know how your graph is. So that's the easiest way of drawing your graph. So now we're going to do when sketching cos, right? Do you see with cos, what do we see? At first, as I said, is that you need to determine what? You need to determine your range, right? So that you can know whether should you have more of the y-axis, the positive one, the positive y-axis, or more of the negative y-axis, right? So with this one, we see the fact that our range, since this is -1, it's perfect. It's just going to be what? It's going to be between. So this is going to be y is an element between -1 and 1. So this one is not complex. It's just going to be that, right? So meaning the amount of positive y-axis and the amount of negative y-axis really doesn't matter, right? So with that said, taking out that one out of the way, let's draw our Cartesian plane, right? So we're going to first draw your Cartesian plane. Remember the fact that your Cartesian plane, first do it with your pencil, then emphasize it with your pen, because you know the fact that we're sketching cos and sine, you need to erase things, right? So this is going to be like this. Remember the fact that you have a restriction here. right? So with that said, we know the fact that this is going to be what? This is going to be till 3, right? So it's going to be 1, 2, 3, and that's going to give you 90. That's going to be 1, 2, 3, and this is going to give you 180. And that's where you're ending, because that's where on the positive x-axis is ending at positive 180. Then here's going to be 1, 2, 3, meaning it's going to be negative 90. Then it's going to be 1, 2, 3. Then this is going to be negative 180, right? So now let's sketch the mother graph, right? So sketching the mother graph, you know the fact that this is 1 and this is what? And this is negative 1, right? So sketching the mother graph, we know the fact that this is going to be what? It goes from where? It goes from here, then it cuts at 90. So this is going to be how it looks. So it cuts here, then this is what? This is its minimum, right? So the graph would look like this. So this is how the mother graph would look, right? So that's the mother graph, right? So continuing it this side, so this is going to be cutting here, and this is the minimum. So it's going to go like this, right? So this is the mother graph. So this is when y is equals to cos x. But remember the fact that our cos is negative. So now we're going to flip it, right? So the green one is us flipping it. So meaning instead of starting here, it's going to start here. So it's going to go like this. So this is going to become here. So this is going to become there. It's going to cut here. And this here is going to come here, right? So same thing here. This one is going to become here. So we're going to do this. It cuts at the same place. And also here, it cuts at the same place. But it changes its position. So it's going to be like this, right? So remember the fact that this is when y is equals to negative cos x, right? So now we sorted with that one, right? So we sorted with this one, right? So now we're going to discuss the period, right? So do you see the fact that the period is what? It's 2 in front of it, right? So now what's going to happen is that, so let me just change my pen, right? So now what's going to happen is the following, is that now we're going to divide what? We're going to divide our 90 and 180 by 2, right? So it's going to be 90 divided by 2 to find the new coordinate because of the period, right? So it's going to be 90 divided by 2, and this is going to give us 45. So our graph here is going to be half of 3, and half of 3 is 2 commas. It's 1 comma something, right? So it's going to be here. So our 45 is going to be here, right? So our graph is no longer going to cut at 90, but it's going to cut here, right? Then you're going to take the 180, right, and divide it by 2. So you're going to say here 180 divided by 2, which is going to give you what? Which is going to give you 90. So now you remember the fact that at 90 it's what? It's the maximum, right? So your maximum, your new maximum point is going to be what? It's going to be here at what? It's going to be here at 1. It's going to be here at 90. So it's going to be here. It's going to be here at 90. So it's going to be here at 90, right? So we see the fact that this is how it's going to go. It's going to go like this. But now, do you see the fact that there's going to be, find the midpoint between these two, right? And that's going to be, the midpoint between these two is going to be where it's going to what? It's going to cut, right? So we see the fact that our graph is going to be 45, 90. Or you can, instead of finding the midpoint, you could say 90. Because now, do you see the fact that our interval is 45? So you can say 90 plus 45 to find the next point, because we need to end at positive 180. So it's going to be plus 45, which is going to give you what? If you say 90 plus 45, it's going to give you 135. So here, the midpoint between 90 and 180 is going to be what? It's going to be 135. So that is going to be there. This is going to be what? This is going to be 1, 2, 3. So let's say it's here, somewhere here, right? So this is going to be 135. And that's where the graph is going to cut, right? Then here at 180, right, it's going to be where the graph is going to have a minimum, right? So same thing here, replicate whatever we have here. The 0, if you divide 0 by 2, it's going to give you 0. So it's still going to cut here for the y-axis, right? And here, we need to find the midpoint, which is going to be negative 45. It's going to be here, right? Then here at 90, it's going to go up. So it's going to go up even here. Then here at 135, so it's going to be negative 135. It's going to be here, right, cutting. Then here again, right? So now your graph is going to look like this. Going to go like this. So this is your graph, right? So this is going to be how your graph will look. Obviously, yours will be neater than mine. So this is the actual graph. So now erasing the green and the dark blue one. So if I erase this, right? So if I erase this, right? And erase the blue one, you actually have your actual g of x. So erase this. So this will be your actual g of x. So let's just emphasize it a little bit more so it can look maybe pretty. So this is how your graph will look. Your actual g of x. So this is how it would look. So this will be g of x. And that's how you would sketch. That's why I'm saying the fact that do everything in pencil. When you're done doing the final graph, then you can basically change it, right? Or what you call this, you can erase the mother graph and the ones that you've reflected and basically have the final answer, right? So that's how the graph would look. So now we're going to move to 10, right? The 10 function, right? So with that one, as you see the fact that we have A, we have K, we have P, and we have Q, right? So the one that I'm going to discuss here is A and K. P and Q is the same as the one with sine and cos. So I'm not going to talk about it more again because we already discussed. You know that the P moves the graph left or right, and we know the fact that Q moves it up or down. So I'm not going to emphasize it again. So the only two that are different is going to be A, even though A gives us the shape, but the shape, how the shape is different, and K is also different compared to your sine and cos, right? So now we're going to discuss A, right? So with A, we know that A gives us the shape, right? So here, when A is greater than 0, so one more thing is that with 10, it has what? It has asymptote, right? So your asymptote here, like the general graph, is at what? It's at 90, right? And then this is going to be 90, this is 180, and it's going to be 180, then it's going to be at 270, right? So your graph, if A is positive, your graph is going to look like this. Let me just add this side. Negative 90, 180, and it's going to be 270, right? So you know the fact that this is going to be asymptote. So your graph, when A is positive, it's going to be basically, it's going to look like this. This is how your graph would look, right? So this is how your graph would look. So this is how it would look, right? So that's when A is positive. So when A is, so this is when A is positive. When A is less than 0, meaning it's negative, this is positive. Then taking the same graph, so now again, it's going to be what? It's going to be 90, negative 90. Then again here, it's going to be 90. Then this is going to be 180, right? Then this is going to be 270, right? Replicating it is going to be 180. Then it's going to be what? It's going to be 270. Just want to end here, right? So now you're just going to flip it. Do you see the fact that we went like this? So if it's negative, it's going to be like this now. This is how your graph would look, right? So it's going to be like this, right? So it's going to be like this. So this is how your graph would look, right? So this is when A is positive and this is when A is negative, right? So now let's discuss the period, right? So with the period, just like using different color, let's continue with the pattern. So with your period, right, is that period is going to be equals to what? To 180, right? Divided by what? Divided by the absolute of k. So here, for example, if you have that 10, y is equals to 10, then here let's say it's 3/5, right, x. How would you find the period? It's going to be the period here, so this is e.g. It's going to be equals to what? It's going to be equals to 180 divided by what? By 3/5. So let's do that. So if you don't want to use the fraction like this is going to be exactly the same as saying 180 divided by 3/5, right? So when you say 180 divided by 3/5, you're going to get 300. So the period here is going to be 300. So that's how you would find the period for this one. Remember with sine and cos, the period is 360 divided by k. Here it's 180 divided by k, right? So that's how you would find your A, or that's how A is, and that's how you would find your period. So now we're going to discuss your asymptote, right? So here we see the fact that first, let's talk about the asymptote of the original graph, right? The mother graph, which is going to be what? Because from there, we can understand the asymptote on how we shift it here, right? So here, we know from the mother graph, which is a y is equals to just 10x. Our asymptote here, from when I was just giving you the basic idea, it's going to be what? It's going to be, if it's between where, let's just make it between this region, right? It's only going to be, or let's just first make it in this region, which is negative 360 till positive 360, right? So within this region, and I'm just going to write it here so that I don't confuse anyone, right? If it's within this region, our asymptote now is going to be what? It's going to be the following. It's going to be negative 270, right? It's going to be negative 90. It's going to be positive 90. Then it's going to be positive 270, right? That's our asymptote. Now, if we're going to do it within the region that they gave us, right, which is going to be like this, positive, sorry. Here, it's only going to be what? It's going to be only positive 90, right? Because only positive 90 can be in between this, right? So now, finding the asymptote here, it's going to be, we're going to look for the asymptote from the mother graph, then we're going to transform it with whatever that they gave us, right? So with this one, it's going to be what? It's going to be, we know the fact that the only asymptote here is going to be 90, right? So it's going to be 90, right? But do you see the fact that the graph moves 45 degrees to the left, right? So this is going to be the same as minus 45. So here the asymptote is going to be positive 45. So here your asymptote is going to be x is equals to 45 degrees. So that's how you would find asymptote. So now we're going to do your domain and range, right? So with your domain, right? So with your domain, you saw the fact that from the graph, right, is that the one that when we're doing the shape, is that your graph has asymptote, meaning it's where the graph doesn't exist, right? So with your domain, what's going to happen, and I'm just going to say this in the general sense, right, is that it's going to be what? It's going to be always x is an element of real numbers, but not where your asymptotes, right? So in our case, if our graph is not shift or anything, meaning 10x, if we're looking at the domain in 10x, which is the mother graph, meaning the graph is not going to touch where, and let's say that's between negative 360 and 360, right? Our graph did not touch where when x is equals, when x is not going to be equals to where, starting from the negative 270, right? Then it's going to be x did not touch at negative 90. Then x did not touch where? At positive 90, and also x did not touch at positive 270, right? So that's when we're talking about the mother graph, which is just 10x, right? That's how it is. It's going to be always x is an element of real numbers, but it does not touch the asymptote. Then range here, always is going to be that x is an element of real numbers. Not x, it's going to be y is an element of real numbers, right? because remember that range we're looking at y. So now to answer this question, right, let's find the domain and range of this one, right? So we're going to start with domain, right? But first we need to find what? We need to find our, our asymptote. We know from the original, so we're going to need the original. We know the vectors from 0 to 180, so we know from the original. Here, if we found just, right, if we found just the asymptote of this one, right, from this range, it would be just 90 degrees, right? Because of here, the only asymptote is going to be 90 because 270 is not part of this, right? But now remember the fact that our graph moves how many units? It moves 45 units to the left. So now our asymptote here is going to be 90 degrees for this question. It's going to be 90 degrees minus 45, right? Because remember it moves, right? So this one is for when 10 is x plus 45, sorry, right? So this is going to be the asymptote there, right? So the asymptote here is going to be 90 minus 45, which is going to be what? This is going to be 45. So the graph is not going to exist here at 45, right? And if you say 270, just to check whether is it going to be inside the 180, if you say 270, right, minus 45, which is the second asymptote we know from the original. So if you say minus 45, do you see the fact that it is equals to 225? So this one, even though we shift the graph, this one is still not part of our region. So here, your range, your domain, sorry, is going to be x is an element of real numbers, but the graph does not exist where? It does not exist when x is equals to what? To 45 degrees. So that's how you would find your what? That's how you would find your domain, right? So now, talking about your range is very easy. It's just going to be y is an element of real number. So here, remember the fact that you just need to find your what? You just need to find your asymptote. Then if the graph is moving left or right, you need to move it left or you need to move it right. So that's how you would find your domain and range for 10. So now we're going to move to what? Sketching the graph of a 10, right? So with this one, I don't want you guys to approach it the same way we approach sine and cos, because if you do that, it becomes very, very complicated. So what we're going to do is we're going to sketch the mother graph separately on its own axis. Then we're going to basically look at it from its own axis and see how we can transform the new one, right? So we're going to first sketch the mother graph here, right? So we see the following. There's important points to look at, right? So it's going to be the following. Right, so this is, I'm going to sketch 10x. So this is what I'm sketching is y is equals to 10x. Right, so this is how it would look. So we know the fact that we have asymptote, right? So we know the fact that we have asymptote. So this is going to be 0, and this is going to be 1, 2, 3. This is going to be 90. Then this is a 1, 2, right? 3 is going to be 180, right? Then this is going to be 1, 2, 3. Then this is going to be 270, right? And this is going to be 1, 2, 3, which is going to be 360, right? So same thing when you duplicate it the other side. So this is going to be 1, 2, 3. This is going to be negative 90. This is going to be 1, 2, 3. This is going to be 180. And this is going to be 1, 2, 3, which is going to be negative 270. Right, and it's going to be 1, 2, 3, which is going to be negative 360, right? So what is your asymptotes? Let's put them. It's going to be here, right? Then it's going to be here. Then it's going to be here. Then it's going to be this one. Then one important point that you need to do is that your graph actually curves at 1 and at negative 1, right? So your graph is going to curve at 1 and negative 1, and the point where it curves is at 45, right? So here, half 45 is going to be here, because that's half of 90, right? So your graph, if this is where it needs to curve, start curving, so 45 will be here. So it needs to basically curve here, right? So here we need to find 45 again. So it's going to be what? It's going to be 90, right? So this is going to be 90 plus 45. So it's going to be 135. So this is going to be somewhere where? This is going to be somewhere here. So this is going to be 135, right? And again, remember the fact that this, from the mother graph, it goes up, meaning here at negative 45, right? It's going to be, let me just draw the line at negative 1. It's going to be here, right? So this point is where it's going to curve. So it's going to go up here and it's going to curve up down here, right? So here it's going to be 135 negative 135, right? So it's going to be again negative 1. It's going to, let's say 180 plus 45, which is going to give us 222. So this is going to be 225, sorry. And if we say 270 plus what? Plus 45, it's going to give us 113. So it's going to be 315, not 100, 315, right? So as I said, the fact that the graph goes like this, right? So we know the fact that this point here and this point here. So for this one, this is where the graph will cut. So let's just do it with the different color. This is where it would curve, right? This is too light for my liking. This is where it would curve, right? Right? And the graph cuts here. So the graph cuts here at 0. Then at this point, it's where it will curve. And this point is going to curve. Then it cuts at 180, right? Meaning it's going to curve here at 225. Then it's also going to curve here, right? At positive 135, right? Then the graph cuts where? Then the graph cuts here, right? At 360, right? Meaning it's going to curve where? It's going to curve here. Then this part, there's no 360 on the other side, right? So I'm going to duplicate everything here. So here, we know the fact that it's going to cut at negative 180. So it's going to curve here at negative 135. And it's also going to curve here. So this point is what? It's 225. So this is going to be negative 225. So it's going to curve here, right? So here 270, we know the fact that there's an asymptote. Then here it's what? It's negative 315. So we know that the graph will cut here, right? So it would curve here. So that's how it would go, right? So now let's sketch the graph. So when I say it will curve, it will do this. There. So that's how the graph will look. And even here, it will do the same thing and it will curve here. See? At 1, right? So same thing here, it will do the same thing. And also here, it will do the same thing. So we're sketching the mother graph here, right? So here it's just going to be this part, right? So here it's going to be the same thing. It will go flat and it will curve there. Then go flat, it will curve here, right? So with this one, it's just going to curve at this point, right? So this is how the mother graph looks, right? So as I said, we're going to translate the mother graph into being what? Into the graph that we were given, right? So now we're going to change points that going to translate this, right? What do we see? We see the fact that our graph moves 45 degrees to the left, right? So now we're going to find the important points. Remember the important points is what? It's, is 0, it's 45, it's 90, it's 135. So let's just highlight the important point, right? The important point is 0, it's 45 because that's where it curves. It's 90 because it's the asymptote. It's 135 because of that's where it curves. Then it's what? It's 180, right? Then it's 225 because it curves. It's 270. Then it's what? It's 315 because that's where it curves. And it's, in our case, it ends at 180. So it's going to be here, right? So, but these are the important points. Let's highlight all of them. So this is going to be the important points, right? So the ones that I'm highlighting are the very important points, right? Because that's where it curves and that's where it cuts and the asymptotes, right? So now with this, we need to first look at the restriction. We know the fact that it's between 0 and 180, right? Then with that said, we know the fact that the graph flips, right? We know that the graph flips. So from the mother graph, let's flip it so that we can see what we need to look at, right? From the mother graph, this is not the pen. I want the pen. From the mother graph, we know the fact that it flips. So the graph would look like this when we flip it, right? So it's gonna, okay, it's blue. So it's gonna go like this. Remember the fact that instead of curving here, it would curve here. Instead of curving here, it would now curve here. So we just swapping, right? So it's gonna be like this, but the intersection will be the same. So this one will curve where? This one will curve here, which is, now we don't have this side, so it's gonna curve here. So this one will curve here, right? So this one will go here. So this one will come here, sorry. I don't know where did I put it on the other side. This one will curve here, right? And with this one, it will curve here. So it will curve here, it will curve there, curve here, curve there. Then this one will curve here, and this one will curve here, right? So do you see the fact that where it curves is only where it's going to change? So now the graph would look like this if it's negative. So this is going to be how the graph would look, like the blue one, right? So this is how it would look. Remember, it's going to be like this if it's negative, right? So this is going to be, so this is going to be, since we can't do this, so it's going to be just like this, right? Then here it's going to curve like this, right? So this is going to how the graph will look, and this side is going to be just like this. And it's going to curve here, right? So the actual graph that we need to change here is going to be this one, because of this one, remember, represents when y is equals to negative 10x, right? Because of this is negative. So I've sorted that part, right? So I'm just going to erase the green one, right? Because honestly, I don't want it, because I want to look at the blue one so I can know when I move it, right? So as you see the fact that I've highlighted the important parts, right? So with that, me highlighting the important part, right? So we know the following. We know the fact that we need to move 0, right? 45. So I'm going to do it here, the maths part, right? So we know the fact that if we say 0 minus 45, right? Then the new point there is going to be negative 45. So the graph is going to cut there, right? So now we know the fact that 45, another important point is what? It's 45. This 45. So it's going to be 45, right? Minus 45 is going to be equals to 0. So our new point is going to be 0. Then after that, it's going to be 90. So when you say 90, right? So it's going to be 90. Remember, let's write them all down. It's going to be 135, right? So it's going to be 190, 135. Then it's just going to be what? It's going to be 180. Remember, that's where we're ending. It's going to be 180. Maybe let's add 225 because of it might be part of our new region. So when we say 225, right? If this one is not part of our region, then we're not going to add it, right? So if we say 90 minus 45, because we're moving it to the left, so this is going to be minus 45. Also, this is going to be minus 45. And this is going to be minus 45, right? So this is going to be 90 minus 45, which is going to give us 45. So this is going to be positive 45, right? And if we say 135 minus 45, it's going to give us 90. So this is going to be 90. So if we say 180 minus 45, it's going to give us 135, right? And if we say 225 minus 45, it's going to give us 180. So that's where it's going to end, at 180, right? So this one, when we shift it, it ends exactly at the region, right? So now we're going to draw the new Cartesian plane, right? So when we draw the new Cartesian plane, let's just make it in black, right? So drawing the new Cartesian plane, we know the fact that we're focusing from 0 to 180. So it's going to be like this. So this is going to be just a positive part, right? So it's going to be like this. Remember the fact that I'm just going to add the negative 45 part but I'm going to erase that section of the graph, right? Just to know how to curve the graph, right? So we know the fact that this, let's call it negative 45, right? And this is going to be 0. And this is going to be 45, right? And this is going to be what? It's going to be, so this is going to be 45. So we done, this is negative, this is 45, this is 45, right? So this is 90. Then this is what? So this is 90, this is 135, right? And this is going to be 180, right? So now let's write each of the properties. Remember the fact that 0 was where the graph cuts, right? But now it's replaced by negative what? Negative 45. So we know the fact that at the original graph, right, the graph cut at 0. So now it's going to cut at 45. So we know the fact that this is going to be the new point where it cuts, right? Then remember the fact that that's when at 0 is, right? So this is where 0 is. Now let's look at what 45 did. So 45 is when it cuts that's where it curves. So let's do this for curving. So we know the fact that it's going to curve at what? It's going to curve at 0 now, right? Remember that 90 is an asymptote, so I'm going to put a line for that, right? Then we know the fact that 135, that's where it curves. So I'm going to put that, right? Then we know the fact that at 180, that's where it cuts, which is I'm going to put an X. Then 225, that's where it curves, right? So now we know the following. We know the fact that it cuts at negative 45. It's going to curve here. So we know the fact that it's going to curve here at negative 1, right? Because we need negative 1. Then we know the fact that what's going to happen is that 45, right? 45 is what? It's the asymptote. So this is going to be our new asymptote. So 45 is going to be the asymptote. So this will be our asymptote like this. But remember the fact that if we're looking at it, because of our graph changes, did a mistake. It's not actually a mistake. So it's that for the curved part, right? Is that remember the fact that we've reflected the graph. So let me just do this. So the cutting part is correct. So this one is correct. But remember the fact that we flipped it, right? So at 45, right, do you see the fact that it's now the blue one, right? So meaning it's going to cut here down at what? At 45. So it's going to cut here, right? So that's how it's going to be. So then we know that 45 is what? 45, it's where the asymptote is. Then now at 90, that's where it curves, right? So 90, remember the fact that 90 is related to 135. Remember that 135 means it's going to be up. So it's going to curve up here. Do you see that? Because it's related to this. This and this are the same thing because they're related, right? Then at 135, which is related to 180, what happens? It cuts. The graph cuts through that, right? Then at 180, what is 180? So we know the fact that 180 is 225, which is where it curves. So this is where it would curve. So we have all the points, right? So now sketching the graph is going to look like this. So it's going to look like, remember the fact that it curves here. So this will be the graph, right? So here, remember the fact that it curves at 90. So it's going to be like this, right? Not as crooked as mine, but this is going to be how the graph would look. So this is how the graph would look. Now erasing the portion that you don't want, right? So let's do this. Let me just do this so that when I erase this, it doesn't go. So this is going to be, this portion is not needed anymore, right? So this portion of the graph is not needed because remember that our graph is between 0 and 180. And also this portion is not going to be needed. So if I put a restriction here like this, do you see this portion is not going to be needed too? So this portion here is no longer going to be needed. So this is how you would sketch this graph. So now what we're going to do is we're going to do question 3, right? So with question 3, they say consider f of x. Let me just change my pen. It says consider f of x is equals to negative 2, 10, 3 over 2x, right? So 6.1, it says what? It says write down the period of f. So we know the fact that period, right, is going to be equals to what? It's going to be equals to the following. It's going to be period, it's going to be, because this is 10, it's going to be equals to 180, right? Divided by what? Divided by 3 over 2, which is the same as what? Which is the same as saying 180 divided by 3 over 2, right? So when you pass that into the calculator, you're going to get that the period here is going to be 120 degrees, right? So now we're going to move to 6.2. It says what? It says a point A, which is t is to 2, right, lies on the graph. Then they say the fact that determine the general solution. Do you see the fact that here we just need to determine the general solution? So we're going to substitute point A, right, into what? Into f of x, right? So let's do that. So it's going to be what? F of x is going to be 2 is equals to what? To negative 2, 10. Then this is going to be 3 over 2. Then this is going to be what? This is going to be t, right? So now we want the trig ratios alone, right? So we're going to divide both sides by negative 2. So this is going to be the same as negative 1 is equals to 10. Then it's going to be 3 over 2. Then this is going to be t, right? So let's just rewrite it properly, which is like this. 10, 3 over 2, t is equals to negative 1, right? So since this one, it's not like it has a coefficient in front of it, it's the same as saying let x now equals to what? To 3 over 2, then t, right? So this is going to be the same as 10. Then you're going to say what? X is equals to negative 1, right? So now with that said, we're going to look for the reference angle. So it's going to be the reference angle is equals to what? Is equals to arc 10, right? Which is what you call this positive 1. Remember the fact that we never put a negative. So therefore the reference angle is going to give us 45. Remember the fact that the sign is there for what? Is there to tell us which trig ratios we should, what you call this, which quadrant we need to pick from, right? So we know the fact that this is all student take coffee. So where is 10 negative, right? It's negative in the second and the fourth quadrant. So the second is 180 minus theta, and the fourth quadrant is 360 minus theta, right? So now in the first quadrant, so right now in the first quadrant, in the second quadrant, right? So it's going to be in the second quad, we're going to have what? We're going to have that x is equals to what? Is equals to 180, right? Minus 45. Because the theta is the reference angle, and this is going to be plus k. Then this is what? This is 180, because that's the period, right? Then now, this is going to be what? This is going to be the same as x is equals to what? Is equals to, when you say 180 minus what? Minus 45 is the same as having 135, right? Plus k, then this is going to be 180. Remember the fact that x, we substituted what we said, let x equals to what? Remember here, we said let x be equals to 3 over 2 t, right? So we're going to say 3 over 2 t is equals to 135 plus k, 180 degrees, right? So everything is degrees, right? So now what we're going to do is we're going to divide both sides by what? We're going to divide both sides by 3 over 2. So that's the same as t is equals to 135 divided by 3 over 2, right? Plus k multiplied by 180 divided by 3 over 2, right? So now, with that said, we know the fact that this, when you punch that into the calculator, you're going to get that your t is equals to 90, right, degrees plus k, then here's going to be what? Multiplied by 120 degrees, right? So that's your t. So now, moving to the fourth quadrant. So this is going to be the fourth quadrant. We know what? We know the fact that it's what? It's x is going to be equals to 360 minus theta, right? It's going to be 360. Let's not say minus theta. Substitute the reference angle, which is 45. So it's going to be 360 minus 45 then this is going to be plus k, then this is going to be 180, right? So therefore, x is going to be equals to what? When you say 360 minus what? Minus 45 is the same as 315 plus k, then this is going to be 180, right? Then replace this x by what? By 3 over 2t is equals to what? To 315 plus k, then this is going to be 180, right? So divide by what? Divide on the other side by 3 over 2. So this is going to be t is equals to 315 divided by what? By 3 over 2, right? Then this is going to be plus a k, then it's going to be 180, right? Divided by what? By 3 over 2, right? So this is the same as t is equals to, 315 divided by 3 over 2 is going to give you 210, right? Plus k, then this is going to be 120, right? And this is when k is an element of integers. So that's how you would solve this. And remember, they said the general solution. That is why we going to need the plus k, 120, and in both solutions, right? So that's how we would answer this question. So now we're going to do 6.3, right? So with 6.3, remember the fact that you need the mother graph, right? And if it's negative, if that mother graph is like reflected the way ours is, we're going to reflect it, right? So this is how the graph, this is the mother graph when it's negative 10x, right? And this is perfect because if we're dealing with negative 2, 10x, right? Negative 2, 10, then it's going to be 3 divided by 2x, right? So now I've marked out the important points on the graph, right? On the mother graph, right? Which is in our case, because if we're dealing with negative, it's going to be negative 10x, right? So now dealing with the important points, that's the ones that we're basically going to use, right? So remember the fact that our graph, it needs to be restricted between negative 20, right, and 180. So we need to draw the graph that we need within this region, right? But before we do that, right, we're gonna basically remember the fact that we're ending at negative. We're ending where? So if I highlight here, if we had to highlight the position that we, highlight where we're ending at 120. So where will be 120? So we're ending here. Do you see that? We're ending, and I don't want to do it in that color. And let me just take my pen. Yes, we're ending here. This is where 120 is, right? Until 180, so it's going to be till here. Do you see that? So that's how our graph needs to be, right? But first, we see the fact that this graph has a couple of features, right? Is that one, we have a 2, a negative 2. And another feature here is that we have a different period, right? So what we're going to do is we're going to take each and every important point, which is in our case is from where? It's from 0 till 180, right? And we're going to basically reduce it to meet this graph, right? So let's do that, right? So now, since our graph has a period, its period change from being 180 to 120, right? Is that we need to divide each point, and I'm just going to do what? I'm just going to do the negative side because of the negative side reflects the positive, right? So I'm going to just do the positive side, right? Because as I said, the fact that it reflects the negative, right? I'm going to take each point here and I'm going to divide it, right? By what? By 3 over 2. So that's what we're going to do. So it's going to be 0, right? Because that's an important point. And we're going to divide it by what? By 3 over 2, right? And we're going to get 0 there. So 0 doesn't change, right? So the 0 doesn't change. Then we're going to take the 45, right? Where it curves. And we're going to divide it by 3 over 2. And when you say 45 divided by 3 over 2, we're going to get what? We're going to get 30. So now it's going to curve at 30, right? And then now what you're going to do is you're going to take 90, right? The asymptote, which is going to be 90, right? And you're going to divide it by 3 over 2. So when you say 90 divided by 3 over 2, you're going to get what? You're going to get 60. So the new asymptote here is going to be 60, right? Then you're going to take what? You're going to take 100 and then you're going to take 135, remember, where it curves. So you're going to take 135 right? So you're going to take 135, right? And you're going to divide that by what? You're going to divide that by 3 over 2. So when you say 135 divided by 3 over 2, so it's going to be 3 over 2, then it's going to give us what? It's going to give us 90, right? So it's going to curve it 90, right? And then you're going to take what? You're going to take 180, right? Then you're going to divide that by what? By 3 over 2. So when you say 180 divided by 3 over 2, we're going to have the fact that that's going to be 120, right? So now, since our graph needs to end at positive 180, we're going to take the next point, which is the next important point, which is 225, right? And we're going to divide that by 3 over 2. And remember that the next point is where the graph curves, right? Do you see the fact that that's where the graph curves? So it's going to be 325 divided by 3 over 2. So it's going to be 3. So it's going to be 3, right, over 2, which is going to give us 150. Since 150 still, right, it's within, let's take the next important point, which is in our case, is going to be 270. So it's going to be 270 divided by 3 over 2. So when you say 270, right, so when you say 270 divided by 3 over 2, you're going to get 180. So this is where it's going to end, right? That's where it's going to end. So now, remember the fact that this reflects. So in the other side, in the negative side, it's going to end here. It's going to end here, right? It's going to end here. So now, knowing that, let me just write the values here. So it's going to be 0. 0 goes to 0. When we divide by 3 over 2, then it's going to be 45 goes to 30, right? Then it's going to be 90 goes to 60, right? Then it's going to be 135 goes to what? Goes to 90, right? It's going to be 180 goes to 120, right? Then it's going to be 225 goes to 150, right? Then the last one is going to be 270 goes to what? Goes to 180. So I'm just going to erase that here because I need space to sketch, right? So let's erase this one. That said, we're going to draw our Cartesian, right? So it's going to be what? It's going to be like this. So I don't know whether this is going to be enough space, but it's going to be like this. So it's going to be like this. So let's mark everything, right? So it's going to be what? It's going to be 0 here, right? And this is going to be 30. 3, so it's going to be 3, 6, 9. So this is going to be 30. This is going to be 60. And this is going to be 90, right? So it's going to be 3, 6, 9. Then 12, right? Then 12. Then after 12 is going to be what? It's going to be 15. Then it's going to be 80, right? So it's going to be 3, 6, 9. Let's just make it a little bit bigger because I feel like the intervals are very small. And I do not like that. So it's going to be 3, 6, 9, 12, 15, then 18. Remember that it's ending at 180. So this is going to be 0. This is going to be 30. This is going to be 60. This is going to be 90. This is going to be 120. This is going to be what? 150. Then the last one is going to be 180, right? So here it's going to be what? It's going to be 3 and 6. It's going to be 3, 6, 9, and it's going to be 12, right? So just put zeros like this, right? So now we're going to match up each interval. Remember I said 0, it's 0. So we know the fact that the graph here, right, at 0, it's 0. So we know the fact that at 0 is going to be 0, right? So at 0, and then it's still 0. And remember, at 0, it cuts through, right? Then we see at 45, here 45, right? It's where it curves. So here, the very important thing is this one, right? Is that, do you see the fact that here is negative 2? Meaning here, where it curves, it's going to curve when y is what? When y, let me just change my pen here. When y is at what? It's at positive 2. That's where it's going to curve. And at y is equals to negative 2. Because of this 2, right? That's where it's going to curve. So the number that's in front of 10 is, it tells us where the graph is going to turn, right? So we know the fact that it's going to turn here, and let's just put dotted lines here, like this, so that we know the fact that that's where it's going to turn, right? Before we move on, let's just put in the asymptote, right? So we see the fact that our asymptote, and I'm going to highlight them right here now. We see the fact that our asymptote is related to 90 and 270. So here it's going to be 90, right? Even negative 90, which is going to be 60, and 270, which is going to be this one, which is going to be 180. So our two asymptote, if we put them down here, it's going to be where? It's going to be at 60 with this graph. So it's going to be at 60, right? And it's going to be at 180. So that's going to be our asymptote. And remember that, again, we're going to have an asymptote at negative 60. So that's your asymptote, right? So we are sorted with asymptote, right? So now we can talk about the curve thing, right? So we know the fact that after that, actually, let's put where the graph is going to intersect. So we see the fact that the graph intersected 0 at 180, right? So where is 180? 180 is here. So this is where it's going to intersect, right? So 180 changes to 120, so it's going to intersect here again, right? So again, so it's going to be 120, so it's going to intersect even here at negative 120, right? So that's where it's going to intersect, here and here. And again, where is it going to intersect? I think that's it. It's going to be 0 and 120 in terms of our situation, or in terms of the region, right? So we're done with where the graph is going to cut on the x-axis, right? So now we're going to move to the curve part, right? So with the curve part, we see the fact that it's going to curve at 45, and 45 is related to 30. So do you see the fact that at 45 is related to 30? So at 30 here, it's going to curve here. It's going to curve here, right? And let's just draw a dotted line here, so we can know where it's going to curve. So it's going to curve here at 2, right? So it needs to curve here at 2. And then, so we sorted with this one, right? And it's going to curve at 130, right? So do you see the fact that it's going to curve at 130? 130 is related to 90. So it's going to curve where? It's going to curve now here, right? Do you see the here at blue? It curves there. So it's going to curve there at 2, right? Positive 2. Then we see again that where is it going to curve? We see the fact that, so this one is sorted. So it's going to curve at 225, right? Which is related to 150. And you see the fact that at 225 is bottom. So it's going to curve there here. So that's where it's going to curve, right? So now relating this to the negative. So it's going to curve at negative 30, which is going to be here. Do you see the fact that negative 45 is up? And then what's related to, what you call this? Yeah, I think that's it. It's going to curve here. Then there isn't any, what you call this, the curves is, remember is what? It's, let me just put dashes at curves. So it's going to be like this, so I can know. So it's this one, then it's this one, right? So we know the fact that it's negative 30 again, then it's going to be negative 90. So with negative 90, right, it's related to negative 135, which is going to be where? Which is going to be negative 135 needs to be here, right? Do you see the fact that 130, negative 135, I didn't even highlight it. It comes here at the bottom. So we see the fact that 130 here, this one is going to be negative 90, which is negative 135. So it's going to curve at the bottom like this, right? Here. So that's where it's going to do, right? So now let's connect. So this graph is going to go. So this graph is going to go like this, curving there, then curving here, right? So that's one, Then here it's going to be like this. It's going to curve here. Then it's going to go straight and it's going to curve here. Right? So that's that. Then here it's just going to go down and it's going to curve here. And that's how you would draw this graph. And just putting the restriction, this is how it's going to look. So putting at 120 because that's the end point from the negative. And let's just erase this in this. And this is your graph showing where it's going to curve and also showing the intercept. So this is your graph complete, right? So now let's answer what? The 6.3, right? Let's answer 6.4. And I'm going to use 6.4 because I need the graph here, right? So I'm going to answer it here in the small space that I have, right? So now moving to 6.4, right? So with 6.4, it says use the graph, right? So it says use the graph to determine the values of x that will have f of x is greater than and equals to 2. So with that first, we need to mark out where is 2. So let's mark out. We see the fact that 2 is here, right? So you're going to draw either a straight line or dotted line. And then you're going to highlight where it's greater than 2. Greater than 2 meaning it's any number that's bigger than 2, meaning here it's going to be 3, 4, 5. So I'm going to highlight everything that is above this, above 2, which that represents greater than 2, right? So that's that, right? So this is going to be greater than 2, right? So now with that said, right, let's answer the question, right? We need x values. So now we need to cut down our graph in terms of where it is greater than 2. So first we need to mark off these points. So we need to mark off these points, right? So this point here, we know it as what? It's at 30. So this is going to be negative 30, right? And what? And 2. This point here, right, is going to be what? It's going to be 90 and 2. And the reason why we're marking this point is because of that's how our answer is going to be, right? It's going to be between those x values because our answer needs to be in terms of x, right? So we know the fact that this one is negative 60 because there's an asymptote and this one is positive 60, right? And this one is going to be negative 120, right? And this one is going to be positive what? Positive 180, right? So remember the fact that this one is not an asymptote. Let me just put a solid line so that you know the fact that this is not an asymptote. It's where the graph ends. I hope that makes sense, right? So now you're going to mark off what? The point where, what you call this, it's equals to 2, right? We see the fact that that point is at negative 30, right? And 2, so that point, I'm going to mark it off. And again, it's at 90. So do you see the fact that I already drew the dotted line, right? So with that said, now I'm going to split my, I'm going to split my graph. So we see the fact that from 120 till 60 is the first region. So this is going to be the first region, right? From negative 60 because of even the asymptote plays the breaking down, right? Then from negative 60 till, till 30, this is going to be the second region. And then from, negative 30 till where? Till the second asymptote, right, which is 60. This is going to be the third region. Then from 60 till 90, this is the fourth region. Then from 90 till 180, it's going to be the fifth region, right? So I'm going to look at each component and see, does the graph is f of x greater, ne? So that's what we're going to look for. So now we're going to start from the first region, from negative 120 till negative 60. Do you see the fact that our graph is in the everything that's below? It's not the highlighted part, right? So this is not going to be part of our solution. But if you say from negative 60 till 30, do you see the fact that the graph exists there? So this one is going to be part of our solution. From negative 30 till where? Till 60. Do you see the fact that our graph is in where? It's in the region that's not highlighted. So this portion is not part of our solution. But from 60 till where? Till 90, do you see the fact that we have a graph? So this one is going to be part of our solution. But then from 90 till 180, do you see the fact that the graph is at the part that we did not shade in? So this is not part of our solution. So to answer this question, it's going to be that x is an element, right? So where I ticked off, it's going to be from where? Let's check whether it's equals to. So it's going to be from negative 60. And the reason why it's a curved bracket is because of negative 60 is an asymptote, right? So it's going to be from negative 60 till what? Till negative 30. So this is going to be till negative 30, right? And this is going to be a square bracket because of this is what? This is not an asymptote. And they said greater than and equals to, right? Or it's going to be from where? It's going to be from 60. Remember the fact that 60 is an asymptote. So it's going to be curved bracket. So it's going to be 60 till where? Till, remember it's 60 till 90, right? So it's going to be 90. And 90 is a square bracket because of that's not an asymptote. And they said greater than and equals to. So that's how you would find the solution for this answer, right? So now moving to 6.5, right? It says, describe the transformation of the graph F to form a graph of this form, right? So we need to basically describe the transformation of G, right? So, and we need to describe the transformation relating it to f of x, right? So we see the fact that f of x is like this, right? And now g of x, we need to make it a little bit similar to this, right? So we know the fact that g of x is equals to negative 2. Then this is going to be 10. Then this is going to be what? This is going to be 3 over 2 x, right? Plus what? Plus 60 degrees, right? So we see the fact that we have the negative 2. That's sorted. We do have the negative 2 here. Then now what we need to do, we need to take out 3 over 2 as a common factor, right? Because we need to know how did x become affected, right? When it's inside a bracket. So this is going to be negative 2. Then this is going to be 10, right? Take out 3 over 2 as a common factor. So this is going to be 3 over 2. Then when you take it out, it's basically dividing this 60, this x, this 3 over 2 by, dividing this 3 over 2 x by 3 over 2. That's how you take it out. So you're going to have x here. And divide this 60 by 3 over 2. So if you say 60 divided by 3 over 2, you're going to get plus 40, right? So here, how do we find it? It's basically 60 divided by 3 over 2. It's going to give you 40, right? So now what do we see? We see the fact that the graph actually moved how many units? It moved 40 degrees, right, to the width, to the left, because it's negative, right? It's positive, right? So we see the fact that since it's positive, since P is positive, which is equals to 40, right? The graph moved how many units? It moved 40 degrees to the what? To the left, right? So your answer here is that the graph, right? So you're going to say the graph moved, just say that, the graph moves 40 degrees to the what? To the left. And that's how you would answer this question. So now what we're going to do is we're going to do question 2, right? So it says in the diagram below we have f of x is equals to cos 2x and g of x is equals to negative sine x are thrown in the interval between negative 180 till 180. And A and B are the what? Are the points of intersection. So we know the fact that this point here and this point here are intersection, right? Of F and G. So now let's just answer the following questions. So number 1, which is 6.1, right? It says what? It says without using a calculator, determine the value of x for which cos 2x is equals to sine, is equals to negative sine x, right? So it's basically finding the intersection between the two, right? So we know the fact that we're going to have the following. We're going to have cos 2x, right? It's going to be equals to what? It's going to be equals to negative sine x, right? So we see the fact that this is an identity and we have 3 options, right, in the identity. We have the one that says what? We know the fact that it's cos 2x, right? We have the one that's both sine and cos. So it's the same as cos squared x, right? Minus sine squared x, right? Sine x, right? Then we have the other one, which is going to be what? Which is going to be 1 minus, right? It's going to be 1 minus 2 sine squared x, right? Then we have another one, which is cos 2x is equals to what? Is equals to 2 cos squared x minus 1. So here, do you see the fact that on the other side we have what? We have negative sine x. So the best option here would be this. So I'm going to substitute with this, and that's going to create factorization, right? So replace the cos 2x by that. So it's going to be 1 minus 2 sine x squared is equals to negative sine x, right? So take this, take this one to one side. So this is going to be the same as 0 is equals to what? Is equals to 2 sine x, right? Then this is going to be minus sine x, right? And this is going to be what? This is going to be minus 1, right? So this is let, do you see the fact that this is factorization? So I'm going to say let k equals to what? K equals to sine squared x, right? So with that said, not sine squared x, just sine x, right? Yes, so just sine x, right? So with that said, I know the fact that this can be what? It can be rewritten as 2k squared minus k minus 1, right? So let's factorize that. It's going to be what? It's going to be open bracket. You're going to have 2k plus 1, right? Then you're going to say k minus 1, right? So this is the same as having k is equals to what? To negative a half. Or you're going to have that k is equals to what? It's going to be equals to positive 1. Replace k by sine x, so it's going to be sine x is equals to negative a half. Or it's going to be what? It's going to be sine x is equals to positive 1, right? So that one we sorted. So now we're going to look for what? We're going to look for the general solution, right? But in our case, it's the general solution within this interval, right? We need to restrict it within this interval, right? So that's what we're going to do. So we're going to do what? We're going to first look at for this one. So for sine x is equals to negative 1 over 2, right? So for that one, we're going to find the reference angle. So the reference angle is going to be equals to what? To arc sine, right? And this is going to be positive a half, which we're going to get our answer as being what? As being 30 degrees. So this is going to be 30 degrees, right? So this being 30 degrees, we know the fact that sine is what? So I'm going to just erase this identity because I need, yes, erase this. So we know the following. So let me just put it here. We know the fact that this is all students take coffee. So where's sine negative? It's negative in the third and in the fourth quadrant. And this is 180 plus beta, and this is 360 minus theta, right? So with that said, we know the fact that it's in the third and fourth where it's negative. So in the third quadrant, it's going to be the following. We know the fact that, let me just do it here. So in the third quadrant, so I can have space, right? Is that we know the fact that it's going to be what? It's going to be 180. So this is the same as x is equals to what? To 180, right? Plus what? Plus 30. Then you're going to say plus k. Then it's going to be what? Plus k is going to be what? It's going to be multiplied by what? By 1. It's going to be multiplied by 360, not 180, right? Then here's going to be x is equals to what? When you say 180 plus 30, you're going to have 210 plus k 360, right? So with that said, now we're going to move to the fourth quadrant. So in the fourth quadrant, right, we're going to have that x, or x, right, is where it's 360 minus 30, right? And this is going to be plus k 360, right? So this is going to give us what? It's going to give us that x is equals to 330, right? Plus k 360, right? So that one we sorted. We know the fact that these are the two answers, right? So now we're going to go to what? We're going to go for what? We're going to go for when we have sine is equals to positive 1, right? So we know the fact that the reference angle is equals to arc sine, right, of 1, which is going to be equals to what? Which is going to be equals to the following. It's going to be equals to, when we have what? So if we say arc sine, we're going to find the fact that it's going to be 90 degrees, right? So where is sine positive? In the first and second quadrant. So in the first quadrant here, right, it's going to be what? It's just alpha, and here's 180 minus alpha. So it's going to be x is equals to just 90 degrees plus k, and this is going to be what? This is going to be 360, right? Then in the what? In the second quadrant, right, it's going to be the following. It's going to be it's going to be x is equals to 180, right, minus 90, right, which is going to be plus k 360. So this is the same as this answer. So this is going to be the same as 180. This is going to be the same as 90 plus k 360, right? Remember, we have a restriction, so we need to find when k, right? So we have a restriction, so we need to find when k is between what? Is between when our x value is between 180 and negative 180 and 80, this restriction, right? So we need to look for when k, we're going to start when k is equals to negative 2, right? Then we're going to look for when k is equals to negative 1. Going to look for when k is equals to 0. When k is equals to what? Is equals to, k is equals to 1. And when k is equals to positive 2, right? So now I'm going to do it. I'm not going to show the working out here. I'm just going to write the answers, right? So looking at this one, right? Now substituting when k is negative 2, right? So here, if you say 210 plus, then it's going to be negative 2, right? Negative 2, then you're going to say multiply by 360. You're going to get the following. So this is going to be 510. So that's definitely not part of our region. So now, if you change this one now, it's going to be 3. Looking at this one now, Anna, it's going to be when we say 300 and, when we say 330, right? So we're going to get, when we say 330 plus negative 2, right? 360, we're going to get our value as being what? As being negative 390. That's not part of it. Then here, remember, this is the same thing. We're just going to look at this one only. So now it's going to be 90. So it's going to be when 90 plus the k is going to be negative 2. We're going to get the fact that this is going to be what? Negative 630. So when k is equals to 2, all of them, they're not part of our solution, right? So now we're going to change when k is equals to negative 1, right? So we're going to go back here again, right? So it's going to be 210, right? 210 plus open bracket negative 1, 360. We're going to get that our first value is going to be negative what? Negative 150, right? So do you see the fact that negative 150 is part of this? So this one is going to be a tick, part of our solution. Then we're going to move to 330. So when we do the 330, substituting what? Substituting negative 1 as k, 330, we're going to get that we get negative 30. Right? So we're going to have negative 30. That's part of our solution. So that's sorted. Then now we're going to move to when it's 90. Right? So when we say it's 90, meaning it's going to be here, right? We're going to have negative 270. So this is going to be negative 270, right? This is not part of our solution. Negative 270 is not part of our solution, right? So now we're going to move when k is 0, right? Going back here, right? Going back to the 220. So, but now substituting when k is 0. So it's going to 210, right? Plus 0 multiplied by 360. This is going to give me 210, right? That's not part of our solution. That is greater than 180. So now let's substitute now when it's 330, but k is 0. So that's going to give us what? 330. It's going to give us another 330. That's definitely not part of our solution, right? Then now we're going to move when it's what? When it's here, right? So we're going to move now when it's 90. So if we say 90 multiplied by 0, then multiply by 300 and 300 and what? 370. Then this is going to give us what? 90 here, right? So 90 is part of our solution. So that is going to be that one. Then now we're going to move when it's 0, right? Go back here now, but substituting 1. So we're going to say what? We're going to say 210 to 10, right? Multiply plus 1 multiplied by 360 is going to give us 570, right? So that's not part of our solution. But now if we say what? If we say 360 again. So if we say 330, multiply by 1 multiplied by 360, that's going to give us what? This is going to give us 600 and what? This is going to be 600 and... So this is going to be 690, right? Not part of our solution. Then now, if we say 90, if we substitute for 90, we're going to get 440. So that's not part of our solution, right? So we know the fact that if 1, all of them, they're not part of our solution. Definitely 2, not all of them, they're going to be part of our solution, right? So our answers here is going to be the ones that I ticked, which is this one, and this one, right? So our answer there is going to be that, let me just write it in dark blue. It's going to be when x is equals to negative 150, right? And we have x is equals to negative 30. And the last one is that when x is equals to 90, which matches up here. Do you see the fact that 150 meaning it's going to be here for A? So this is going to be negative 150 for A. Then for this one, it's going to be what? It's going to be negative 30. And for this one, it's going to be the 90. Do you see that? It's going to be the 90. So do you see the fact that all of them are sorted now? So that's how you would do this question, right? So now moving to the next question, it says, use the graph below to answer the following question. So for 6.2.1, right, it says how many degrees apart is A and B? So we know the fact that A is what? It's negative 150, right? Remember? Then B is what? Is negative 30. So apart meaning they want the distance between here from 150 and when we here at 30. So we want this distance. Let me highlight it. So the distance or the degrees apart, we're looking for this distance, right? So this is negative 30, right? Not 3, negative 30. So how would we find the distance apart between the two? It's going to be very simple. You're just going to take this one, right? The bigger one minus the smaller one, right? So we know the fact that the distance between A and B is going to be equals to what? Is basically equals to B, right, minus A, right? Which is the x-coordinate of B is what? It's negative 30 minus the coordinate of A, right? So this is going to be what? This is going to be negative 30 minus 150. It's going to give us 120. So that is the distance between A and B, right? I hope that makes sense. So this is 120 degrees, right? So now we're going to move to 6.2.2, right? It says for which values of x, right? So for which values of x will the given interval, right? Meaning when f prime of x and f prime of g is greater than 0. So let's look at this in this way, right? So I want to do the following. I want to erase this diagram before, right? So when we're doing calculus, remember I said the following. I said when we're finding increasing and decreasing, right, we look at the turning points. So here, what's happening in the equation is that when f prime x, right, multiply for when f g x is greater than 0, meaning it's positive, right? So I'm looking for when both, here I'm looking for when both f of x and g of x are increasing, right? And the reason why increasing is positive, right? Increasing is positive, right? So we know the fact that a positive multiplied by a positive, it gives you a positive. So that is why this one, it means that if I take a positive and I multiply it by a positive, right, I'm going to get a positive. Because that's what? That's less than, that's what you call this, that's greater than 0, which is positive, right? Or I'm looking for when both f of x and g of x are what? Are decreasing. So here, what am I looking for? I'm looking for now when they're negative. So remember, the decreasing means negative, right? So it's when negative multiplied by another negative, it gives you what? It gives you positive. So that's why you're looking for when they both increasing and when they both, increasing, right? So your answer, because of it needs to be in terms of x, is going to be divided by the turning points, right? So your turning points is going to be here, right? And here for the other graph, right? So this is going to be here again and here again, right? So now looking at your information, right? Do you see the fact that cos, f of x is cos? So let's just highlight f of x and g of x, right? So f of g of x is going to be this one in yellow, né? So this is going to be g of x. We're going to write the maximum and the minimum, right? So we know the fact that this one is going to be what? This is going to be considered as what? As our g of x. Then now, let's move to f of x. So f of x is going to be the green one, right? So it's going to be the green one. So it's going to be the green one, like this. So we need the turning points, right? I'm just going to look at this one, right? The g of x, right? So g of x first, what is our what? What is our... where is our maximum and minimum, right? So we know the fact that maximum and minimum at sign happens where? So if I had to draw this mother graph, it happens at the following position, right? It goes through here, right? It cuts. So the maximum or minimum happens here at 90. Since it's negative, it's going to be 90, right? Then it's going to be where? It's going to be at, at 180 again, right? So we see the fact that this here is going to be 90 degrees, and this here is also going to be negative 90. So do you see the fact that both the green and the yellow share the maximum, share the turning point, the x coordinate, right? That's what I need. I need only the x coordinate, right? So with that, from looking from this direction, I'm going to check where it's increasing and decreasing, right? So from going this, I'm going to do the green one. Do you see the fact that the green one has what's happening? It's going down. If I'm moving this direction, do you see that? If I sketch down or write arrows, they're going to be moving down, right? Then from the turning point, right, which is from negative 90, on the green one, do you see the fact that now I'm going to be going up? Which represents what? Which represents increasing, right? Then I'm going to go down, which represents decreasing, right? Then I'm going to go what? I'm going to go up, which represents increasing, right? So that's what's going to happen, right? So that's for the what? That's for the green graph, right? So now I'm going to do the yellow graph. From this point till the turning point 90, do you see the fact that we're going up, right? We'll be going up. So this represents increasing, then we're going to go down from negative 90 till the next turning point, which is positive 90. So we're going to go down, right? Then here we're going to go up. So here what I'm going to do is I'm going to separate them by highlighters, right? No, let's not do it by highlighters. Let's do it by color, right? Let's just pick red, right? For increasing, I'm going to represent it by red. Then for decreasing, I'm just going to leave it in blue, right? For increasing, it's red. So this one is going to be red now. So we can see where they both increasing and both decreasing, right? So increasing is going to be red. So this one is also going to be red. Because remember, it represents increasing, right? And this one is going to be red. Do you see that? So this one's going to be red. and this one is also going to be red, right? So now remember the fact that our answer is divided by the turning points, right? So our answer is divided here by the turning points, the x-coordinate of the turning points, right? So we're going to look at the following region. This is part 1, part 2, right? And this is part 3, right? From negative infinity now, right? Till what? Till 90. Do you see the fact that the green graph is what? The green graph is actually decreasing, but the yellow graph is what? It's increasing. So this can be part of our solution, right? But from 90, negative 90, right? Till where? Till 0. So remember the fact that even 0 is one of the turning point. It's the turning point for the green one, right? So it's going to be 1, 2, 3. Then this is going to be the fourth region. Yes, right? Then from negative 90, right? Till what? Till 0, right? Do you see the fact that what's happening is that the yellow graph is decreasing, but the green graph is increasing. So that's not part of our solution. But do you see the fact that from 0 till positive 90, they both going down, right? Both the green and yellow are going down. So this is part of our solution. Then from 90 till where? Till 180, right? Remember the fact that from till 180, because that's where our region ends, right? What happens is that both our graphs are going what? Are going up. So that's when they both increasing. So there's two parts where I take this part of our solution, right? So our answer here to answer our question is going to be that x, right? X is an element where they both decreasing, which is going to be from where? From when 0 till where? Till 90 degrees, right? So from 0 degrees till 90 degrees, or, right? So this is curly bracket because of they didn't say equals to, right? Or it's going to be where? It's going to be from 90 degrees till where? Till 180, right? X is an element. And that's how you would write your solution. So that's how you would do this question, right? So now what we're going to do is we're going to do 6.3, right? So it's 6.2.3. It says determine the value of k for which cos 2x plus 3 is equals to what? Is equals to k, right? So first, I want to discuss what it means will not have any solutions. We need to discuss what it means, and I'm going to just do it in a general form before we do this question, what it means to not have a solution, right? So with this one is that let's minus the k thing, right? Let's not have the k, right? Is that if we have y is equals to cos x, right? Or even sine x, then you know that your graph looks like this, right? It's going to look like this. So this is going to be how your graph would look, right? So this is going to be just the mother graph of what? Of of cos, right? So what affects our graph to have a solution or not, right? It's actually the q value, right? So it's actually the q value, right? So the q value affects our graph having what? Solution or not. And remember the fact that solution is finding the x-intercept, right? So it's this equated to 0. So this is 0. It equals to cos y plus q, right? Remember the fact that q affects us having the solution or not, right? So I'm going to take the q to the other side. So this is going to be the same as what? As negative q is equals to what? It's equals to cos x, right? So depending on how we move depending on how much we move the graph up or down, it's going to tell us on whether we're going to have a solution or not, right? So now, as I said, the fact that it's dependent on q, right? And it's also dependent on our maximum and minimum from the original graph. From this graph, what is going to be our maximum? Our maximum is going to be this point. Do you see that? At 1. Then our minimum is going to be at this point, which is going to be what? Which is going to be negative 1, right? So do you agree the fact that if I move the graph, right, the maximum amount, what's going to happen is that my graph is going to move the maximum amount, which is 1, right, which is going to be here. So now my graph is going to be at 2 because it moves 1 unit up, right? So now this point here is going to be here. Then this point here, and let me just change my color because I feel like that's too light. So I'm saying the fact that this is the maximum and this is going to be the new maximum, right? Because this point is going to move here. This point is going to move 1 unit up, which is going to be here, right? And this point here is going to move here, right? And this point here is going to move here. So just drawing this side of the graph, this is how the graph is going to be. Do you see that? So this is how the graph will be, right? Meaning now your new maximum is going to be 2, then your new minimum is going to be 0, right? So do you see the fact that if I move it slightly, anything greater than, anything greater than 1, right? Do you know the fact that we moved it 1? Meaning here Q is equals to 1. If I move it anything slightly greater than 1, right? Do you see what's going to happen is that it's going to be somewhere here, right? Our graph, our new graph is going to be the dotted line, this one. Do you see the fact that now my graph doesn't touch? It doesn't do what? It never touches the x-axis, meaning it's not going to have what? It's not going to have any what? Any x-intercept, right? Knowing that knowledge, right, we're going to relate it to what the question wants. So now let's discuss what happens here, right? Your Q value for it, if you have this graph, right? So let's say this is a positive Q, right? Your Q value having this graph, which is cos x, which is the maximum and minimum, you know the fact that it's, the maximum is 1 and the minimum is -1, right? Is that for us not to have any root, right? Looking at this, we see the fact that our Q value needs to be what? Needs to be anything that is what? That is greater than what? Greater than 1. Do you see the fact that anything that's greater than 1, then it doesn't cut, right? And it shouldn't be equals to, because of if it is equals to, do you see the fact that it touches the graph when it's exactly 1? The one that's not dotted, it's exactly, it touches the x-axis. We don't want it to touch the x-axis, right? So anything that's greater than 1, it's going to give us that. And also, we need to look at the minimum situation, right? Is that, or now if I move the graph, how many units? And let's just do it in a different color, that one, right? If we move the graph by negative, by negative 1 unit, what do you see is that if we move it down, is that this one is going to be here, this one is going to be here, right? This point is going to be here, this point here is going to move here, and this point here, right? Do you see this turning point is going to move at -2? So, and this one is going to move here. So our graph is going to be like this. Do you see? Our graph is going to be like this, where it's touching the x-axis if it's exactly 1 unit, right? If it's exactly, if we move it exactly -1 units down, right? But we don't want it to touch. So if it's something greater, if it's something less than, not greater, right? If anything that is less than -1, what happens is that our graph never touches, which is the dotted line that is purple, right? So, or a situation where Q is what? Remember the fact that -1 here, Q here for the purple is equals to -1. So we want anything that is less, right? So anything that is less than, which is going to be represented like this, less than what? The minimum value, right? Which is going to be -1. So here, if we want it to not touch, it's Q, right? Q is greater than the maximum, right? If you just did it by a formula. Or we're looking for when Q is less than the minimum. And this comes from this idea, right? So taking this into account and it being the formula, right? Is that we're going to do the following, right? Now we're going to answer the question in blue. So this is going to be 6.2.3. They gave us what? They gave us that we're looking for when cos 2x plus 3, right, is equals to k, right? We need Q. What is our Q here? Our Q is actually this value. It's going to be what? It's going to be 3 minus k. It's going to be 3 minus k, but I'm going to take the 3 to the other side. So it's going to be the same as cos 2x, right, is what? It's equals to k minus 3. This represents the what? The Q in this formula, right? So here, what is our maximum and minimum? No, we know the fact that our maximum in this graph, because of the coefficient of 1, is going to be 1. Then our minimum here is going to be equals to -1, right? So we're looking for when what? When, remember the fact that it's what? Q is what? Is greater than the maximum, right? Let's substitute our maximum and Q. We know the fact that Q is what? Is k minus 3 is what? is greater than 1. Or we're looking for when Q is what? Is less than the minimum. Which is going to be what? Which is the same as K minus 3 is what? Is less than negative 1. Let's solve for K. So here K is going to be equals to what? It's going to be equals to K is greater than. So if you say take 3 to the other side, it's going to be what? It's going to be greater than 4 here. Then or K here is going to be, when you take 3 to the other side, it's going to be less than 2. So that's how this is how you would solve this question, right? I can't even underline it. Yes, I want to underline this one, but it's disturbed. So this will be your final answer for this question. So now what I want to do is that I want to put the area rule into what? Into practice, basically, right? So what we have is that we have this, and it says the fact that we need to find the area of triangle ABC, right? So one thing about the area rule, you need to understand what information do you need from the triangle to use it, right? So, and I'm just going to take this triangle, right? And actually, let's go back to the proof so that I can see you, so that you can see what I mean, right? So you see that from the proof that we just done is that the area of triangle 1 over 2 QR multiplied by P is sine cube, right? Is that for you to find the area of the triangle, you need the following information. You need the following. You need to have two sides like this, right? And the included angle. Do you see the fact that that's what we proved? Is that there's two sides, which is Q, what you call this QR, and another side, which is PQ, and the included angle, which is this one, right? So this will find the area. So another thing that we could do is that if our angle is this, what you call this, is this P, right? Is that it's going to be two sides in this included angle, meaning it's going to be like this. Do you see that? It's going to be two sides in the included angle. So if I had to write the area of that, it's just going to be basically going to be, this can be also written as the area of triangle PQR is equals to a half. I said two sides, which is my two sides is what? And remember, it's two sides and the included angle. So the angle needs to be in between the two sides, right? So it's going to be PQ multiplied by PR multiplied by what? By sine P, right? So that's two sides and the included angle. So now let's change it and make the fact that we want the included angle, which is going to be, let me just change my color into being yellow, right? Is that we want our R to be what? To be our angle. So it's going to be two sides, right? And the included angle. So the included angle is going to be this one, right? So to write the area, so the included angle is going to be this one, then the two sides. So the area also, you can find the area being what? Is being P, Q, R is equals to 1 over 2, two sides, right? Which is going to be P, R multiplied by R, Q, then it's going to be sine R. So that's how you would find it, right? So with me explaining that concept, the fact that every time when we're looking for the angle, it's always two sides and the included angle, is that when asked to find the area of a triangle, right? And we know the fact that this is not a right angle triangle, is that we need two sides and it's the included angle, which goes in the included angle. So what do we see from our triangle? We see the following. We see the fact that our triangle is an isosceles, meaning if this is 7, and also that means the fact that this is 7, right? That's what we know. And we know the fact that opposite sides are equal. That means that opposite angles are equal. So this one is going to be what? It's going to be 50 degrees too, right? So that's what we know, right? Then what else do we know? We know the fact that the sum of angles in a triangle is equals to 180. So we know the fact that, so let's write what I just did, right? We know the fact that C is going to be equals to what? It's going to be equals to 7. And your reason is going to be what? It's going to be isosceles, right? So isosceles triangle, right? Then we know the fact that even if you don't write the reason, to be honest, is that now we know, because this is not the same as Euclidean where your reasoning is important, but I'm writing it so that you can know why that is the case, right? Then we know the fact that Therefore, angle C is equals to what? To 50 degrees. And right, so it's what? Opposite sides equal means that opposite angles equal. Opposite angles equal. Hope that makes sense, right? So that's what we know. So we know the fact that this is going to be 50. Then I said the fact that this we can find it by sum of angles in a triangle. So we know the fact that angle A plus angle B plus angle C is going to be equals to 180 degrees. And that's what? Sum of angles in a triangle. So sum of angles in triangle, right? Hope that makes sense. So with that said, we know the fact that we're looking for what? So it's sum of angles in a triangle. So now we know the fact that we can find A. So it's going to be angle A. And this is going to be plus 50 plus another 50 is equals to 180, right? Take that to the other side. So it's the same as A is equals to 180 degrees minus 100, which is A is equals to what? Is equals to 80 degrees, right? So this is going to be 80 degrees, right? So we know the fact that that's going to be equals to 80 degrees. So now remember that I said when you're finding the area, what do we need? We need the two sides and the included angles. Do you see the fact that we have two sides, which is this one, right? And before finding anything, we need to find this angle because this is going to be the only included angle. So the area of this triangle, so we know the fact that now area, let me write in the triangle first. Let me erase that. Okay, cool. So it's going to be the area of triangle A, B, C is equals to 1 over 2. Then remember two sides, which is going to be AB, right, multiplied by AC, right, multiplied by sine A. And that is going to be equals to 1 over 2. Then AB is 7. Then this is going to be 7. Then it's going to be sine 80 degrees, right? Punch that into the calculator. You find your area is going to be 24.13 degrees unit square, right? So I just want to talk about why didn't we use B as being the angle, right? So let me just take my pen. I just want to move to highlighter. Why didn't we use B as being the angle, right? So do you see the fact that we have the angle B? For us to find the area is the two sides. We have the included angle, meaning the two sides will be this and this. Do you see the fact that this portion is missing? We don't have this side. We only have one side. So we have one information missing. So that is why we couldn't use that. But do you see with A is that we had the two sides because of this information, the fact that it's an isosceles triangle. And we didn't have the angle. And us solving the angle, we know now we have the angle because of the sum of angles in a triangle. I hope it makes sense why we didn't use B, but we used A instead, right? So now what we're going to do is we're going to do the first example of sine rule. But before we do the first example of sine rule, I'm just going to draw a triangle, right? Just a small triangle, not looking at this information, right? Let's say we have the triangle A, B, and C, right? And I know the fact that I'm going to talk more about it when I show you in different case studies on when to use which one, right? But for us to understand on how to solve this question, you need to understand which information do you need so that you can solve, right? So what sine rule is that always the angle is, if you have an angle, it needs to be related to its sides, the opposite side of it, right? So this angle here, do you see the fact that this angle B is going to be related with this one that I ticked off? And also this angle B needs to be related with the opposite side, and also the C needs to be related with the opposite side. So with that said, is that if maybe we're looking for this AC, for instance, right? Let's say we're looking for AC. For us to solve AC is that we need to have the angle of what? We need to have the angle B. So this one needs to be given, right? So this needs to be given. Then another pair needs to be given, meaning it's either this and this are given, or it's either this and this are given. So there needs to be one unknown. I hope that makes sense. I feel like this is going to make sense when we do questions, right? So let's do this question. So it says, let me just erase this mess that I just created here. So let's just talk about it so that you can see it in action, right? It tells you the fact that triangle TRS, right, where the angle STR is equals to 55 degrees, and they tell you the fact that TR is equals to 30 units. Then they tell you the fact that RST is equals to 40. Then they tell you determine the fact that we need to determine this P, PS, ST, and this angle, right? So now let's draw the triangle with the information that we're given. So this is the triangle. And we know the fact that this is T, so I'm going to start here. So it's going to be TRS. All right? So they tell us the fact that this angle T, which called as STR, is equals to 55. So S is here. So we're going to go in those directions. So it's going to be STR. So they're talking about this angle is going to be 55 degrees. And they tell us the fact that TR is 30, so the side is going to be 30. Then they tell us the fact that RST, so going from this direction, it's RST is equals to 40. So they're talking about this way. See? Then now, since we're given two angles, we can find that angle because of that's going to be sum of angles in a triangle. So we know the fact that angle R plus angle S plus angle T is equals to 180 degrees. The sum of angles in a triangle. So we're looking for angle R plus angle T is what? Is 55 because we're given that. So it's going to be 55 plus 40 is equals to 180, right? Take the numbers in the other side. When we take the numbers in the other side, we find the fact that angle R, right, is equals to what? Is equals to 85 degrees, right? And we see the fact that angle R is the same as what? As TRS. Do you see the fact that it's this one? So therefore, now we already solved this one. We know the fact that TRS is basically equals to 85 degrees. So we have solved the first part. So this is 85 degrees. So we have solved this one, right? So now we need to solve the side. So we know the fact that since we're given all the angles, we can find both sides, right? As I said, the fact that we need to relate it with the side. So let's start finding this side, right? So let's write this side, which is going to be this one, right? Finding this one. Then we know the fact that we need another pair that has an angle in the side. So we know the fact that we have 40 degrees and we're given this one. So we can solve using sine rule. So using that, we know the fact that sine is, right, divided by what? Remember the fact that it's the angle then the opposite side, which is TR, is equals to sine. We're looking for this side, which is going to be sine T, right? Divided by what? By the opposite sign, which is RS, which is this one, the one that we're looking for, right? So let's substitute all the numbers. So we know the fact that sine is what? Is 40 degrees divided by TR, which is 30. Then this is going to be sine T, which is 55, divided by what? Divided by RS, which is the one that we're looking for, right? So cross multiply, so we're going to cross multiply. So when we cross multiply, it's going to be RS, then it's going to be sine 40 degrees, then this is going to be 30, then it's going to be sine 55 degrees, right? Then we need RS and also we're going to divide it. So it's going to be RS is basically equals to what? Is equals to 30 sine 55 degrees, and this is going to be divided by what? This is going to be divided by sine 40 degrees. Punch that into the calculator. When you punch that into the calculator, you find the fact that R is, right, is going to be equals to what? It's going to be equals to 38,2. right? So that is going to be the RS, right? So we have that one sorted. So now we're going to solve for what? We know the fact that this is going to be 38, 2. So now we need to solve for T, which was T is. Do you see the fact that T is, and I'm just going to change the color so that I'm not confusing you guys, is that, do you see the fact that T is related to this R? Do you see? And with another side and the angle, you can use either or. So I'm going to still use this one as our reference, right? And the reason why is that we were given what? We were given this information, and this one is the new information. So if this one is incorrect, I don't want it to affect the other one. That is why I'm using another side that was originally given in the information. I hope that makes sense, right? So now finding what? Finding T is. So we know the fact that it's sine of this area and this one, right? So we're going to use sine of R and sine of what? Sine of S. So let's start. So it's going to be sine S, right, divided by what? Divided by R. T is equals to sine R divided by what? Divided by T is. Let's substitute. So it's going to be the same as sine 40. Now it's going to be sine 40 is divided by what? Divided by divided by sine 40 divided by 30. Then the side is going to be equals to what? To sine 85. And this is going to be divided by T is. Cross multiply. So it's going to be T is. Then this is going to be sine 40. Then this is going to be 30 sine 85, right? And what we're going to do is that we're going to divide both sides by what? Divide both sides by side 40. So it's going to be the same as T is equals to 30 sine 85. And this whole thing is going to be divided by what? It's going to be divided by sine 40, right? Punch that into the calculator. You're going to get the fact that T is basically equals to 46,5. Right? So that's how you would do it. So now we're going to do example 1 using cost rule, right? So cost rule works exactly how area rule works in terms of the fact that to solve it, it's going to be always two sides and the included angle, right? So now they say determine the side of QR, right? So as I said, the fact that it's to solve is that you always need two sides and an included angle. So if they want the angle, let's say this was not there, but they gave us this, right? Is that we need to have all three sides, then that angle that we need. I hope that makes sense, right? So now we need what? We need a QR. So we see the fact that QR is related to what? Is related to this opposite side, right? Because let me just write this. And let me just go here. Okay, cool. Let me write the formula for this one so that you can see the relationship. As I said, the fact that it's always going to be two sides and the included angle. So we know the fact that QR squared is basically equals to what? Is equals to the two sides, which is going to be PQ, right? Squared plus what? Plus, then it's going to be PR, right, squared. Then this is going to be minus 2. Then this is going to be PQ multiplied by what? Multiplied by PR. Then this is going to be cos. Then this is going to be cos what? This is going to be cos P. Okay, so this is the relationship that I want to show you. Is that if they're looking for the side of something, right? This side, the one that's outside, needs to be opposite to the angle that is going to be in the cos. Then the two included angles is going to be this ones. That's going to be the two included angle, the two sides. Then the included angle is here. Then the relationship between these two is that this side needs to be opposite to the angle that you're looking for, right? So with that said, before we move on, is that I want to show you another thing. Is that I want to show you the fact that let's say maybe they gave us R, right? they gave us maybe the angle R and they're looking for this side. How we're going to do it? It was going to be what? Is that, do you see the fact that R is related to this? So meaning we need to start with PQ. So it's going to be PQ, right, squared is equals to, what is the two sides next to Q to R is this two sides. So it's going to be the same as what? It's going to be the same as PR squared plus QR squared minus 2. Then this is going to be PR. Do you see the fact that even here, this and this becomes here? It's going to be the one that's multiplying. So it's going to be the same thing. So it's going to be PR multiplied by what? Multiplied by QR. Then this is going to be cos. And what is the angle that's opposite to that side is R. Do you see that? So now let's move into if like maybe we're looking for Q, right? So the two, which one, it was two sides, which is going to be this one. And the angle that is the side that is opposite to that is going to be PR. So you will start saying PR squared is equals to, what is the two sides? The two sides is PQ plus squared. Then the other side is what? Is QR squared minus 2PQ, right? Then multiply by what? By QR. And this is going to be what? Cos. And the angle is what? Is this one. So that's how you would do it. I hope that makes sense. So with that said, now we can answer this question, right? So in our case is that they're looking for what? They're looking for this side, right? And this side, the angle that's opposite to it is P. So we see the fact that that is why we have QR and P as being the angle, right? So now let's fill in the information because of we have each and every information. We know the fact that QR is what we're looking for. So it's going to be QR squared is equals to what? Is equals to, then this is going to be PR is going to be 13. So it's going to be 13. So it's going to be 13 squared plus, then this is going to be 4 squared. This is going to be minus, then this is going to be minus 2. Then this is going to be 13. This is going to be 4. Then this is going to be cos, and this is going to be 70 degrees. Punch that into the calculator. You know the fact that QR squared is basically going to be equals to 149.42, right? Then square root both sides. So QR is basically going to be equals to 12.2 centimeters. So that's how you would solve this question. I hope that made sense. So now it says the fact that we need to solve angle A, right? So angle A is here, right? So do you see the fact that the side that is related to angle A is what? Is this one. And the nice thing is that they gave us all the sides, right? So it's related to this one. And since we're looking for angle A, the two sides is going to be this one that are going to be added. But the one that is related to it is this one. So our equation needs to start with this side that is opposite to the angle, which is the angle that we want. I hope that makes sense. So we're going to say BC squared is equals to what? Is equals to the two sides that are next to the angle, which is going to be AB squared plus AC squared minus 2. Then this is going to be AB multiplied by AC. Then this is going to be cos the angle that we want, which is A, right? So we know the fact that AB is 7. So this is going to be 7 squared is equals to AB. AB is what? AB is 5. So this is going to be 5 squared plus AC, which is going to be 8 minus 2. This is squared. Then this is going to be 5. And this is going to be 8. And this is going to be what? Cos A squared, right? So that's what we know. So what I'm going to do is that I'm going to expand this. So this is going to be 49 is equals to, when you say 5 squared plus 8 squared, it's going to give you 89, right? And when you say 2 multiplied by 5 multiplied by 8, it's going to give you negative 80. Then this is going to be cos A squared. Not cos A, not A squared. Then we're going to take the 85 to the other side. So it's going to give you what? When you say 89 minus 18, or you call this 49 minus 89, It's going to give you negative 40 is equals to negative 80. Then this is going to be cos A, right? Divide both sides by 80, negative 80. So it's going to be negative 40 divided by negative 80 is equals to cos A, right? So this is going to be the same as positive a half is equals to cos A. Now we want A alone, so this is going to be a cos, then a half is going to be equals to angle A. Punch that into the calculator, you're going to find the fact that A is basically equals to 60 degrees. And that's how you would solve this equation. So now we're going to move to the application of trigonometry functions, right? Which is also the 3D diagram, right? So here, honestly, even like the situation, them talking about evolution and all that, it really doesn't matter. It's understanding what you're given in the diagram and what best formula to use. Remember the fact that the situation, even the paragraph, really doesn't matter, right? Is what you're given in the diagram, then knowing which formula to use. So now we're going to talk about first the sine and the sine rule, right? The formula. Then we're going to talk about the cos, right? Then we're going to talk about the area. The nice thing about the area is that they tell you find the area. So with that one, you don't need to be like, oh my God, which formula should use, but you need to know how to use it, right? But with the sine and cos rule, you need to know which one to use, right? So with that said, we have the following. So we're going to talk about the sine, right? Do you see the fact that it says what? It says sine A divided by A. Then you have sine B divided by, what you call this? Sine B divided by B, or is sine C divided by what? By C, right? So here, what matters is that you need two of this, right? So you either, if you're looking for an unknown, you know the fact that, let's say, for instance, B is unknown, and I'm just going to circle it, right? And let's say in the information that they gave you the following. And I'm going to highlight the information that they gave you, right? Is that they gave you, they gave you A, right? And they gave you the angle A, and they gave you this A. And they also, they gave you B. Do you see the fact that you have three information, right? Do you see you have three information and you will have one unknown? And how do you know that the sine rule is the one that's going to work? Is that from the angle, you need to have a corresponding side, right? Then here, do you see the fact that there's an angle and there's a corresponding side? So do you see the fact that this B relates with this corresponding side? And always draw the line that I'm doing, right? Is that this B correspond to this side, right? Then this A correspond to the side. So if you look at the information, if now we want to solve for B, it's simple. We can use the sine rule because we have 1, 2, 3 unknowns, and we want the one that we actually want, which is B, right? So that's how you would do it. So with this one, it would be what? It would be sine A divided by A, and it's going to be what? Sine B divided by B, right? So making B the subject, it will be the same as what? Cross multiplying. So it's going to be B sine A is equals to A sine B, which is the same as B is equals to A sine B divided by B. Do you see? And you have all the values here, or sometimes it will say in terms of something, or you have all the variables, right? So do you see the fact that that's how you would see it, right? So remember the fact that to know whether you're using sine, if you go from the angle, drawing a line, and you have that side and taking another side, right? Drawing what you call is going from the angle, going to the side. If you see the fact that from the unknown, you have only unknown, then you can use the sine rule, right? So now that's how the sine rule you're going to use it, right? So let me just leave it here, right? So now let's talk about the cos rule. And I'm just going to do it with a different color with the cos rule. The cos rule, you need what? You need two sides and the included angle. Very important. It's two sides and the included angle, right? So what do I mean two sides? Let's say now we have C missing, right? And now to use the cos rule, you need how many? Two sides and an included angle. So meaning they need to give you what? If this one is missing, they need to give you the following. And I'm just going to highlight it in green, right? They need to give you B. They need to give you A. and the included angle is C. Do you see the fact that why I'm saying included? Do you see the fact that B and C, the sides, the angle is in between the two sides that they gave you? Then if that's the situation, then you can solve for C. Do you see that? And if we go in the diagram this here, do you see the fact that is what you call this is C squared is equals to A squared plus B squared minus AB cos C, the included angle. So if this side is given, right, it's what you call this, it's missing. You need what? You need two sides and the included angle. And two sides and the included angle, that's the only way you can solve it, right? So this is going to be the one that's unknown. Obviously, it's going to be the one that's opposite. The side is going to be opposite to the angle, right? So remember the fact that if you have two sides and included angle and you want this, that's how you would solve it. And it's going to make sense when we do questions, right? So that's how you would use the cos rule, right? So this one, it's opposite sides, right? And opposite angles for the sine rule. Opposite sides, opposite angles. That's what you need to be given, right? Then with the cos rule is what is the included side, right? Is what is the two sides, sorry, is the two sides and the included angle, right? Two sides and the included angle. So with area, yeah, with area, right, you're going to need the following. With area, you're going to also need the same thing that you need for cos. It's going to be, if they want the area of anything, like it could be any triangle and you're given, to find the area, you need two sides and included angle. So in this case here, do you see the fact that if maybe we given this one, and you need this angle. So you can find the area there, meaning it's going to be what? It's going to be a half, then you're going to say AB. Do you see that? It's going to be a half AB sine C. Do you see the fact that also area works with what you call this, two sides and the angle that's in between the two sides. Okay? So that's how you need to understand basically how to basically work with the formulas. So now we're going to do the first question, right? It says point B, C, and E lies on the same horizontal plane, right? And they tell us the fact that A, B, C, D is a what? Is a rectangle, right? It's a rectangular part of the board. And they tell us the fact that CDE is the triangular part of the board, right? Having a right angle, right, at C. So we see the fact that at C, we have the right angle, right? Then they say each piece of the board is placed perpendicular to the horizontal plane and joining along BC as shown in the diagram. So everything that they're talking about here is shown, right? Then they tell us the fact that the angle of evolution from E, right, to D is what? They tell us the fact that it's X. So we have the fact that that is X. Then they tell us the fact that BEC is equals to 2X. They tell us that. Then they tell us that EBC is equals to 30, which is labeled, which is nice because of they label everything, right? So now the first question, it says what? So let me just do this. The first question, it says, show that DC is equals to BC divided by 4 cos squared X, right? So every time when they ask you to show something, right? And with this one, they tell you what you need to show, right? You look at what they want from you and you write down the information, right? So what do we see? We see the fact that we're looking for what? We're looking for B, what you call this? We're looking for DC. So we know the fact that we're looking for this one, right? So I'm going to just put a cross there, right? Now I'm going to mark here the things that they want, right? Our answer needs to be in terms of BC. So we see the fact that our answer needs to be in terms of this, right? So our answer needs to be have BC in it, which is I just put a tick there. And also, if you notice, is that our answer, right, needs to have some X. Where is X? X is here. Do you see that? Right? And also X is where? So X is this one, and also X is where? X is here, right? Then looking at our diagram, right, we're going to look at the given information, right? So we see the fact that we given, and I'm going to highlight the given information because the given information tells us which formula to use. We see the fact that we have this 30, right, as the given information. We also have what? We also have this 2x that's given. We have this x, right? and that's it, right? And this 90 degrees things, right? So now remember the fact that we're looking for in this one. And very crucial, we're looking for this one, right? So if we're looking for B, right? If we're looking for what you call this, BC, right? And we look at the given information, which triangle between A, and I'm going to highlight it, right? I'm just going to highlight the two triangle that I'm talking about, right? Which triangle between the two? Which triangle between this triangle, right? Do you see this one? The right angle triangle. Where that's where, if you think about it, that's where we're going to get our BC, because our BC is there, right? Compared to this triangle. So this triangle, the other one, right? This one. First, which triangle has more information? Do you see the fact that it's actually the green triangle, right? And the nice thing is that the green triangle has a part of what our solution should have, right? And what do we know? What is the relationship between the green triangle and the orange triangle? Do you see the fact that they share the same side? This is what they share. So do you see the fact that they share the same side? And this is the side that they share. Do you see the fact that this side is what they share, the one that I'm emphasizing? So from the green triangle, I can find this side, use this side, and use theorem of Pythagoras to basically find DC. So that's what we're going to do, right? So for 7.1, right, as I said, the fact that we're going to use the green triangle because of it has most information. From there, we're going to relate it to this orange triangle because of our length that we want is from the orange triangle. I hope that makes sense, right? But now looking, and I'm just going to take it out, right? I'm going to take out this green triangle, and we're going to analyze it in terms of the information that they gave us, right? We know the fact that this is C, right? And this is E, and this is B, right? And this is 30. This is 2x, right? And this, we don't have it, right? So that's what we know, right? So looking at this, remember the fact that we want BC, right? We want what? No, we don't want BC. We want CE. And reason why we want CE, because of it's a common side, I can use that side to basically find what you call this DC, because of we're going to use Pythagoras rate, right? So I'm going to put a tick here, right? So looking at that, what information do you know? We know the fact that again, our answer, right? Our final answer needs to have what? It needs to have BC. So I'm just going to put this scribble like this, right? This needs to be part of our answer. So our answer can have this, right? So now looking at that, right? So let's say this is given. So this side is also given. So this side, it can be given because of our answer needs to be in terms of what? It needs to be in terms of BC, right? So now with that said, right? With me saying all that, right? So let me just take my pen. With me saying all that, right? So we know the fact that the green side is given. We know that the angle 30 is given. The 2x is given, right? So now let's relate. Let's first check out, can we do sine, right? If I do sine, if I do this, right? So I know the fact that this 30 degrees is going to link with CE, which is what I want. And we know the fact that this angle 2x is going to link up with what? With BC, which is what I want, right? So, and I want my answer to have BC. Do you see the fact that sine here would be the perfect one to use, right? Because if I had to use, if I had to use cos. Do you see the fact that I can't use cos because of I need this side and this side, right? And our answer does not have BE. So I can't even use this side. But we only need BC, right? So do you see the fact that, and the included angle, that one is perfect. But do you see the fact that our answer does not have BE? So we cannot use cos because of its two-sided and the included angle. Our answer does not have BE, but it have BC. So we can't use cos, but we can use sine, right? So with that said, we know the fact that it's going to be what? It's going to be the same as sine, right? And this angle here, which is this angle here, the 31. So it's going to be CBE, right? And that's going to be divided by what? When you draw a line across, it's linked to CE, right? And that's going to be equals to what? It's going to be equals to sine this angle here, which is CE, right? CEB. And that's going to be divided by what? That's going to be divided by, when you draw a line across, is linked to BC. So part of our equation is sorted. We have a BC, right? So now we're just going to substitute values. So we know the fact that this one is the same as sine 30, right? So sine 30 degrees divided by CE is what I want, because that's the common side, right? And that's going to be equals to, this one is going to be sine, then this is going to be 2x, right? And this is going to be divided by what? It's going to be divided by BC, which is what I want, right? So cross multiply, I'm going to have the following. I'm going to have BC multiplied by what? By sine 30 degrees is equals to what? 2CE, then this is going to be sine 2x, right? So I want CE alone because that's the one that I want. So it's going to be the same as BC, then it's going to be sine 30 degrees, right? It's going to be divided by what? It's going to be divided by sine 2x is going to be equals to CE, right? So that part is sorted. We have that, right? So we know the fact that this part is equals to what? It's equals to this value, right? So now we're going to go to this orange triangle, which is a right angle triangle. Do you see that? So we're going to go to that triangle, right? And this is D, this is C, and this is E, right? And this is 90 degrees, right? So remember the fact that we're looking for this, right? And now we already have the value of this, right? And this is X, right? So now with everything that I have, I can use what? I can use trig ratios to basically solve for this, right? So what do we know? We know the fact that since we want this and we have this, what is that? That is opposite, right? And this is adjacent. So this is opposite and this is adjacent. What's opposite and adjacent? That's 10. So this is the same as looking for 10, right? 10x, because this is x, the angle is x, is equals to what? Is equals to what's opposite is DC, what we actually want, divided by what? By CE, right? So now we know the fact that it's going to be 10x. We need to make what? DC the subject. So multiply that side. So it's going to be the same as CE is equals to what? It's going to be CE multiplied by 10x, right? Is equals to DC, right? So now with that said, I can substitute what? I can substitute this CE that we found, right? So this is going to be the same as saying BC, right? And this is going to be sine 30 degrees, right? Divided by what? Divided by 2x. And this is going to be multiplied by 10x, right? It's going to be equals to DC, right? So DC, I'm just going to write it here. It's going to be equals to, let's change this, what you call this? This, no, let's not change it yet. This sign, right? I'm going to change, I'm going to put an identity here. We know, I'm going to put an identity here. This is cos, this is sine, sorry. This is sine 2x, right? So I'm going to substitute an identity here and an identity here. So it's going to be what? It's going to be BC multiplied by sine 30 degrees. This is going to be multiplied by what? By what we have. It's going to be sine x, right? Divided by cos x, right? And this whole thing is going to be divided by the following. It's going to be divided by 2, right? Sine x, right? So it's going to be 2 sine x and it's going to be cos x, right? So this again is going to be what? We're going to have the following. So now we're going to have the following. So this, I'm going to change it now. So I'm going to get rid of the numbers because of sine 30 is a number in 2. So if I say sine 30 degrees, right, divided by 2, I'm going to get 1 over 4. So this is going to be the same as DC is equals to 1 over 4. So it's going to be BC. Then this is going to be multiplied by sine x cos x, right? And this is going to be divided by 4, right? Then this is going to be divided by 4. Then this is going to be what? This is going to be 4. Then this is going to be sine x. Then this is going to be cos x, right? So now, I don't have space. Let me just move in this direction. I'm going to start way here, right? So with that said, I'm going to take this one and I'm just going to divide it here, right? So this is the same as saying B, DC, right, is equals to what? Is equals to the following. It's equals to, when I say B, C, right, multiply by what? By sine, right, sine x divided by what? By cos x. And let's just do this, actually. Not to complicate things. Since here, this one is the numerator, so I'm going to multiply BC, right? So I'm going to multiply BC with what? With sine x. So it's going to be sine x like this. And this whole thing is going to be divided by cos x, right? And that is going to be what? It's going to be the same as divided by, when I change this one, it's going to be what? It's going to be divided by 4 sine x. Then this is going to be cos x, right? So that is the same as changing this one, since it's in the numerator. It's the same as saying DC is equals to B, C multiplied by sine x divided by what? Divided by cos x. And this is going to be multiplied, since it's in the numerator and the denominator is 1. It's going to change and it's going to be what? It's going to be 1 divided by what? By 4 sine x. Then this is going to be multiplied by cos x, right? So do you see the fact that since it's multiplication, the signs are going to cancel out? So your answer here in the numerator, you're going to be left with BC divided by what? By 4 cos squared x, which is exactly what they want. So that's how you would do this question. So now we're going to do 7.2, right? So we're doing 7.2. It says what? If x is equals to 30 degrees, show that the area of ABCD, right, is equals to 3AB all squared, right? So now we're going to do that. So let's do the following. So we're looking for the area of, I'm going to highlight what we're looking for the area. So we're looking for the area of this rectangle, right? So this rectangle is the area that we're looking for, right? And I'm just going to take it out from there, right? Because I like working with things outside them, right? So if I look at this, so I can evaluate the information that I'm given, right? So we're looking for this area of this triangle. So this is going to be A, this is going to be B, this is going to be C, and this is going to be D, right? So this is going to be D. Yes, D, right? So we are given the fact that BC, which is this one, right? We know the fact that DC is equals to what? Is equals to BC divided by what? Divided by 4, what? 4 cos squared x. But we know that x is 30, right? So it's the same as DC is equals to BC divided by what? By 4 cos squared 30 degrees, right? So punch that into the calculator, the 4, right, open bracket and say cos 30 degrees, then all squared is going to give us what? It's going to give us 3. So we know the fact that B, not BC, DC is equals to BC divided by what? Divided by 3, right? So do you see the fact that our answer needs to have AC? So we know that AB, so our answer is going to be this. Then we're going to need this length here, right? Our answer needs to be in form of AB, so that's sorted. So that's like given. Then it needs to have BC. But what do we know about the relationship about BC? Is that we know the fact that DB is equals to what? Is equals to BC divided by 3, right? So now I can take 3 to the other side. So it's going to be 3. DC is equals to what? Is equals to BC, right? So we know the fact that this one is going to be equals to 3BC. But what do I know about BC, right? Is that, do you see the fact that since this is a rectangle, we know the fact that those two sides are equal. So I know that, and I'm just going to write this, right? I know the fact that AB is equals to DC. And that's because of this is a rectangle, right? Opposite sides are equal. So if that's the case, now I can basically find the area of this side. So what's the area? So the area, right, of, because I have this side, right? And I have it in terms of what? I have it in terms of BC, right? Because I know the fact that if this is AB, so this is going to be the same as 3AB. Because remember the fact that AB and BC is equal to each other. So this is going to be the same as that, right? So now with that said, I can find the area of what? Of A, so of A, B, C, D, which is going to be the same as length times breadth, right? So it's going to be what? It's going to be, our length is AB. So our length is going to be the same as AB, right? Multiplied by what? By BC. So it's going to be multiplied by BC, right? But we know the fact that BC is equals to 3AB. So that's going to be AB multiplied by what? By 3 times AB, right? So answer here is going to be 3AB squared, which is exactly what they want. And that's how you would get your 3 marks. So now let's do question 2, right? It says, a landscape artist plans to plant flowers within 2 concentric circles around a vertical line pole PQ. So we see that there is a vertical line PQ. R is a point on the inner circle. So we see the fact that R is a point of the inner circle, meaning the circle that's inside, and on the inner circle. And S is where? So they tell us the fact that S is a point on the outer circle, so it's outside, right? And they tell us that Q and S lie on the same horizontal plane. So they tell us that Q and S, right, lies on the same horizontal plane. And they tell us more the fact that RS, right, is the pipe used for the irrigation system in the garden, right? So they tell us the fact that the radius of the inner circle is the small r. And they tell us the fact that the radius of the bigger circle is QR. So it's this one, right? Then they tell us that the angle of evolution from S to P is 30 degrees, which is written. Then they tell us the fact that RQS is equals to 2x. Again, it's given here. Then they tell us the fact that PQ is equals to square root of 3r, right? So with that said, now with all the information that they gave us, let's go and answer the questions, right? So 7.1, it says, show that QS is equals to 3r, right? So meaning, whatever we do, we need to make sure the fact that QS is equals to r, right? So now, where's QS? So we know the fact that QS is this one. Do you see that? Is this one, which is the radius of the what? Of the bigger circle, right? So we see the fact that this is within this triangle. Do you see the fact that is within this triangle, right? So if I had to redraw this, right? I like redrawing because of I get to see the information properly, right? So this is P, this is Q, and this is R. And this is 90 degrees, right? So we are given that this one is 3R, right? And we're looking for what? We're looking for this side, right? And we are given the fact that this one is 30 degrees, right? Do you see the fact that I can use trig ratios to basically solve this one, right? So from this side, I know the fact that this is opposite to one given side, which is this one, and the one side that we want, which is QR, is this one. So if this is opposite and this is adjacent, then what are we going to use? We're going to use 10, right? So here it's going to be 10. What is our angle? Is 30 degrees. So it's going to be 30 degrees is equals to what? Is equals to opposite, which is going to be what? Which is going to be PQ divided by what? By adjacent, which is going to be QR, right? So now we want QR as the subject. So we're going to multiply it first. So it's going to be QR multiplied by 10. 30 degrees is going to be equals to PQ, right? So divide both sides by, by 10, 30, because I want QR alone, right? So this is going to be the same as what? As QR, not QR, man. It's not QR, it's QS. So this whole time I've been saying QR. So this is QS, right? I'm looking for QS. So this is QS, right? So this is going to be QS, right? So this is QS. Even here, let's just fix that. This is QS, right? So this is going to be QS, right? So this is going to be QS. So this is going to be QS 10, right? 30 degrees. So it's going to be basically QS. Want that to be the subject. So it's going to be QS, right? So it's going to be QS is equals to PQ divided by what? By 10, 30 degrees, right? So now we already know what's PQ, right? PQ is what is 3 root R. So we know the fact that this is going to be QS is equals to root 3 R. And this one, when I find it in the calculator, it's going to be what? It's going to be 10, 30 degrees, which is I'm going to get root 3 divided by 3. So this is going to be the same as what? As Q is equals to what? Is equals to, when you say root 3, right? Divided by what? Divided by root 3 divided by 3. You're going to get your answer as big 3. So this is going to be exactly equals to 3. Then this is going to be R. So which is exactly what they want from you, right? So that's how you do 7.1. So now moving to 7.2, they tell you the following, right? They tell you the fact that determine in terms of R, right? The area of what? Of the flower garden. Where is going to be the flower garden? Let me erase this. The flower garden is the following, right? Flower garden is the following. It's this. Do you see the circle? The one in blue. That's the flower garden, right? So how would you determine that area, right? So the area of the flower garden is going to be big circle. So area of the garden. So I'm going to say area of the flower garden of flower garden, right, is equals to what? It's going to be equals to the area, right? So it's going to be the circle area of the big circle minus, which makes sense. So you find the area of the big minus the small, which gives you that region, right? So it's going to be area of big minus area of small, right? So since the area we're dealing with circle is the same as pi r squared of big minus pi r squared of small, right? So remember that the radius of the big circle is what? It's actually QS. So this is the radius of the big circle, and the radius of the small circle is just what? It's just this R, right? Which is RQ. So we know the fact that it's going to be pi R. Our R, let's substitute, is, as I said, the fact that is QS. So it's going to be 3R all squared minus the radius of the small. So it's going to be the same as pi R squared, right? Because it's R. So here we're going to have the fact that distribute the square. This is the same as 9, right? 9 pi R squared. And this is going to be minus pi R squared. So this is, because they are common, we have pi R squared and pi R squared. So when we add them together, it's going to be 9 minus 8, which is going to give us 8 pi R squared. And that's how you would answer this question, right? So now, moving on to question 7.3. It says show that RS, so let's find RS first. We're going to highlight it, right? So let me just highlight it with a different color. Where's RS? RS is going to be this one, right? It says show that RS is equals to 10 minus 6 cos 2x, right? So we see the fact that our answer has what? Has cos 2x. So meaning this needs to be there, the cos 2x, right? And the nice thing is that we know the fact that this section is R and this section is what? Is given as 3R. So I can use this triangle, this yellow one, the one that I'm highlighting right now, to basically solve for RS, right? So I'm just going to replicate it here. So this is going to be 7.3. So if I'm going to have this triangle like this, so I'm going to have the following. This is going to be Q, right? This is going to be R, and this is going to be S, right? Remember the fact that we're looking for this one, right? So we have 2x here, right? Then here, remember the fact that we have R and we have calculated QS, which is what? Which is 3R, right? So now let's look at the information that we're given, right? Let's check whether can we use sine. With sine, remember the fact that it's linked to this one. If I use sine, is that I need this one, right? Which is sorted. Then either between R and 3R, I need an angle. Do you see the fact that, this one, we don't have an angle, right? Even this one, if we use this R, do you see the fact that we don't have a R and we don't have angle R, we don't have angle S? Do you see the fact that sine is not going to work here? So here, sine is not going to work, so I'm going to erase that. Because do you see the fact that when I draw lines from the angles to the side, we only have the side, right? And even here, we only have the side, right? So now we're going to move to what? We're going to move to what? We're going to move to checking whether can we use cos, right? So with cos, what do we need? Since we need this side, we have its angle, so that's sorted. But we need the 2 included side, right? Do you see the fact that we're given R and we're given 3R, right? So because we have calculated that. So we can use cos there, right? So remember the fact that we're looking for RS, right? So it's going to be RS squared is equals to the 2 sides. So it's going to be QR squared plus what? Plus QS squared. And this is going to be minus 2. Then there's 2 sides again. It's going to be QR, right? Then here's going to be QS. Then it's going to be cos. Then the included angle, which is I'm going to just substitute as 2x, right? Because I'm kind of lazy to rewrite it as the actual angle, right? So now let's substitute the values here. So we're going to have the following, right? So we're going to have the fact that QR is the same as R squared. Then this one is the same as 3R all squared minus 2. Then this is going to be what? R. And this is going to be 3R. Then this is going to be cos 2x, right? So now we're going to have the following. We're going to basically simplify this. This is going to be R squared plus 9R squared. Then this is going to be what? Negative 2 multiplied by 3, which is going to give us what? Negative 6. R squared, and this is going to be multiplied by cos 2x, right? Add this together, we're going to have 10R squared, right? And this is going to be what? Minus 6R squared. Then this is going to be cos 2x, right? So this is going to be R squared. Then this is going to be RS squared, right? So now we're going to take out R as a common factor. So it's going to be RS squared is equals to R squared, open bracket. We're going to have 10 minus 6. Then this is going to be cos 2x, right? So now with that sorted, right, this is going to be what? We're going to square both sides. So this is going to be RS is equals to the square root of everything here. So it's going to be what? It's going to be R squared. Then open bracket is going to be 10 minus 6 cos 2x, right? So since we have a square root and these two are multiplying, I can distribute the square root. So this is going to be the same as the square root of R squared, right? And this is going to be the same as the square root of 10 minus 6 cos 2x, right? So here our answer is going to be the square root and the square is going to cancel out. So you're going to have R. Then this is going to be inside the square root of what? Of 10 minus 6 cos 2x. So now we know that RS is equals to that. So we got exactly what they wanted, right? So now we're going to move to what? We're going to move to 7.4. It says if R is equals to 10, right? 10 meters and X is equals to 56, calculate RS. So taking this one, so for 7.4, taking this RS, so we know the fact that RS is equals to, they gave us R, which is going to be 10, right? Then it's going to be the square root then it's going to be 10 minus 6, then this is going to be cos, then it's going to be 2 multiplied by x is equals to 56, right? Then if you punch that into your calculator, you're going to get your answer as being what? You're going to get your answer as being the following. It's going to be equals to R is going to be equals to 34,9, right? So which is approximately, RS is going to be approximately equals to 35 meters. So that's how you would answer this question. So now we're going to do question 3, right? It says what? It says in the diagram below, shows a solar panel A, B, C, D, which is affixed to the flat piece of the concrete slab, right? Then they tell you the fact that EFC, right? So it's fixed on that gray part, which is the concrete slab, right? And they tell you the fact that A, B, C, D, and EFC are two identical, meaning they are exactly the same thing, right? Two identical rhombus. What is a rhombus? Is a square that is sliced, meaning opposite sides are equal and everything is equal. So since with that information, since we know the fact that this side is x, do you see the fact that we're given that this side is x? That means this is going to be x. That means this is going to be x. That means this whole side here is going to be x. I'm just going to put it here. Then that means that this side is going to be x. This one is going to be x. And this one is going to be x, right? And this, since, do you see the fact that there's a midpoint, meaning this is going to be a half x, and this one is also going to be a half x, right? I'm just putting the information since we're talking about a rhombus, and they tell us the fact that K is a point on DC. So it tells us the fact that K, right, is a point on DC such that DK, right, is equals to what? 2KC. So K is the midpoint, right? As I already filled in, because of half of x is going to be basically x divided by 2. And x divided by 2, when you add them together, you're going to get half. You're going to get 1, which is going to be the entire this thing, right? Then they tell us the following information. They tell us the fact that AK is perpendicular to DC, which is they already have it here. So even this side is going to be 90 degrees, right? Then they tell us the fact that AF and KF are drawn. Then they tell us the fact that ADC is equals to what? Is equals to CDE. So is ADC. So the 60 is equals to what? Is equals to, where C is here, CD. So it's going to be CDE. No. So this one is already labeled. So it's going to be A, which is this one. It's going to be equals to A, right? Then that's going to be D. And then so it's going to be ADE, right? So that's already written there, right? So we know the fact that these two are both equals to 60. Then they tell us the fact that AD is equals to x, which is we already put all the necessary information that is equals to x, right? So now moving to the first question. It says determine AK in terms of x. When they say determine something in terms of x, it should be no other variable besides x, right? So let's check what they want. So I'm going to highlight what they want. So what do they want? They want AK. Where is AK? It's here. It's this one, right? Do you see the fact that AK is where? It's here in the right angle triangle, right? And the nice thing is that this right angle triangle has all the information that we need, right? So again, I'm going to reproduce this. So we're going to have this triangle like this. And this is A. This is K, right? And this is D, right? So we know the fact that this is 60, right? This is a 90. And this is x, right? And what are we looking for? We're looking for AK. So we're looking for this one, the one that I put a tick, right? So related to that, obviously our angle is going to be this one. So it's going to be opposite, then over hypotenuse because it's opposite the square, right? So it's going to be opposite over hypotenuse. So this is the same as, which one has opposite over hypotenuse? So this is opposite and this is hypotenuse. It's sine, right? So we're going to have sine 60 degrees is equals to what? Is equals to opposite. Our opposite is A. K, what we want, divided by what? by AD, which is x, right? So take the AD to the other side. So it's going to be AD, right? And it's going to be sine 60 degrees, right? It's going to be equals to AK. So AD is x. So this is going to be x sine 60 degrees is equals to AK. So therefore AK, if you substitute sine 60, it's going to be equals to it's going to be equals to the root 3 divided by 2. Then this is going to be what? Multiplied by x. So do you see the fact that our answer AK is only in terms of x, right? So now moving into 7.2, they want us to write the size of what? Of KCF, right? So they want us to write the angle of K, where's K? It's here, C is here, and F is here. So this is the angle that they want, right? So this is a rhombus. What does it mean? It means the fact that opposite sides are also parallel, right? So since the opposite sides are also parallel, what does it mean? It means the fact that, do you see the fact that we have a property of what? And I'm just going to highlight it. Going to highlight that. So we have a property of what? Of co-interior, right? What do we know about co-interior angles? They are supplementary. So now if I say what? If I say angle, right? So if I say, so let's say since, right? Since DE is parallel to what? Is parallel to CF, right? What do we know? We know the fact that this angle here, and I'm going to name it, which is going to be ED and C plus this angle here, right? The one that we want, which is going to be KCF, is going to be equals to 180 degrees, right? And I'm just going to write this. Reason is not compulsory. I'm going to write the reason for you guys so that you can know why we're saying that. That's co-interior angles, right? Co-interior angles are supplementary, meaning they add up to 180 degrees, right? So this is going to be 60, right? And this is going to be plus what we want, which is KCF is going to be equals to 180 degrees. Take the 60 to the other side. It's going to be KCF is equals to 180 minus 60, which is going to give you 120 degrees. So we have that as 120 degrees, right? So we sorted with that one. Then the last question, which is 7.3, it says the following. Let's just do it here if we need more space, right? So with 7.3, it says the following, right? It says, if it's further given that AKF, right, the angle between the solar panel, right, and the concrete slab, right, is Y. So we know the fact that, what you call this, A, so let's go find that. A, so A is here, right, A, and then AK. So it's going to be what? Which angle is going to be AKF, right? So this whole entire angle, right? So they're saying this entire angle is equals to Y, right? Then they say determine the area of the triangle A. So I'm going to highlight the triangle before I take it out, right? So let's highlight the triangle before we take it out. So the triangle A, we want the area of the triangle A, which is here, which is K is here, and what? And F, which is here. So we want the area of this triangle. Right? So this is the area of the triangle that we want. Right? So that's the triangle that we want, right? The area of that. So now let's basically draw that triangle. So this is going to be like this. Right? So this is going to be, why am I slanting it? So this is going to be straight like this. So it's going to be like this. And this is going to be like this. And this is going to be like this. Right? And then it has a couple of components. Remember the fact that it has the C. And I'm just going to probably need it. So I'm just going to, we know the fact that this is C here. And this is 120. Right? And we know what? We know the fact that this whole thing is Y. Right? And we need to determine what? Determine the area in terms of X and Y. So this Y needs to play a role, right? So we know the fact that this is A, K, and this is F, right? So what do we know? We know that this portion here is half. Remember the fact that it's half. KC is a half X, right? And what do we know again? We know the fact that this whole CF is X, right? So now with area, if we need to use this Y, we need this side and we need this side, right? Because it's two sides and the included angle. So now we have this side, right? We already know what is AK. We know the fact that AK is equals to root 3 divided by 2x. But the problem is this one, right? Is KF, right? So we see the fact that KF is within this triangle. And I'm going to just reproduce it, right? And I'm producing it so that you can see it properly. No eraser, right? So it's within this triangle, right? It's within this triangle here. The one that we found there, 120. So this is going to be 120. Then this is going to be a half x, right? And this is going to be what? It's going to be the side, which is going to be just x. So do you see the fact that with this one, and we want this section, because we want this KF, and this is C, right? We want this KF because of this KF is one of the side for the areas, right? So we need to solve for this. Then after solving for this, we can basically solve for the area. So let's solve for this side. So we can substitute and solve for the area. Now, so now what we're going to do is the following, right? So let's solve for this, right? So what do we see? We see the fact that we have this and we have its angle, right? Do you see the fact that we have the angle and the included side, right? So that's perfect. So what does it mean? We can use what? We can use the cos rule, right? Because we have two included side and the angle and the side that we want, right? So this is going to be equals to what? It's going to be equals to K F squared is equals to what? Is equals to C F squared, right? And this is going to be plus CK squared, right? And this is going to be minus 2 CF, right? Then C multiplied by CK. Then this is going to be cos of the included angle. So this included angle is going to be what? It's actually KCF, right? Substitute everything. This is going to be KF squared. Is going to be equals to what? It's going to be equals to the following. It's going to be, this one is going to be X squared, right? And this is going to be X divided by 2 all squared, right? And this is going to be minus 2. Then this is going to be X. And this is going to be X divided by 2. And this is going to be cos. Then this is going to be 120 degrees, right? So now with that said, right, it's going to be KF squared. This is going to be X squared. And this is going to be X squared divided by 4. Then here's going to be what? The negative 2 multiplied by a half is going to be basically 1. So it's going to be minus. Then this is going to be X squared. And this is going to be cos 120, right? So let's find cos 120, right? So we're going to say KF squared is equals to X. When you say X squared plus 1 over 4, you're going to get 5, right? X squared divided by what? Divided by 4, right? And this is going to be minus X squared. When you find cos 120, it's going to give you negative 1 over 2, right? So this is going to be the same as what? This is going to be the same as 5 over 4 X squared. Then a negative and a negative is going to give you a positive. Then this is going to be X squared divided by 2, right? So this is going to be equals to what? So your answer here is going to be equals to, add them together, is that we're going to have that, what you call this, KF squared is going to be equals to 7, right? 7x squared divided by what? Divided by 4, right? But remember that we need the following. We need just KF, right? So KF is going to be equals to the square root, right, of what? Of 7x squared divided by 4, right? So that's going to be equals to root 7. Then it's going to be x, right, divided by what? Divided by 2. So this is going to be what? KF is going to be equals to. So now let's just go to the next page. What I mean is going to be like this. So we're going to have, I'm just going to redraw this diagram. now having your KF. So we know the fact that AK, right? We know the fact that AK is root 3x divided by 2, right? So this is AK, right? We know that this whole thing is Y, right? And we know the fact that this is F, and we already calculated this. And when we calculated it, we had root 7 over 2. So we had root 7 over, let's go up again, x divided by 2, right? So now we have that, right? So what is the area of this? Remember, it's what you call this two sides and the included angle. So this is going to be the same as the area of triangle. Let's name it. It's going to be AKF. It's going to be equals to the following. It's going to be equals to a half. Then it's going to be the size that we have, which is going to be AK multiplied by KF. And the included angle is what? It's going to be sine Y, right? So now it's going to be what? It's going to be a half. Then AK is what? AK is going to be root 3, right? X divided by 2. Then this is going to be what? This is going to be root 7, right? X, and this is going to be divided by 2. And this is going to be sine Y, right? So now that means that your area is going to be what? It's going to be the square root of 21 x squared, right? Then it's going to be sine Y divided by what? Divided by 8. So this will be your area.